Okay, so good afternoon, everyone. So I hope I'm audible. Please do let me know. So am I audible or not? If I'm audible, then I think we can start today's session. Anyone of you can let me know if I'm audible. Okay, good. Okay, so then we can start today's session. As you know, we have been discussing this NPTEL-based NPTEL assignments specifically related to this GATE examination. So today, as you know, I will be discussing with you questions from production and industrial engineering portion, and I already told you the areas which are going to be covered today. Let's hope it's going to be a fruitful session for you. So let's get started with the questions. Okay, so assignment is already with you. The soft copy or maybe hard copy, depending upon how you have taken it. So let's start these questions one by one. And as you know, it's going to be a long session. Need your patience. My patience also I need to have good. Okay, so here's a question. I think. Okay, go ahead. So this is related to your what true strain in this case will be, right? So a 60 mm long mild steel bar has been elongated thrice by this much amount, and you are supposed to find out the true strain. So in parallel, you can also try. There are going to be many questions which will not take much time. So only somewhere if explanation part is required, that I'm going to explain you. So as you know, if you see it very simply, then let us say if you are having 60 mm, then you elongate it by once, twice, let us say, and then thrice. Okay, and each time you are going to have 0.5 mm. Okay, so this is second time, third time, and this is first time, right? And initial length you're going to have the 60 mm. This is how the situation is. Let us say. So now he's asking you to find out the true strain. So true strain, as you know, you need to know one property of the true strain. I think hope you may be knowing that when there is a sequential process, when you deform a particular component bar sequentially from one stage to another, then total true strain, obviously he's asking the total true strain. Either you can calculate the true strain directly, like final, let's say this is the initial or original dimension, let's say original length, and this is the final length, let's say. So you can directly get it done. Okay, what is the true strain? You will say total true strain is going to be natural log of final length to the original length or initial length. This is going to do the job. As simple as that. If you will do it that. So what is the final length? As you know, this becomes 1.5 plus 60. So 61.5. This becomes the final length. This length divided by the initial length, which was 60. So this is going to give you the true strain, and which is going to be how much? 0.02469. So that's all. This is the answer for this. Okay, that is all that we need to do. But at the same time, what I told you is that in case of true strain, it is having one property called as true strains are additive in nature. Additive in nature means what? That even if you, for example, calculate the true strain individually for individual these steps, and if you simply add them up, then also you are going to have that total true strain. That means, for example, what does that mean? It means that I say if I want to calculate the true strain, I can also calculate it is also going to be equal to the true strain in first step, true strain in second step, plus true strain in third step. So either you calculate it individually and then add them up, then also you're going to get this answer, or if you want to get it directly done, then also you're going to get the same answer. But this is not the same case in case of the conventional strain. So this is a property that you need to remember, and it's going to be useful for you depending upon how he's going to frame the question for you. For example, if I say that what is the conventional strain in this case, you will say total change in length from initial step to the final step to the original length, maybe this one. This total strain, if I will calculate conventional strain, if I will calculate this way, is not going to be equal to E1 plus E2 plus E3. That means if I will calculate conventional strain in step 1, conventional strain in step 2, conventional strain in step 3, and if you will add them up, then it is not going to be equal to the total conventional strain if I will calculate from this particular formula. So it means this particular convention state doesn't have the additive property. This is not additive in nature, whereas this is going to be additive in nature. So that you can just cross check also. One other way also verifying this is like, if I call it as L0, I will call it as L1, L2, L3. Okay, this is final. So if I say what is the true strain, okay, I'm just omitting it now, just to, for example, if I say what is the true strain in this step, epsilon 1, you will say natural log of what? L1 by L0. Because L0 is the instantaneous stress when you deform it from here to here. So this divided by this. What is the epsilon 2? Now when you deform from here to here, then this becomes the instantaneous length, then it is going to be natural log of L2 by L1. Same way, if I go for the step 3, then what is going to be? This becomes the instantaneous length for this third step. So it is going to be natural log of what? LF by L2. And as you know, if I add them up, then these terms are going to be multiplied inside. L1 will cancel out. Then you are going to have L2 will cancel out. You are going to left out with LF divided by L1, which is, sorry, LF divided by L0, which is the same as this. So it means I can say this is have the property called as additive in nature, right? And also one more thing, if you want to note, depending upon, because in wire drawing normally you are going to have these kind of questions which are normally framed to check your understanding, and also because you're elongating them by the same amount. So if I find out the true strain for any of these steps, it is going to be the same. For example, if I calculate the true strain for this step, this one, this is also going to be equal to the true strain for this step. It is going to be equal to the true strain for this step because I am elongating them by the same amount. So I can also write in this case, that is the total true strain will also be 3 times epsilon 1, or maybe you can say 3 times epsilon 2 or 3 times epsilon 3, depending upon how you understand it. Okay, so that is all that I need to tell you. So this is going to be a very handy property that I discussed with you regarding the true strain and the conventional strain. Otherwise, this question is relatively easy. Okay, let's now go to the next question. See this. You're having in case of hot working process, see which one is true. So simultaneously you can answer also, keep on answering, right? It says that if it is a hot working process, which one of them is going to be correct? Simultaneously recovery takes place with the deformation, strain hardening takes place continuously, metal is heated just below the recrystallization temperature, and you already know that CAA, you are saying, okay, you already know that in hot working, what we do is we heat the material above the recrystallization temperature, and when we heat the material at above the recrystallization temperature and at that state we are deforming it, then obviously since it is already above the recrystallization temperature, then those deformed grain will immediately get broken down, and therefore you will not going to have the elongated grain structure. So that is why if you see, this is a kind of state that you are having. For example, this is a state of cold working, right, where when you deform a material in cold state, you're going to have the elongated grains, right, below recrystallization temperature. Now just have a look over here. When you're I want to make use of one here. This is something term used as dynamic recrystallization. For example, these are the, now keep it in mind, the recrystallization, the temperature of this particular bar is above recrystallization temperature. Then only we can say that this is a hot working process. Now when we are deforming it, had it been a cold working, these would have got elongated. But as soon as they get elongated by deformation, dynamic recrystallization, because temperature is above the recrystallization temperature, immediately that elongated grain structure will be broken down and new crystal will be formed. So that is why we say that there is no elongated grain structures and recrystallization takes place simultaneously, which we call it as a dynamic recrystallization. So if that you have in mind, that means then obviously you can answer this question now, that simultaneous recovery takes place with the deformation. Simultaneous recovery, that means grain structure breaks down immediately. Strain hardening takes place continuously. Keep it in mind, in cold forming, you always have a situation where strain hardening is taking place. That means strength is getting increased, indirectly you can say. But in this case, in hot working, there is no strain hardening. Reason for that, I think, reason for that is why strain hardening doesn't take place. Main reason for the strain hardening is the dislocations, right? But when you go above the recrystallization temperature, there are no dislocations. Dislocations are absent. And also when the further deformation takes place, then the further deformation, during further deformation, no new dislocations are formed in hot working. Whereas in case of cold working, additional dislocations are also formed, and which creates a hindrance for that particular this movement, and therefore we say that the strength increases. Okay, so that is how you have to see. So this is going to the A is going to the correct answer. Okay, great. Let's now move on to the next one. Okay, just go through it. A forging method for reducing the diameter of a bar and in the process making it longer is termed as. ठीक है, अब पहले क्या करो, जस्ट गो बाय एलिमिनेशन. यू कैन जस्ट गो बाय एलिमिनेशन आल्सो व्हेन यू गेट स्टक अप, क्योंकि बहुत सारी चीजें ऐसे हैं यू मे ऑलरेडी बी नोइंग इनडायरेक्टली, आपको ऑलरेडी इनडायरेक्टली पता हो सकती हैं. फॉर एग्जांपल इफ आई से ब्लैंकिंग, देन यू नो दिस इज अ कटिंग प्रोसेस, सो इट इज नॉट अ फोर्जिंग प्रोसेस, सो ऑब्वियसली दिस इज नॉट गोइंग टू बी द प्रोसेस. पंचिंग इज आल्सो कटिंग प्रोसेस. दो तो एलिमिनेट होगी, बच गई आपकी फॉलोइंग एंड अपसेटिंग. एंड अपसेटिंग यू नो वी आल्सो कॉल इट एज ए हेडिंग प्रोसेस, वेयर फॉर एग्जांपल व्हेन यू वांट टू form the head in the, for example you are having a bolt, how you form the head of the bolt. Let's say if it's a bar that is from which you are going to make a bolt, so what you will hold it, and this portion and portion compress it, so it means overall length is going to reduce when you will form the head. So when you will deform it, you have formed the head, so we call that a heading also, and upsetting also we can say. So it means since it is reducing the length, this cannot be the option. He's saying that it is going to make it longer. So basically then by elimination also you can reach to the fullerene process. Otherwise in forging you are required, from the exam point of view, you are supposed to know what is edging, what is fullerene, what is finishing, what is blocking. All these processes you need to know, right? And somewhere I think I have also framed the question on blocking also. There also again it will get revised, but anyway this is the process. Something simply, fullerene is a process where when we are having a bar, simply when we deform it somewhere in the middle, not the ends, not towards the end. For example, if I am having this bar and I will deform it somewhere in the middle, in the process when I will deform it, obviously that cross-sectional area will get reduced somewhere around that area, and obviously then if cross-sectional area is getting reduced, then its length will increase. So that we call it as this process as a fullerene process. Just a pictorial view, like you're having a bar, and if you are deforming somewhere in the middle, in the process obviously there is going to be outflow of the material, and overall length of that material is going to be increased. So reducing the diameter of the bar, and in the process making it longer. So correct option is going to be A option. Okay, so go to this one. Normally for 2 marks in GATE, you know, questions could be framed in this format, where sometimes he may ask you to match those columns, and I hope in this situation again go by the methods or the knowledge that you are having, that you are sure shot. आपको clear है, बिल्कुल clear है आपको, ये तो है ही है. So first match them. If that is done, then I think things become easy. Pressure vessel. अब pressure vessel, normally you already have the idea, you have studied the form. Normally जो pressure vessel जो बनते हैं, they are made up of steel plates. And the steel plates, if you have to do plate है तो plate को, if you have to make it in the form of a vessel, you have no option other than the welding. तो इसका मतलब है कि in any case pressure vessel you are going to have the welding. C1 कौन सा बचा? Either this one or this one. Then what about the connecting rod? Connecting rod extrusion से नहीं बनेगी, forging से भी नहीं. Yes, we may go for casting and forging, right? But the most appropriate process is forging, because अगर मैंने इसको मैच कराना machine tool bed, you know machine tool bed आपने देखा, मान लिया इससे lathe machine, तो lathe का bed कैसे बनाओगे? You cannot make it by forging. You can go only for the casting. So it means you are left out with no option but casting. 4 C4, where is C4? Sorry, I made it wrong. Sorry, it was B1. I was saying pressure B1, B1 C4, B1 C4, B1 C4. Then what is left out? Connecting rod, forging, collapsible tubes. For example, you are having creams, the tubes which are in which creams are hold, and you are having toothpaste and all those. So how we you may have studied in extrusion also, right? So in extrusion, impact extrusion, through impact extrusion, we make those tubes. So that means D is going to be 2. So the correct answer is going to be which one? A3, B1, C4, D, D2. Okay, so that is how we are going to find it out. Let's now go to this question. Just go through it, try to solve it. And normally in wire drawing section, you are going to find such kind of questions, and on similar lines, the GATE questions are framed by manipulating the few things. Okay, just go through it and try to solve. In a wire drawing operation, diameter of the steel wire, okay, is going to be what? So one way, directly, if you have the formula, you know the formula, then I think directly you can make use of it also. And so you're having D2, that means the diameter, initial diameter, let's say if I call it as a 10 mm, then final diameter 8 mm. In a wire drawing, it's a wire drawing operation, right? You know it already. So this is the, let's say, wire drawing operation, and I'm taking this out, let us say, as D2, and let us say this is D1. This is a die through which you are passing it and getting it. The mean flow stress of the material. So mean flow stress is what? Mean value of the true stress in this deformation zone, as you know, because you are deforming it in the plastic, you are in the plastic region, so you have to make use of the mean flow stress, right, or true stress. So mean flow stress, I'm denoting it as a mean value of true stress as 400 megapascal. The ideal force required for drawing. So you have the formula, I'm writing the formula, but at the same time, keep it in mind, sometimes you may get confused, like you may forget the formula, but I'm just writing it like you're having A2 into sigma TR into this is a natural log of A1 by A2. See how you have found out the formula directly. You need to know two things in case of this metal forming section, whether it is a forging, whether it is a wire drawing, whether it is a rolling, or whatever the process is. One formula that you need to know is the work done in homogeneous deformation. So work done per unit volume in homogeneous deformation is given by, work done per unit deformation is given by sigma true or ln. Either you can say this is a true strain only, so either you can write it in terms of length or in terms of area. In terms of length, it is L final by N initial, whereas when you have in terms of area, because volume consistency, in that case it is going to have in terms of area original or final. So let us say if I write it in terms of area, then it is going to be initial divided by final area. So keep it in mind, this is the work done per unit volume in case of homogeneous deformation process. And based upon this formula, he can create so many different numericals for you, which if you have simply wrote this final formula, let's say if you are remembering this formula, you are not bothered about it, then there are going to be many numericals or the questions which you will not be able to solve. We will see one such questions, one or two such questions based upon this formula, but how you have obtained it, that I'm just making you cross check. So this is the work done in a homogeneous deformation, and let us say in this process, when you want to find out the how much work you did, external work you did, then if you start applying force from here, and let us say this force, I say that is a drawing force, then how much work you did, you will say the force multiplied by the distance it traveled. Distance it traveled means the final length. So it means in case of this, the external work done, I can say is going to be the drawing force into the length, final length, that is the L2. That's all. And if you equate them, because this both of them are going to be the same, if you get the total work done from here, this is a volume multiplied by this will become the total work. This must be equal to the external work. Just equate it and your job will be done. So for example, if you will equate it, then what is going to be, you're going to have PD into L2 is equal to volume, this work done, this is the work done, external work done. So from here also I can get the work done, this become volume into sigma TR into ln of A1 by A2. Got? Now this volume, because here it is appearing L2, so I can write it in terms of the final dimension. So final dimension, let us say if input as the cross section area of final and L2, then L2 will cancel out. You're going to have this formula. Why I'm telling you this? Reason being that sometimes, see, when you will see the extrusion case, in case of extrusion, when we will talk about, there again we are going to find out the force required to deform the material. In that formula, instead of A2, you're going to have the term A1 over there. And when you're going to have that situation, sometimes you may get confused if you directly remember the formula, because whether A2 is in drawing, wire drawing, or whether it is in A1 is there or A2 is there. So it is better to just remember. In any case, you have to remember this. And this external work done, you can definitely immediately calculate depending upon the type of process, or simply equate that external work done with that. I will have that one extrusion question. So there I will explain again the same thing. Only difference is going to be the external work done, that I will write it over there. Will be a little different. That's all. But you can directly get the value of the force, deformation force over there from this formula. Anyway, so that was the basis. So just remember this, and it is going to be quite useful for you. But here, directly, if I am having this formula, then I think you can simply input the values. Go ahead now. What is the area? Pi by 4. Final cross-sectional area is 8 square, and mean flow stress, we call it as a mean flow stress, or mean value of mean average flow stress below, mean flow stress below, mean value of true stress below, whatever you want to call it. That is up to you. 400 into natural log of A1, pi by 4 D1. So I can write it in terms of pi by 4 will cancel out. So 10 square divided by 8 square. A1 by A2. So square. Pi by 4 will cancel out. From here, you're going to have the value of the drawing force, and it will turn out to be 8973.13. This is Newton. So 8.973 kilonewton. This becomes my value. That's all. Okay, done. So if done, then I think we can move on to the next question. Okay. Just I'm making one correction over here in this question before you answer this. Let's say this is correction is this. Instead of blank, this is punched. Okay. Go ahead and give me the answer. See this question and give me the answer, which should not take more than 30 seconds. So I am giving you that much time. Okay, some more answers. 50.06, right? All of you agree with that? Okay. See, I deliberately क्वेश्चन यही था, ब्लैंक नहीं था, मैंने जानबूझ के I deliberately changed the statement to confuse you. By writing down punched out, you change the interpretation. You change the interpretation. You made this process as a punching process. When you are saying that is blanked out, then you are saying this was a blanking process. When I wrote it as a punched out, then also you said this is a then you said that okay, this is a punching process. How you will decide whether it is a blanking or punching? You will not decide based upon this terminology. You will decide what you are making. Got it? You will decide it based upon what you are making, not based upon what you have written. If I say punched out, what does that mean? How will you decide whether punched out is taking out? As simple as that. But taking out does that mean that you are creating a hole? Or does that mean you are creating a blank? You cannot decide, right? You have to decide what based upon a 50 mm diameter disc. That means you are producing a disc. You are producing a blank. So if it is a blanking, so it means it is a blanking diameter. Punching out means taking out or blanking out. So keep it in mind. I think once in GATE he has framed the question on the similar lines. Only what he did is he simply removed this term and wrote this over here as punched out. And when he wrote that, all of you committed the mistake. It was the same way it was committed by the students also. So keep it in mind. These kind of confusion you may create. Now it is clear whether it is a blanked out or punched out. You have to decide based upon what you are making. You are making a disk. It means blank. So it means this process is a blanking operation. And in blanking operation, what he is asking me to calculate the diameter of the die. In blanking operation, the diameter of the die decide the diameter of the blank. It means the diameter of the die is equal to the diameter of the blank. And here, the diameter of the blank is 50 mm. That's all. That is your answer. It means this whole information that he has given you, that is just to confuse you. Take clearance as 3% of the sheet thickness. He has not asked you to calculate the diameter of the punch. Had he asked you to calculate the diameter of the punch, then this information was relevant. Let's say if he has asked you how you're going to find it. And one more thing, just keep it in mind. Let's say our job is done now. Jo usne पूछना था, we have calculated. Now let's say if I had to calculate the diameter of the punch. Diameter of the punch is, you already know, diameter of die minus 2c, where 2c over here is the clearance. This is the C. So C over here is the radial clearance. So keep it in mind, until and unless he clearly specified this percent, 3% is what? Is it radial clearance or diametral clearance? Your interpretation has to be radial clearance only. Or else he should very clearly specify that this is a diametral clearance. So this information he has nowhere mentioned whether it is a radial clearance or diametral clearance. If he has not mentioned, for us it is a radial clearance only. But if he wants us to tell, okay, this is a diametral, then he should write the term diametral clearance. So take clearance as 3% of the sheet thickness. This means the radial clearance C, which I have denoted over here, is equal to 3%, 0.03 of thickness. That is 1 mm. That is, it becomes 0.03 mm. So in that case, you could have calculated this becomes diameter of die 50 minus 2 times this 0.06. So that means this becomes what? 49.94 mm. In that case, it should have been this much. Anyway, this is just to, if we extend it further. Okay. So let's now go to the next one. Over here, you are going to have, this one is the question for you. Just go through this. Which of the following relation holds good for extrusion ratio R and fractional reduction in area? Okay. So, you know, fractional reduction in area is what? This is simply R he is noting. That means when you are reducing any size from initial diameter to the, or initial cross section to the final cross section. So let's say this is the change in cross sectional area with respect to the original cross sectional area. This is the fractional reduction, percentage reduction. Sometimes you can say percentage reduction in cross sectional area. It is the same thing. So it is this one, right? And what is R? R is extrusion ratio. See, there are two terms called as this drawing ratio in wire drawing. Drawing ratio, we denote it with capital R in case of wire drawing, And in extrusion also, we use the term called as extrusion ratio. It is not specific only to extrusion. It could be framed, this question could be framed for this your drawing also, wire drawing also. So extrusion ratio is also the term used, which is have the same meaning as you have in case of, we denoted with this. What is that? It is a ratio of the initial cross section to the final cross section. Over here also it is a ratio of the initial cross section to the final cross section. So keep it in mind, whether he call it extrusion ratio, then it means he's talking about the extrusion process. If he says drawing ratio, then he's talking about the drawing process, but meaning is same. The meaning of this is also same, whether for this is this what you call it as a fraction reduction, whether you can take it for any process for that matter, not specific to any only extrusion or wire drawing only. Okay, so now in terms of R, you need to put that value R. So can I write it this way, 1 minus A2 by A1? That's all. So A2 by A1 is what? A2 by A1 is equal to what? 1 minus R. So for A2 by A1, if I write it as opposite, that means reverse it, A1 by A2, if I do that, then it will become 1 minus R. And A1 by A2 is extrusion ratio or drawing ratio, whatever. So he can ask it, he has framed it for extrusion. He can also frame it for this, what do we call it as? And sometimes the formula, in terms of that formula, drawing formula, there also this manipulation can be done. Sometimes he can frame that question like, okay, you're having drawing stress. Like we had the formula for wire drawing, we had written as A2 sigma 2 into ln of A1 by A2. Right? This was the formula in case of what? Wire drawing, right? For drawing force. So sometimes he can give you, okay, what is the drawing stress in terms of this small r? So for example, A1 by A2, how I can write? A1 by A2, I can write A1 by A2 in terms of this. So sometimes you can say PD by A2 in wire drawing becomes, that is the exit cross-sectional area, force you are applying at exit. So this becomes the drawing stress will be equal to sigma 2 into natural log of 1 by 1 minus r also. So sometimes 1 minus r. So that way also he can frame. Okay, he may give you the options, okay, how you can write the drawing stress in case of wire drawing. He can give you such kind of options, like manipulating these values. You should be very clear what is the meaning of this if you know how we can represent this particular value. Clear? Okay, so that is how you have to proceed. Let's now go to the next one. Now this question is from extrusion now. I think in earlier question I was talking to you when I was in talking wire drawing. So on the similar lines I said that okay, in extrusion also we can have this formula on the similar lines. A brass billet is to be extruded from initial diameter. Let's say it is to be extruded from initial diameter to the final diameter, right? So something this way when we get. Okay, so let's say final diameter you're having D2, let's say it is D1. The operation is carried out at a working temperature 700 degrees Celsius and the extrusion constant 250 megapascal. The force required for extrusion is what? Now again the same way, let me just come to the same formula that I was on. Work done in an homogeneous deformation. It is not going to change for any process which we are carrying out in the plastic region. How much is that? Sigma 2 mean value of flow stress natural log of A1 by A2. It is not going to change. Now depending upon the process that we are using, external force may change. In case of wire drawing, I was applying the force at the exit. Work done I was calculating as the drawing force multiplied by the final dimension, that was L2. Over here, what is the force that I'm applying? Let us say force that I'm applying over here is let's say P. I can say call it as a P or whatever you want to call it. So or F. And when I deform it, let us say this was the initial length of the billet ideally, then this was the length. So if I say what was the external work done over here, so it is the external work done over here is equal to P into L1. So this work and this work should be same. So from here, if you see, if I equate it, then volume is going to be over there, that side. PL1 equal to volume goes to that side. Now volume, because here is L1, the term appearing is L1, so I can write the volume over there in terms of the initial cross-sectional area A1 into L1 into true got. So in this formula, if you see the work done, the force required to deform the material in case of extrusion, the term appearing over here is A1, whereas in case of a drawing it was A2. Work done was what? Same formula exactly, but only difference was here, instead of A1 it was A2. So if you will just simply cram the formula, that in sometimes examination hall, if you frame the question from extrusion or drawing, whether it is A1 or A2, you may get confused. And if you got confused, then obviously if you chose the wrong one, instead of A1 you chose A2, then your job is finished. But if you know that, okay, whether that formula or this formula, we have got it from the work done formula, then your job is pretty easy. If you got confused, immediately write it and you will get the work done. Okay, so keep it in mind that this is going to be quite helpful for you for any particular process. Now, this is the ideal formula. Okay, keep it in mind in extrusion. So it means in this case, if I had to write, the force required to deform the material in this case should be equal to sigma true into natural log of A1 by A2. But in this case, we have ignored the friction and all that. Okay, and so what we do is, for practical settings, we modify this formula in case of extrusion. So what we do is, we use a term called as extrusion constant, and this extrusion constant basically includes your friction, inhomogeneous deformation, and this. So basically, friction को भी count में लेगा ये, और inhomogeneous deformation है, उसको भी count में लेगा, and also it will include this term sigma TR in it. Sigma TR is also included in it. So what we did is we modified this formula to the practical settings, where you're going to have the friction also, you're going to have inhomogeneous deformation also, and we coined a term called as extrusion constant by taking this and sigma TR effect also into account. So it means for the actual settings, this formula is going to be K into A1 into ln A1 by A2. So what modification we did? Instead of the sigma TR, which is included in this, which I mentioned over here, in addition to it, you are taking into account friction and inhomogeneous deformation, we use the constant K. Since sigma TR is also included in it, you're always going to have its units in megapascal. Right? So if that be the case, then simply now input, you know this value, directly he has given you. Sometimes he can give you the, he may ask you to calculate the force for ideal situation, then you will use this formula. No friction, no inhomogeneous deformation, only homogeneous deformation, then go for this. But if it is a friction is there, inhomogeneous deformation is there, then make use of this formula, which is a situation which he has directly given you the value of K. So it means I'm not going to use this formula, but this formula, modified formula. So simply K is how much? It is in megapascal. 250 initial pi by 4 d1 is 100 square into natural log of 100 by 50 square. Pi by 4 will cancel out, and this value is going to be, how much is that value? So it will turn out to be 272,1982.61 Newton, or in terms of meganewton, he has given you this value, so it becomes the 2.72 mega Newton. That's all. Okay, so that is how you have to proceed. Okay, now let's go to the done. So that is how you have to see. So in ideal situation, make use of this formula, and for practical settings, actual situation where friction is given to you and all that, you need to make use of the extrusion constant. Okay, see this one. Which of the following statement is correct for closed die forging? कौन सी स्टेटमेंट करेक्ट है? Closed die forging is known as impression die forging. In closed die forging, blocking means workpiece is at completely finishing stage. See, आपको ऑलरेडी पता, to be more appropriate, you already know closed die forging or impression die forging. He has mentioned the term called as impression die forging, right? Closed die forging और impression die forging में थोड़ा सा डिफरेंस होता है, even though impression die forging is also closed die forging operation, but with the additional feature of flash and gutter arrangement, right? तो हम क्या करते हैं, इंप्रेशन, एक्चुअल में जो इंप्रेशन डाई फोर्जिंग होता है उसमें हम एडिशनल स्पेस देते हैं जिसको हम बोलते हैं गटर, एंड द फ्लैश एडिशनल मटेरियल जो है उसमें फ्लो कर जाता है, राइट? बिकॉज इन क्लोज डाई फोर्जिंग इट इज डिफिकल्ट फॉर अस टू एस्टिमेट द एग्जैक्ट अमाउंट ऑफ मटेरियल जब आपकी शेप ऑफ द दैट पर्टिकुलर कंपोनेंट कॉम्प्लेक्स हो जाती है। तो उस केस के लिए हमें क्या करना पड़ता है, तो सिंपली क्लोज डाई फोर्जिंग यू डोंट नीड टू हैव फ्लैश एंड गटर अरेंजमेंट, और गटर अरेंजमेंट यू डोंट नीड टू प्रोवाइड in simple closed die forging operation, but in this impression die forging आप additionally ये गटर का अरेंजमेंट देते हो। तो अगर मैं कहूं क्या impression die forging closed die forging operation है, you will say yes. If I say क्या closed die forging operation is always the impression die forging operation, then no, because impression die closed die forging without इसके हो सकता है जो आपका गटर दिया है, but impression die forging you need to definitely have this one. So इसका मतलब ये है कि ये स्टेटमेंट करेक्ट है कि हम बोल सकते हैं क्लोज डाई फोर्जिंग इज आल्सो नोन एज इंप्रेशन डाई फोर्जिंग, बोल सकते हैं हम इन लूज टर्मिनोलॉजी। सो इन क्लोज डाई फोर्जिंग ब्लॉकिंग मींस वर्कपीस इज एट कंप्लीटली फिनिशिंग स्टेज। ये ऑपरेशन सीक्वेंस रख लेना ध्यान में, इवन दो वी हैव ऑलरेडी स्टडीड, आई विल नॉट इलैबोरेट इट टू मच, बट ये कुछ सीक्वेंस है। तो जैसे मान लिया लेट्स से कनेक्टिंग रॉड है, if you know we did one question earlier where we said that connecting rod is made from this forging operation. तो initially हम इस तरह का we are going to take a bar of this shape, then if you want to increase its length तो हम क्या करते हैं middle portion में first क्या करते हैं apply the force and then धीरे धीरे elongate करते हैं। तो furring operation is first carried out, edging operation carried out करते हैं। for example edging is moving the material to the correct location, so हम पकड़ते हैं material को because let's say if it is in a heated state and move it to the different location. For example here I need more material, so I will hold the material and slowly move it to the different locations, we call it as a edging. Then bending हो गए, if bending is required then you go for bending, but see finishing operation में जाने से पहले इस केस में this is a forging operation, in final finishing operation basically this is a impression die forging operation. Impression die forging operation we are going to have the flash and gutter arrangement, that is the final stage. Exact dimension you will obtain over here, but before that operation we perform one operation which is an approximate operation. Closed die forging operation होगा, die भी almost same shape होगी, but we will not get the exact final dimensions. तो blocking operation क्या है? If we say what is blocking operation, you will say blocking operation is a closed die forging operation only, but in that we will not obtain the final dimension, we will get approximate dimension, approximate shape हम दे देते हैं इसमें, then final shape exact dimension वाली shape के लिए मुझे क्या करना, finishing die पे जाना पड़ेगा। तो you can say blocking operation is one step ahead or one step before that of the finishing operation in case of this particular these forging operations. तो एक तो sequence का आपको थोड़ा ध्यान रहे कि we will start this way normally, किसके बाद कौन आएगा, ऐसा नहीं होगा कि फिनिशिंग के बाद ब्लॉकिंग आएगा, purpose is defeated. Finishing में that means I want the final dimensions. So इसीलिए if you see over here in this question, what is over there? In closed die forging, blocking means workpiece is at completely finishing stage. No, one step ahead of it or one step before that. So this statement is incorrect. So you can say one is going to be the correct statement. Okay. Go ahead with this. You're supposed to find out the angle of bite. In case of a, obviously, this rolling operation, right? So go ahead and try to find it. So let's say this is the ruler that you are having, and something this way. If I take one side only, so this is the angle of bite. We denote it with the alpha, right? And what is this? Let's say if I say O, if I say A, B, and what is this? You know, this is the half of thickness reduction, 9.02 to 6. Yes, you're correct. So this is half of thickness reduction, that h by 2. Total thickness reduction is, let us say, x, then it is going to be x by 2. Half this side, half other side, because you are having another roller also. So now, what I am supposed to find out, he is asking me to calculate this angle of bite, this angle that is made by this arc of contact of this strip with that particular roller, that is going to make an angle, subtended angle at the center of the ruler. So what is that angle? We call it as the angle of bite. So what is that value? Geometrically you can find it out. Otherwise you may have remembered the formula, like tangent alpha is equal to that h by r. One way is that directly, because you may have remembered, so you can also get it done from here. Otherwise, if some of you may go by the geometry also, which is over here. If I ask you what is this much, how much is this? So if this is total r, if you remove this one, so this is going to r minus that h by 2. This distance, that is this OC. So one way is to calculate this much. So let's say if I input the values, how much is the thickness, total thickness reduction? You're going to have that h, how much? H1 is this 20, this is H2, let's say. So thickness reduction is 20 minus 14. So 20 minus 14, it becomes 6 divided by radius. So keep it in mind, in haste, don't take the diameter, you need to take the radius. So radius is half of that, 240 mm. So this value you will get something. So let's say I got it something 0.158, and then alpha from here is going to be 8.97. Okay, this is one way of doing it. Other, let's say we forgot the formula, but you have this picture in mind, or you are having this, you have this process जो है आपको जो है वो ध्यान में है, and from here also you can get it done. For example, if I say this becomes, ये जो ट्राइंगल है आपका, ये आपका ट्राइंगल हो सकता है, ये बन गया कौन सा, ये अल्फा OC and this is A. So इस ट्राइंगल का बेस कौन सा हो गया, ये. And what is this dimension? Do you know this dimension OA? From here to here, you will say radius. So can I get the value of cos of alpha? लिख सकता हूं मैं क्या? Obviously, because R I know. So this dimension I know. How much is that? R minus that h by 2. So base is OC. So base by hypotenuse, you have the base is R minus that h by 2 divided by R. So from here, if you input the values, from here also you can get the alpha. So let's say, for example, if I input the value from here, it will turn out to be 240 minus, let's say, that h by 2, 6 by 2. It becomes 3. So 3 divided 240. और यहाँ पर आपकी वैल्यू आई ये, I don't know, मैंने कैलकुलेट नहीं किया है, बट अल्फा यहाँ से जब फाइंड आउट करोगे आप, so it is going to be 9.068 degree. Okay. So it's your choice which one you are doing. अब आप ये बोलोगे गेट के पॉइंट ऑफ व्यू which one is correct. It's up to you, because इस सिचुएशन में he is going to give you the range. Let's say some of you go ahead with this and you found this answer, exact answer you're writing. Let's say this is a numerical type of question, and you're writing this answer 8.97, and the other student who calculated from this and he wrote this answer, this, which one is correct? Obviously is going to give the range. Both are correct, because the error, because in this formula actually we have made a little approximation. जब हम वो derivation करते हैं, final जो condition achieve करते हैं, in that case we get some approximation. So approximation के कारण we have a simplified formula, so we simply remember it and just get the value. So it is up to you, right? अगर आप इससे करना चाहते हो then also okay, यहाँ से करना चाहते हो तब भी कर लो. But as I told you, in GATE he's going to give you the range, and out of these two, as per your choice, आप कोई भी कैसे प्रोसीड कर सकते हो. यहाँ पर because as you know NPTEL assignment में he's not very specific in the sense, क्योंकि वो GATE के हिसाब, that means he's not only like जो स्टूडेंट्स हैं आपके जो उनका कोर्स करते हैं उनके हिसाब से उन्होंने बनाई है, तो इसलिए उन्होंने डायरेक्टली 9 लिख दिया है. So in that case it may be not be much issue, but or definitely in GATE he is going to give you the range. Okay, so that is how you have to proceed. So I hope you understood it. Let's go to the next now. Over here, okay, and one more thing, for example, he manipulates. If you see the questions that are framed normally from this particular section, particularly the rolling, एक तो एरिया वो है जो कि ये ज्योमेट्री है जो हम बात करते हैं इसके बेसिस पे फ्रेम करता है. अदर वन इज द फ्रॉम द पावर एंड दिस रिलेटेड टॉर्क और पावर निकालने के लिए बोलता है वो. दैट सेक्शन डेफिनेटली आल्सो. तो दो ही एरियाज हैं जहां से क्वेश्चन फ्रेम होते हैं यहाँ पर. आई कुड नॉट फाइंड द क्वेश्चन इन NPTEL assignment this from the power section, but anyway at later stage when I will find it, definitely I am going to include. But अच्छा, इसी में भी वो फर्दर क्या पूछ देता है, कई बार बोलता है रोल स्ट्रिप कॉन्टैक्ट लेंथ निकाल लो, जो मैंने यहाँ पर शो किया था. सो डिफरेंट वेज ही कैन आस्क यू टू कैलकुलेट. फॉर एग्जांपल ये था, यहाँ पर अल्फा कैलकुलेट करने के लिए बोला था, मे बी ही मे आस्क यू टू कैलकुलेट दिस लेंथ आल्सो. फॉर एग्जांपल दिस इज अ सेंटर ओवर हियर, दिस इज अल्फा, दिस इज आर. ही मे से रोल स्ट्रिप कॉन्टैक्ट लेंथ, दैट इज द पोर्शन ऑफ द रोल which is in contact with the strip. So which is that portion? That is AB. So he may ask you to find out this length, roll strip contact length. So you can just find out simply, क्योंकि R into alpha क्या हो जाएगा, R into alpha provided alpha आप रेडियन में लो, R into alpha equal to AB. So that way simple manipulation, अगर प्रोसेस को आपको समझ आई है, then you can simply calculate all those values. Let's go to the one more question on the, almost on the similar lines. Just see this. Steel plate 20 mm, more or less उसने dimensions and all those same ही दिए हैं. And what is asking you to calculate? If given reduction is the maximum reduction possible, then the coefficient of friction is, you know, in case of for the unaided entry of the strip inside the rules, right? Condition क्या है कि maximum जो thickness reduction obtain कर सकते हो. Let's say he says कि अगर मैं कोई भी additional, जस्ट मिनट, बिना किसी एक्सटर्नल हेल्प के, इफ यू वांट दैट स्ट्रिप बिना एड के, बिना एडिशनल हेल्प के, लेट अस से यहां से विदाउट एनी एक्सटर्नल हेल्प, रोल बाय देमसेल्व्स पुल दिस पर्टिकुलर स्ट्रिप इनसाइड, बिना एनी फोर्स अप्लाई किए हुए. इफ रोल बाय देमसेल्व्स पुल देम इनसाइड, then what is the maximum possible reduction? ये maximum कितनी हो सकती है? ये combined together, that is that h by 2, that h by 2. So maximum thickness reduction in one pass, एक ही बार में, एक तरफ से दूसरी तरफ, when we move it or push it, sorry, I will not use the term push it. That means when the strip moves from one end to the other end, that means we call it as a single pass. So in single pass, you know, already know the formula. The maximum possible reduction, एक बार में maximum possible reduction कितने कर सकते हो? You know, that is decided by the coefficient of friction and radius of the rolls. तो बोलता है अगर this is the maximum possible reduction, अगर ये maximum possible reduction है इस केस के लिए, it means that is 20 minus 14, this is the maximum possible reduction, then what should be the coefficient of friction between these rolls and strip? Roll और strip के बीच coefficient of friction कम से कम कितना होना चाहिए? So that you can find out mu square, and because you know the roll radius which is 240, as simple as that. So mu is 0.158, you may have found it out. Clear? So nothing कोई complicated नहीं है, but straightforward, you can get it done. Okay, go to the next one. Just see it. I think it was, this is the question, just उसको अलग तरीके से पूछा गया है, but I think we have discussed this. What is this? Deformation under condition of temperature and strain rate such that recovery takes place simultaneously with deformation. I already discussed with you. साथ साथ जो है रिकवरी भी हो रही है. कहां होती है वो? हॉट वर्किंग में होती है. So hot working, I already discussed with you hot working process. तो साथ साथ as you are deforming the material, simultaneously, what? Simultaneously that recovery also takes place. मतलब जो grains है, elongated grains, they will be broken down and new grains will be formed. So there is no strain hardening as well as no this what do we call as जो simultaneous recovery भी साथ में मिल जाती है. So ये same ही way है, just the way he has framed the question is little different. Otherwise it comes from the same process. Just go to this. Be fast. Easily you can do it. In open die forging, disk of diameter reduced from this to this and is compressed without any barreling effect. Barreling effect, you know, in case of what? In case of this forging, barreling is a defect. But he's saying they ignore the barreling. Barreling कुछ नहीं है, barrel की. Barrel आपने देखा होगा ड्रम इस शेप का, उसको barrel बोल देते हैं. This is a drum which is having this shape. तो बोलता है ये नहीं है present. Simply when I am deforming it, अगर इनिशियल ये था, इस शेप में था, तो फाइनल भी वो स्ट्रेट सिलेंडर ही मिला मुझे. दैट इज द मीनिंग ऑफ दिस. ये समथिंग दिस वे, राइट. सो व्हाट ही हैज गिवन यू, इनिशियल डायमीटर दिया उसने आपको, दैट इज दिस डायमीटर ही हैज गिवन यू, दैट इज 200 mm. हाइट उसने दिया, दिस इज नॉट प्रोपोर्शनेट, ही हैज गिवन यू द 60 mm. इज कंप्रेस्ड विदाउट बैरलिंग, कोई बैरलिंग नहीं होती, सिंपली जो स्ट्रेट सिलेंडर बन रहा है. The final diameter of the disc is 400 mm. तो ये आपको जो है he saying that this is 400 mm and that's all. The true strain. What is the true strain? So true strain, you know, natural log of what? या तो initial cross sectional area ले लो if he has 400 final diameter. So you can say in terms of area also, because area you already know, initial and final. So I can say initial divided by final. This is the natural strain or true strain I can say. So in terms of area, natural log of pi by 4 जाएगा आपका. This becomes 200 divided by 400 square, right? This turns out to be 0.5, natural of 0.5 square. और ये वैल्यू क्या आ जाएगी आपकी? What is that value? This is minus 1.386. ये मेरी ट्रू स्ट्रेन आ गई. So keep it in mind. वन एक चीज ध्यान रखनी है आपने. Sign is important. Even though this question he has framed, he has given you the option, we are left out with no option, but in terms of value he has given you. He has not given the sign. For me, let's say if it is a numerical type question, if it is a numerical type of question, then sign is important. Sign, what does the sign indicate? Sign indicate कर रहा है कि इसका जो है क्या हो रहा है, length decrease हो रही है, right? So sign is important for me, but in this question option उसने दिया नहीं है, so let it be. But if it is in exam, either he will give you the option of this one. If it is not given, let's say उसने ऐसे ही दिया है, then you have no option. But let us say either he should give you the option in negative. If not given and it's a numerical type of question, then you have to go for the no. Finally, it's not Pratap. It is not final initial. Lengthwise, true strain जो है आपकी आती है natural log of final length divided by इनिशियल लेंथ, ऐसे आती है. लेंथ के टर्म में ये ऐसे आता है. जब आप इसको क्या करते हो, आपको पता है, यू नो, वॉल्यूम कंसिस्टेंसी, ए फाइनल एल फाइनल इज इक्वल टू ए इनिशियल क्रॉस सेक्शन एरिया. दिस इज वॉल्यूम इज गोइंग टू रिमेन सेम. सो दिस, सो व्हेन आई राइट एल एफ बाई एल आई, सो एल एफ बाई एल आई क्या हो जाएगा आपको, एल एफ बाई एल आई विल बी इक्वल टू एल एफ बाई एल आई, ए आई बाई ए फाइनल, ए आई बाई ए फाइनल. ठीक है. तो इन टर्म्स ऑफ एरिया इट इज इनिशियल बाय फाइनल. गुड, ओके, ठीक है. तो ये ध्यान रखना आपने. इन टर्म्स ऑफ लेंथ ऑल्सो यू कैन कैलकुलेट, पर उसमें फिर अननेसेसरी मेरा एक स्टेप करना पड़ेगा. आई कैन डू दैट ऑल्सो, जैसे मैंने यहां पर किया. लेंथ के टर्म में भी लिख सकते हो, लिख लो, लेंथ के टर्म में लिख लो, पर फिर अननेसेसरी में बिना मतलब का एक व्हाई शुड आई गो फॉर एन एडिशनल स्टेप, राइट? ओके. Okay, go to this particular question now. Simple. और keep it in mind, इस तरह क्वेश्चन पूछे गए हैं गेट में. ऑलमोस्ट मुझे जहां तक आई कैन रिकॉल, आई डोंट नो वेदर इट वाज द सेम और लिटिल मॉडिफाइड. सेम क्वेश्चन, सिमिलर लाइन क्वेश्चन है. दिस क्वेश्चन आल्सो सिमिलर लाइंस पे क्वेश्चन आपको फ्रेम किया गया है. सो इवन दो दे आर नॉट डिफिकल्ट, बट एनीवे. A solid cylinder of diameter 100 mm, 50 mm, forced between two frictionless flat dies. Obviously, यहाँ पर उसने mention, he is not mentioning about the this barreling effect. If is not frictionless dies, and obviously we say that okay, we are able to obtain the straight cylinder even after deforming, so there is going to be no barreling, right? So directly इसमें I am having this one. So let's say this one. So everything is given 100. हाइट जो है 50 है, डायमीटर 100, डायमीटर 100, इट्स नॉट प्रोपोर्शनेट एज आई टोल्ड यू, 50 ये आपका है, एंड देन फ्रिक्शनल स्प्रेड डाइस हाइट जो है 25 आ गई आपकी, एंड percentage change in diameter. So let's say if I call it as a D1, and let's say if I call it as a D2. Percentage change in diameter? Simple, pretty simple. That means change in diameter, diameter increase हो रहा है, D2 by D1 divided by compared to initial diameter. I don't know the diameter, तो आप last A1 L1 equal to A2 volume. In terms of volume, volume is going to remain same. So pi by 4, D1 is how much? Under square into L1 is 50 equal to A2 pi by 4 D2 square into I don't know the diameter, so but I know the height, that is 25. From here you get the diameter 2, so it is 141.42. So that means D2 is 141.42, D1 आपको पता है 100 है, so this value change in diameter कितनी आ जाएगी आपकी? This is going to be 0.14142. So that means in terms of percentage, if he is saying, so it is going to be, sorry, इसमें मैंने 41 कुछ गड़बड़ की, it should be 141 था ये, हाँ ठीक है 41 आ जाएगा ना, 141 minus 100, sorry 141 minus 100, so ये आ जाएगा 41, so 4142 ऐसे आएगा ये point, right? So it means 41.42%. ठीक है, so इसमें इनपुट करो 141.42 minus 100 divided by 100, so it will turn out to be this much. So in terms of percentage, 41.42. Simple math, nothing special in it, right? But sometimes you can frame the question on these lines also. Okay, go to this particular question. ये वही है, this question is going to have the relation, right? It is what I think it is. He is not going to ask the question this way to you. ये simply because NPTEL assignment में frame कर दिया है. Just I am simply taking it just to relate it to the earlier example of true strain. I think that was the first example that I discussed with you, right? So इसलिए मैंने ये ले लिया. Otherwise, I think from GATE point of view, it is not that much important. Simply क्या है? A 10 centimeter long, a bar of 10 centimeter long is elongated to 20 centimeter by rolling in 3 steps. ठीक है? 10 से आपने 12 किया, 10 to 12, and then 12 to 15, and then 15 to 20. So 10, 12, 15 and 20. Right? So what is saying? Calculate the sum of engineering strain. See, question ही ऐसे पूछा गया, sum of engineering strain. Not logic, he is not going to ask you in GATE, but ये simply इसलिए पूछा गया, just अगर आपको इसको basically to relate the concept with that, कि अगर मैं इसमें क्या करूं, if I ask you in this case, in the whole of this process, what is the conventional strain? If I ask you what is the conventional strain, how will you be calculating? आप लोगों को change in length कितनी बड़ी ना, 20 minus 10 divided by final initial divided by initial, so it is going to be what? 10 by 10, 1. Sorry, strain, conventional strain. Sorry. This is conventional strain. So if I ask you what is the conventional strain, so this is how you are going to calculate change in length to the original length, right? So this is the way you are going to calculate. But as I told you, this is not going to be the same as if अगर मैं क्या करूं, इसको calculate करूं individually. For example, from here to here, then here to here, then here to here, and then add them up, right? So that value is not going to be equal to 1 because this particular strain, that is the conventional strain, doesn't have the property of additive. Then we say that it is not additive in nature. Addition की property नहीं है इसमें, right? For example, अब ये केवल just a kind of practice, आपको कहीं question frame करके दे दिया उसने in different way, so at least you should have idea कि कैसे हम calculate करते हैं. For example, in this case, when we talk about the strain in first step, strain in second step, strain in third step, that is a conventional strain. So first step में conventional strain क्या आ जाएगी? आप बोलोगे इसके लिए original ये है, तो आपका क्या आ जाएगा? Change in length 12 minus 10 by 12. How much is that? 2 by 12. 1 by 6. What about second step में? What is the conventional strain? You will say second step के लिए original length ये है, तो 15 final length, original length उसके लिए क्या होगी? ये second step के लिए, and compared to the original. Sorry, यहाँ पर मैंने गलती तो नहीं की. Yes, I committed mistake. Final initial divided by initial होता है ना ये इट शुड बी 10, इट शुड बी 10. सो ये क्या आपका 0.2 है. ठीक है. सो फाइनल इनिशियल डिवाइडेड बाई चेंज इन लेंथ टू द ओरिजिनल लेंथ. ओरिजिनल लेंथ कौन सी है? 12. ओवर हियर इट इज 12, सो 3/12, सो इट इज 1/4. सेम वे थर्ड स्टेप पे अगर आप बात करोगे, थर्ड स्टेप पे क्या होगी? फाइनल माइनस इनिशियल, सो इट इज बिकम्स 20 minus 15 डिवाइडेड बाई 15, so it becomes 5/15, that is 1 by, so 0.25, ये 2.25 हो गया और 1/3, 0.33. now just club them together. Let's say उसने पूछा क्या मुझे? sum of engineering strains. He has not asked me this one. ध्यान रहे, you may commit the mistake of interpreting this as this. No, because if you have that understanding, let's say ये पूछ रहा है मुझसे ये और ये, so ये मेरे ख्याल if you will club them together, 5 3 8 8 और 3 5 और 3 4 7, see 0.78, right? यही. Okay, so this is how the difference is 0.2 0.25 0.33. anyway ठीक है, अगर मैं 3 ले लेता हूं तो 3 आ जाएगा, कोई बात नहीं, it's okay. But point is, you cannot have the misinterpretation in this question that if he is asking you that okay, sum of engineering strain, let's say उसने क्वेश्चन ये पूछा और आपने किया, you answered it this way, okay, sum of engineering strain, आप बोलोगे क्या हो गया, बात एक ही उतना ही आएगा जितना कि डायरेक्टली मैं कैलकुलेट करके देखूं, right? So that could not be the case. So here you can commit the mistake, you don't have to calculate this way, because क्यों? Because you already know कि ये वैल्यू कभी भी इसके बराबर नहीं होगी. That is the disadvantage. आप ये भी बोल सकते हो, that is the one of the disadvantage of the conventional strain, right? And that is why we normally don't go for the this kind of strain in case of particular plastic deformation processes or metal working में. ठीक है, true strain पे ही focus करते हैं हम, right? So anyway, this question is not true, but give you an idea कि आप कहीं दूसरे क्वेश्चन में sometimes you will frame the question other way around also, but if you have that understanding, I think in those questions you are not going to commit the mistake. इन दोनों को चीजों को, sum of engineering strain and total engineering strain, both are different. Total engineering strain, this, sum of this. अगर ऐसे पूछता तो है, अगर ऐसे पूछ रहा तो you're going to calculate this way, right? Okay, so that is how you have to do. Let's go to next question. Just this, see this question. ये मेरे हिसाब से जो है, this is quite good question, और I would advise you to try this question by yourself. थोड़ी सी आपकी अंडरस्टैंडिंग को चेक करेगा और it will help you to relate the things, कि जो चीजें आपकी अंडरस्टैंडिंग है, the basic understanding that you are having, how that understanding you can apply over here and all that. It's not B. It's not B. No, neither B, neither D. अब कैलकुलेट करके बताओ. Don't say that okay now C and A. Okay, just calculate and give me the value now. नहीं बता दिया मैंने. I just told you B is not the option. Okay, इसको थोड़ा सोच लो बस. Okay, एक तो you already know this. The true stress and true strain relation is given to you, where stress is in this. What is the ultimate tensile strength of the material? I hope you know ultimate tensile strength किसको नाम दिया गया है. जब भी आपको विदाउट एनी स्पेसिफिकेशन मेंशन किया गया हो, देन इसको हम अल्टीमेट टेंसाइल स्ट्रेंथ बोलते हैं, विदाउट एनी फर्दर क्लैरिफिकेशन. अगर कोई क्लैरिफिकेशन नहीं दी गई है, दिस इज माय अल्टीमेट स्ट्रेंथ. दैट मींस when we talk about the ultimate strength, we are talking about the conventional value of that particular stress corresponding to the maximum value of load. ये मतलब है इसका. True stress, ये ट्रू स्ट्रेस कर्व है एंड कॉरस्पॉन्डिंग टू मैक्सिमम लोड समवेयर यू आर आल्सो गोइंग टू हैव दैट वैल्यू corresponding to maximum load. Corresponding to maximum load in the conventional stress strain diagram, you are going to have this value which we call it as a sigma ultimate. But corresponding to the same maximum load in the true stress strain diagram, I also going to have some value which we don't say ultimate tensile strength. Yes, you can say that is the, let us say, ultimate tensile strength in ultimate true tensile strength. Then okay, you can some way you can accept. Okay, कि आप बहुत स्पेसिफिक हो रहे हो, बता रहे हो क्लियरली अलग से कि corresponding to maximum load, the value of the stress in true stress strain diagram, let's say I call that as a true value of stress corresponding to that maximum load, but we don't normally call that value as the ultimate tensile strength. तो अगर आप एक स्टैंडर्ड टर्मिनोलॉजी की बात करोगे, when you will talk about the standard terminology, then this ultimate tensile strength as a standard terminology is used for the value of the maximum stress corresponding, sorry, value of the maximum stress in the conventional stress strain diagram. ठीक है, अब बात करते हैं, ये इतना आपको क्लियर है. अब इफ दैट बी द केस देन आई हैव टू डिस्टिंग्विश. क्या पूछा है उसने? इसने पूछा ये, ठीक है. इफ दैट बी द केस तो रिलेशंस आपको ऑलरेडी पता है और उन रिलेशंस का उसने आपने यूज करना है. दैट्स ऑल. नाउ टू फाइंड आउट दैट यू हैव द रिलेशनशिप बिटवीन व्हाट, दो रिलेशनशिप जो यूज करने पड़ेंगे आपको यहां पर. वन इज व्हाट इज द रिलेशनशिप बिटवीन द ट्रू स्ट्रेस एंड द कन्वेंशनल स्ट्रेस. यू विल से सिग्मा इनटू 1 प्लस ई. एक रिलेशन ये है. एंड सेम वे स्ट्रेन के लिए भी सेम सिमिलर काइंड ऑफ रिलेशन है. ट्रू स्ट्रेन इज गोइंग टू गिव नेचुरल स्ट्रेन ऑफ 1 प्लस ई. दीज रिलेशंस यू ऑलरेडी नो. ये रिलेशंस आपको ऑलरेडी पता है, यू नो ऑलरेडी नो देम. इन्हीं का यूज करना है. व्हाट आई एम गोइंग टू फाइंड आउट, ही इज सेइंग मी टू फाइंड आउट द अल्टीमेट टेंसाइल स्ट्रेंथ. इसका मतलब ये है कि ये वैल्यू कन्वेंशनल वैल्यू को फाइंड आउट करनी है कॉरस्पॉन्डिंग टू द अल्टीमेट और मैक्सिमम लोड. इट मींस आई हैव टू फाइंड आउट सिग्मा अल्टीमेट. तो उसके कॉरस्पॉन्डिंग फिर वैल्यू जो ट्रू वैल्यू ऑफ स्ट्रेस को क्या नाम दे दूं मैं, लेट्स से उसको मैं यू लिख देता हूं. बिकॉज व्हाई आई एम राइटिंग यू, बिकॉज इट कॉरस्पॉन्ड टू द मैक्सिमम वैल्यू ऑफ द कन्वेंशनल स्ट्रेस यूटी. सेम वे this value of the conventional stress or strain should correspond to that value. That means this value of conventional stress should correspond to this value. So can I call it as a strain corresponding to the ultimate stress? Of course. जब यहां पर ultimate कर रहा हूं तो ये value भी तो ultimate होनी चाहिए. Corresponding to that value of the stress, what is the strain? You are having this one. ये relation है मेरा. यहां से मैं निकाल सकता हूं this value. ये value मैंने find out करनी है. So to find out this value, first I need to find out this value. I need to find out this value. My job is done. So can I find out this value? आप बोलोगे definitely I can find out because I have this relation. So true strain, do I have that? Yes. उसने कुछ दिया है आपको. अच्छा, एक चीज आपको रिलेशन ऑलरेडी पता है. Anyway, इसी को मॉडिफाई कर दूं. I want, अगर मैं let's say corresponding to this strain, conventional strain, what is the value of the true strain over here? So that I can find out from here. Is equal to natural log of 1 plus E ultimate. So I need to find out this one. What is this value? And you know, एक relation आपको definitely you may have studied in wire drawing that corresponding to the maximum force. Yes, right. Corresponding to the maximum force, the value of the strain, true strain, is equal to the value of n. ये आपको Holomon relationship है. Sigma true, ये क्या है? What is this? Sigma true is equal to k epsilon raised power n. And corresponding to maximum load, you're going to have value of the n equal to this. So can I say this epsilon ultimate is what? Corresponding to maximum load. तो maximum load कब होगा? When you are having this, because ये जो value है, this will correspond to epsilon ultimate will correspond to what? Maximum value of load. At that point it is going to, n is going to be equal to this. So can I say over here, this over here is going to this one, which is equal to, I can say this way also. ये आपकी understanding है 33. It means this becomes 0.33 equal to natural log of 1 plus ultimate. So यहां से मेरी ultimate की वैल्यू आ गई कितने? ये ultimate की वैल्यू आ गई मेरी conventional में 0.395. ठीक है, ये तो मेरा काम हो गया. So from this understanding I got this value of ultimate which I will input over here. Now left out with this. तो ये भी तो find out कर ही सकता हूं मैं. अगर मैं इसमें जो है इसमें ट्रू को अल्टीमेट कर देता हूं तो एप्सिलॉन क्या आ जाएगा, अल्टीमेट आ जाएगा. सो सिमिलरली आई कैन ऑल्सो फाइंड आउट, सिमिलरली I can say true value of ultimate corresponding true value of the stress corresponding to the maximum load, that is the ultimate, will become equal to what, 1500, and corresponding to that point you are going to have this value equal to this 0.33. So can I say this 0.33 raised power 0.33. तो ये value of true stress आ गई. कितनी आई है true stress की value कितनी आई, how much is that? Okay, 0.07 megapascal. Am I clear? That's all. बाकी तो इनपुट ही करनी है. Input this value over here, input this value over here, and you're going to get the value of sigma ultimate. So 1040.07 equal to sigma ultimate equal to 1 plus 0.395. कितनी आ गई मेरी वैल्यू? Sigma ultimate is going to be 745.56 megapascal. So even though he has given me the approximate value, but stick to this value. Okay, stick to this value. यहां पर और कोई ऑप्शन है नहीं. अप्रोक्सीमेट आई कैन नॉट, गेट के पॉइंट ऑफ व्यू से आई कैन नॉट टेक दिस अप्रोक्सीमेट वैल्यू, नहीं गेट में देगा वो, इज नॉट गोइंग टू गिव दिस वैल्यू इन गेट, कीप इट इन माइंड. सो इसलिए इस क्वेश्चन में आई विल नॉट स्टिक टू दिस वैल्यू, बट ये मेरा आंसर रहेगा. यू स्टिक टू द एग्जैक्ट वैल्यू दैट यू हैव गॉट. ओके, तो इस क्वेश्चन को ढंग से ध्यान से रखना. ये इज गोइंग टू बी क्वाइट हेल्पफुल. मतलब काइंड ऑफ यू कैन से अभी पूछा नहीं गया है इस लाइन पे, आई थिंक जहां तक मैंने देखा है, बट डेफिनेटली ये फ्यूचर के लिए क्वेश्चन बनेगा, कभी भी पूछ सकता है इस लाइन पे. ही मे क्रॉस चेक योर अंडरस्टैंडिंग ऑफ दिस. ठीक है, ओके ओके, लेट्स नाउ गो टू नेक्स्ट वन. डन. अगर आपने स्क्रीनशॉट लेना ले लो, देन आई एम जस्ट टेकिंग आउट. Okay, let's now move on to this one. I think you will be able to do it. Just try it out. And okay, so I hope you may have C. You are saying C. So let me just check. क्या जाएगा? ब्लैंकिंग तो ऑब्वियसली आपको पता है शेयर है. ब्लैंकिंग पंचिंग डायरेक्टली शेयर ऑपरेशन है, तो इसमें तो आपको सोचना ही नहीं है. तो स्ट्रेच फॉर्मिंग, स्ट्रेच फॉर्मिंग सिंपली क्या कर रहे हो आप, खींच रहे हो उसको. स्ट्रेच फॉर्मिंग टेंशन डायरेक्टली देख लो कौन सा है, A3 B1 A3 B1 ये, बाकी ऑप्शन है ही नहीं. बट एनीवे देख लो. क्वाइनिंग, क्वाइनिंग क्या है? क्वाइनिंग इज ए क्लोज डाई फोर्जिंग ऑपरेशन. क्वाइन जो आपका बनता है, जो उसमें रेज फिगर्स होते हैं, राइट, यू नो दैट. सो क्वाइनिंग इज ए क्लोज डाई फोर्जिंग ऑपरेशन, राइट. ये ध्यान रखना हमेशा, क्योंकि जो आप क्या करते हो, क्लोज डाई होती है और यू आर हैविंग ए क्वाइन जो आप पुट करते हो, जो यू आर हैविंग करेंसी क्वाइंस, तो उसको क्या करते हैं, कंप्रेस करते हो रेज फिगर. सो इट इज ए क्लोज डाई फोर्जिंग ऑपरेशन. सो व्हाट इज दैट? दैट मींस क्लोज मीन यू आर ओनली कंप्रेसिंग इट, नो फोर्स, नो अदर फोर्स. इसका मतलब है ये क्या है, कंप्रेशन. डीप ड्राइंग, डीप ड्राइंग आपको ऑलरेडी पता है. जो डाई है आपकी ये, उसमें दो तरह के, फॉर एग्जांपल व्हेन यू आर पुटिंग द ब्लैंक ओवर हियर, तो व्हेन यू आर फोर्सिंग इट डाउनवर्ड, तो क्या हो रहा है, एक तो सर्कमफ्रेंशियल कंप्रेसिव स्ट्रेस होती है, दैट यू ऑलरेडी नो. जब आप इसको फोर्स करोगे डाउनवर्ड, तो सर्कमफ्रेंशियल कंप्रेसिव स्ट्रेस होती है, राइट, ऑन द पेरिफेरी ऑफ दैट पर्टिकुलर फ्लैंज. सो सर्कमफ्रेंशियल कंप्रेसिव स्ट्रेस, तो कंप्रेसिव तो होगी. एंड टेंशन कहां होगी, क्योंकि व्हेन दिस कप गोज इनसाइड, जैसे ये ड्रॉ होना शुरू हो जाएगा, ऐसे जाना शुरू हो जाएगा, सो ऑब्वियसली यू आर गोइंग टू हैव टेंशन. द होल ऑफ दिस पर्टिकुलर इज गेटिंग पुल्ड. तो एक तो हो गया, इट इज गेटिंग पुल्ड, दैट मींस टेंशन. एंड द अदर वन इज द इनडायरेक्ट कंप्रेसिव स्ट्रेस इन द फॉर्म ऑफ सर्कमफ्रेंशियल स्ट्रेस बोलते हैं हम उसको, दैट इज गोइंग टू बी. तो इट मीन डीप ड्राइंग में आपकी क्या होगी, टेंशन तो होगी होगी, क्योंकि आप पुल कर रहे हो डाउनवर्ड, एंड सर्कमफ्रेंशियल कंप्रेसिव स्ट्रेस, जो कि डायरेक्शन अगर मैं बताना चाहूं तो ऐसे होगी आपकी सरफेस परपेंडिकुलर टू दिस. इस पॉइंट पे बताऊं कहां पर, परपेंडिकुलर टू यू, सर्कमफ्रेंशियली दैट वे, हर एक पॉइंट के ऊपर सर्कमफ्रेंस के ऊपर, राइट. सो इट इज गोइंग टू बी डी. So I think then this is the correct option only. Okay, go to next one. ये जो है using slab method of analysis, die pressure is calculated. In this case, I think you don't need to go in detail, but at least आपको इतना पता होना चाहिए कि you are going to have this. देखो, two ways of, or rather I will say this way, you are having different methods of calculating the force, whether it is in extrusion or किसमें, whether it is in extrusion or whether it is in wire drawing or maybe other process also. एक मेथड तो वो है जो हम यूज कर रहे हैं नॉर्मली, फॉर एग्जांपल वर्क डन पर यूनिट वॉल्यूम, जो फॉर्मूला है डायरेक्टली वो यूज कर रहे हैं. सेकंड जो है हम क्या कर रहे हैं, उसका डिटेल एनालिसिस करें. फॉर एग्जांपल इसके स्लेव मेथड एनालिसिस है. बेस्ड अपॉन दैट आल्सो वी कैन ट्राई टू एस्टिमेट. करेक्ट वैल्यू कोई नहीं देगा, राइट? कोई मेथड आपको जो इज नॉट गोइंग टू द एग्जैक्ट एंड एग्जैक्टली करेक्ट वैल्यू. नो मेथड इज गोइंग टू गिव यू. सो दैट इज व्हाई वी आर हैविंग द डिफरेंट अप्रोचेस. सो जो एक कन्वेंशनल अप्रोच है उसके फॉर्मूले तो हमने देखे ही हैं, बट of this approach also at least we should know the formula. I think that much is required so that at least अगर वो question frame कर दे in GATE, you must be at least able to handle it. आपको पता हो कि मैंने इस तरह का कुछ फॉर्मूला देखा है, and you must be, because sometimes I don't know, I don't exactly remember, but 3 or 4 years back, 2-3 years back, there was one question from wire drawing. Wire drawing का मैं क्वेश्चन लूंगा आपको on the similar line. उसने सिंपली फॉर्मूला दे दिया, एवरीथिंग वाज गिवन इन दैट पर्टिकुलर क्वेश्चन. मतलब वो फॉर्मूला भी दे दिया, सारी एक्सप्लेनेशन भी दे दी, वैल्यू भी दे दी, और आपको कहा कि कैलकुलेट करो समथिंग फोर्स एंड ऑल दैट. अब थिंक ऑफ सिचुएशन जिसने देखा ही नहीं होगा, सिंपली देखा भी नहीं है फॉर्मूला, तो यू विल गेट फ्राइटन्ड बाय द मियर लुक ऑफ दैट फॉर्मूला. आपको बड़ा सा फॉर्मूला लगेगा, आप बोलोगे कि तो मैंने कभी देखा ही नहीं, एंड यू विल नॉट ट्राई इट. अदरवाइज दैट वाज द, आई थिंक आई कैन से दैट वाज द सिंपलेस्ट क्वेश्चन इन दैट पर्टिकुलर सेट, क्योंकि उसमें केवल कुछ करना ही नहीं था, सिंपली वैल्यूज इनपुट करनी थी. बट मोस्ट ऑफ यू may have not done that because you may not have seen. जिसने थोड़ा बहुत फॉर्मूला देख लिया हुआ, you would have attempted it. Okay, now ये जो है, ये क्या है, एक्सट्रूजन है. इट मींस एक्सट्रूजन रेशियो दी है, इट मींस टॉकिंग अबाउट द एक्सट्रूजन, राइट? सो एक्सट्रूजन में लेट मी जस्ट राइट दिस वैल्यू. मैं लिख लेता हूं टोटल एक्सट्रूजन प्रेशर. ऐसे लिख सकते हो आप, इफ यू वांट टू राइट यू कैन राइट इट. टोटल एक्सट्रूजन प्रेशर एज पर दिस मेथड, एक्सट्रूजन प्रेशर और स्ट्रेस भी बोल सकते हो, व्हाटएवर वे यू कॉल इट. कितना होगा? एक तो होगा आपका एक्चुअल, सी एक्सट्रूजन में इफ यू टेक इनटू अकाउंट द फ्रिक्शन आल्सो, तो फ्रिक्शन को भी काउंट में लोगे तो दो, you need to apply the force to overcome two things. What? One is to actually deform the material, that is the one force that is required, and the other one is to overcome the friction between the die and the workpiece interface. ये दो रीजन चाहिए आपको, राइट? तो जो टोटल एक्सट्रूजन प्रेशर है, that is going to be extrusion pressure needed to actually deform the material. To deform the material, you can write it down, जिसको हम सिग्मा डी से नोट कर सकते हैं कि एक्चुअल मटेरियल को डिफॉर्म करने के लिए, मान लिया ये डाई में है, सो वन इज कि इफ आई एम अप्लाइंग एनी प्रेशर और फोर्स फ्रॉम दिस साइड, तो एक्चुअल जो मटेरियल डिफॉर्म हो रहा है एंड गोइंग थ्रू इट, हाउ मच इज दैट फोर्स और प्रेशर दैट यू नीड अप्लाई, दिस मच. द अदर वन इज that is pressure you need to apply in order to overcome the friction between the die and workpiece interface over here. तो वो भी चाहिए होगा. So that is what we are extrusion pressure. प्रेशर बोल लो, स्ट्रेस बोल लो, फोर्स बोल लो, अगर फोर्स के टर्म में लिखते हैं तो that way also we can do done. Pressure, sorry, extrusion pressure to overcome container billet interface, container billet interface friction, right? तो ये ओवरकम कर, लेट्स से मैं इसको F बोल देता हूं. इट इज अप टू यू हाउ यू डिनोट इट. ये दो चीजें मुझे चाहिए, राइट? अब मुझे जानना, व्हाट आई नीड टू नो, आई नीड टू नो दिस वन, आई नीड टू नो दिस वन. तो इसका जो फॉर्मूला है दैट आई विल राइट इट डाउन ओवर हियर. सिग्मा डी जो है दैट इज सिग्मा 0 into 1 plus b divided by b 1 minus r raised पर b. नाउ इसको देख लो आप कैसे है. सो b over there is basically m cot है क्या? ये m cot alpha is normally, I don't know what is the notation, but डिपेंडिंग अपॉन विच बुक यू आर रेफरिंग, दिस इज म्यू कोटेंजेंट अल्फा है ये। इसमें क्या है, अल्फा इज द सेमी डाई एंगल, जो डाई मान लिया डाई इस शेप की है, लेट्स से इफ इट इज कॉनिकल शेप ऑब्वियसली इट इज गोइंग टू बी ऑफ दैट शेप। सो ये जो एंगल है ये हाफ ऑफ दिस एंगल, ये वाला एंगल, ये अल्फा है, टोटल एंगल इज 2 अल्फा। सो टोटल एंगल 2 अल्फा, तो दिस एंगल इज अल्फा। So this is semi diangle which is denoting with A, and M over here is basically the coefficient of friction. M he has he mentioned somewhere, yeah mention नहीं किया है, but M means coefficient of friction. So B जो over here है this is mu cotangent alpha. Same terminology we use in case of wire drawing also. And obviously R you already know, extrusion ratio that is A1 by A2 that you already know, right? Sigma 0 if you want to note it down, that is the yield strength of the work material. तो ये yield strength of the work material, ये formula आ जाएगा इसका. And what about sigma f? So sigma f लिख लो, even though यहाँ पर अगर आप देखोगे, if you want to find out the this answer, then you can just correctly now see this is going to this one, right? ये आपका आ गया. Let's say in this case he has ignored this one, उसने इसको ignore कर दिया है, right? So if it is not given then forget about it. But anyway for your reference just take it. इसको हम ऐसे लिख देते हैं L divided by D. Let's say complete formula ये रहेगा, where आपकी जो है वो shear stress होगी length and diameter. So अगर देखोगे tau is the shear stress between container billet interface, length L is the length of the billet, and D is the diameter of that particular billet. That's all, right? So just इसको फॉर्मूले को एक बार देख लो. Sometimes directly फॉर्मूला तो नहीं पूछेगा इस फॉर्म में, इस फॉर्म में he will not ask the direct formula in this format, but definitely as I told you sometimes कई बार क्या करता है वो बहुत बड़ा एक काइंड ऑफ न्यूमेरिकल लेंथी न्यूमेरिकल बना देगा इन टर्म्स ऑफ उसको रीड करोगे, बट वैल्यू सारी दे देगा. सो इफ यू आर एटलीस्ट फेमिलियर विद द फॉर्मूला, तो उस वक्त जो है वो यू विल नॉट हेजिटेट टू अटेम्प्ट दैट क्वेश्चन. आप कोशिश करोगे यहां पर, बट इफ यू हैव नॉट सीन तो आप से यू विल से ओके आई हैव नॉट सीन, दिस इज समथिंग डिफरेंट, सो यू विल नॉट ट्राई इट. ओके, सो जस्ट नोट इट डाउन, दैट्स ऑल. Okay, so that was the purpose of telling you this. Okay, let's now go to the next one. Okay, just see this particular question now. Okay, what it says, if the flow stress of the material is given by this, ideal work per unit volume will be how much? कुछ if you see it's pretty simple. मैंने आपको कहा था, I told you कि जो वर्क डन पर यूनिट फॉर्मूला है ना, उसको यू नीड टू रिमेंबर एंड यू हैव टू यूज इट इनवेरिएबली, राइट? क्या फॉर्मूला मैंने बताया था? वर्क डन पर यूनिट वॉल्यूम इज इक्वल टू सिग्मा मीन वैल्यू ऑफ फ्लो स्ट्रेस एंड नेचुरल लॉग ऑफ व्हाट, A1 by A2 और L2 by L1, जो भी लिखना है आपने लिखा था. इतना याद करने के लिए मैंने कहा था आपको कि दिस इज द वर्क डन इन एन होमोजीनियस this deformation, that means वो ideal work ही है. Now in this case what he's saying, he's asking you to calculate this one only, but the only difference is he has given you the variation of the normal. See, if you want to relate the things, you can relate the things very easily. अगर मैं आपको कहूं कि जो स्ट्रेस स्ट्रेन डायग्राम है, whatever the information area under the diagram है, that is the per unit volume information. For example, if you remember the strain energy concept, we say strain energy per unit volume is represented by the area under the stress strain diagram जब हम बात करते हैं, right? Whereas if simply we say strain energy, then we say it is represented in the force deflection diagram. So in this case also, if you see now, ये क्या है? ये approximation थी basically. ये है क्या है? If I ask you what is this? If I ask you what is this? This is strain only, isn't it? Strain ही तो है ये. If I write it this way, sigma true into strain only. कौन सी strain? True strain. Which strain? True strain only. This is what you have. But actually ये सिंप्लीफाइड है, हमने अपनी ईज के लिए इसको सिंप्लीफाई कर दिया. वी हैव टेकन द मीन वैल्यू ऑफ द फ्लो स्ट्रेस. बट अगर मैं आपको डायग्राम दूं ट्रू स्ट्रेस और स्ट्रेन का, सो बेसिकली समथिंग कुछ भी इस तरह का कुछ डायग्राम है लेट्स से. सो basically work done per unit volume is the area under the diagram. So let's say if I deform the material from initial strain value epsilon 1 to epsilon 2, then what is the work done per unit volume? Then you will say that this is the area under this particular diagram. So ये area under the diagram कैसे लिखूंगा मैं? I will say the area under the diagram is going to be simply true value of the stress, which is a variable in this case because it is from every point it is varying. So we will say work done per unit volume is going to be true value of the stress multiplied by the strain. Strain vary कर रही है and strain varying from epsilon 1 to epsilon 2. तो ये क्या हो गया? If you see this becomes the area under the diagram. ये area under the diagram ही है. Right now इसी फॉर्म में अगर मैं लिखना चाहूं इसको तो आई कैन डू इट दिस वे सिंपली. अगर मैं इसको ओरिजिनल फॉर्म में लिखना चाहता हूं आई कैन राइट इट दिस वे सिंपली. वर्क डन पर यूनिट वॉल्यूम विल बी इक्वल टू व्हाट? ट्रू वैल्यू ऑफ द स्ट्रेस व्हिच इज वेरिएबल. ये जो वैल्यू है ये वेरिएबल नहीं है, ध्यान रहे. ये हमने सिंप्लीफाई किया, कांस्टेंट वैल्यू है. मीन वैल्यू ऑफ फ्लो स्ट्रेस, दैट मींस मीन वैल्यू ना एवरेज वैल्यू ले ली हमने अपनी कन्वीनियंस के लिए इस फॉर्मूला में. इसलिए कहीं भी जो भी आपका जो हमने डिस्कस किया वहां पर वो वेरिएबल वैल्यू नहीं देता, वो ही इज गोइंग टू गिव यू द कांस्टेंट वैल्यू ऑफ दिस. तो ये कांस्टेंट वैल्यू हमने अपनी कन्वीनियंस के हिसाब से उसको क्या कर दिया था? मॉडिफाई कर दिया था. बट एक्चुअल में इट वाज अ ट्रू वैल्यू ऑफ स्ट्रेस व्हिच इज वेरिएबल इनटू डी एप्सिलॉन थी एंड वेरिंग फ्रॉम इनिशियल स्ट्रेन वैल्यू टू फाइनल स्ट्रेन वैल्यू टू व्हिच आई डिफॉर्म्ड दिस. ये एक्चुअल फॉर्मूला था. इस फॉर्मूले को मैंने क्या किया था? मॉडिफाई कर दिया था. आई मॉडिफाइड दिस. देखो इसको मैं इंटीग्रेट करता हूं. देखो अगर इफ यू वांट टू सी दैट वे, लेट्स से इसको मैं कांस्टेंट मान लेता हूं. ठीक है, लेट्स से इफ आई अज्यूम इट कांस्टेंट एंड तो ये ऐसे आ जाता था. देखना इसको कैसे लिख सकता हूं मैं फिर. इसको कांस्टेंट मान लिया मैंने, तो लेट्स से मैंने बोला एवरेज वैल्यू, तो इसको बाहर निकाल दूं. सिग्मा ट्रू, इफ यू डोंट वांट टू रिमेंबर वो छोड़ दो, बट जस्ट कि कैसे आया था ये बताना चाह रहा हूं मैं. ये कांस्टेंट वैल्यू होगी, बाहर आ गया. एंड अंदर मैंने क्या किया था? इसको मॉडिफाई किया था. दिस वाज द ट्रू स्ट्रेन. तो मैं कैसे लिखता हूं? dl बाय द चेंज इन लेंथ टू द इंस्टेंटेनियस लेंथ. सो अगर मैंने इसको इफ आई एम राइटिंग दिस वे, देन आई नीड टू चेंज द लिमिट्स आल्सो. देन आई नीड टू चेंज द लिमिट्स फ्रॉम L1 टू L2. करो इसको इंटीग्रेशन. सिग्मा ट्रू मीन इनटू नेचुरल लॉग ऑफ व्हाट? L into L1 to L2. So it was true value of the strain which was mean and natural log of what was that? Initial L2 by L1. हाँ ठीक है यही तो था. It was the same thing. So इसको मैंने ऐसे लिख दिया, L2 by L1 को A1 by A2 लिख दिया. बात एक ही है. Got my point? Okay. Now if that be the case, ये इतनी अंडरस्टैंडिंग आपको ध्यान रखनी कि मैं ये जो लिखा है कहां से ऑब्टेन किया? बेसिकली यहीं से ऑब्टेन किया है. वेयर आई एम हैविंग दिस ट्रू वैल्यू ऑफ द स्ट्रेस एज वेरिएबल. यहां पर ये बार का मतलब है कि मैंने मीन ले लिया, एवरेज वैल्यू ले ली और कुछ नहीं है. ओके, नाउ आई एम रिमूविंग द होल थिंग एंड कीपिंग दिस वैल्यू. इसको वेरिएबल ला रहा हूं एंड दैट्स माय जॉब विल बी डन. अब देखते हैं ऐसे, वहीं से आई एम टेकिंग इट, सॉरी, sigma true which is variable d epsilon and epsilon 1 to epsilon 2. ठीक है. now he has given you, let me अपनी फॉर्मेट में ले आता हूं मैं इसको. ये बार उसने लगा दिया बट कैरीज नो मीनिंग. वेरिएबल वैल्यू ट्रू वैल्यू ऑफ स्ट्रेस है ये, तो आई कैन राइट इट दिस वे. ये यही है, ट्रू इक्वल टू अल्फा एप्सिलॉन स्क्वायर प्लस सी. ये दिस आई एम राइटिंग दिस वे. ओके, बिकॉज माय जो जिस फॉर्मेट में मैं लिखता हूं आई एम राइटिंग दिस वे. Now this true value is varying this way. True value stress is varying this way. So input this value over here. So simply I am writing alpha epsilon square plus c constant है जो कि and d epsilon 1 to epsilon 2. Now see this value. You are going to have integrate करो इसको. When you will integrate it, alpha epsilon raised to power 3 divided by 3 plus c into epsilon and you are going to have the limits epsilon 1 to epsilon 2. Since no information is given, let us say from epsilon 1, let's say epsilon 1 0 है, right? So उस केस में क्या होगा ये? This value will become, this term will turn out to be what? If this is epsilon 1 is 0, then you're going to have this one as epsilon 2 cube divided by 3 plus c epsilon 2 क्या है? ये यही आएगा. This is going to be this one. So either you write it epsilon 2, or either you can write it in terms of simply epsilon also, or you can write it this also, alpha epsilon raised power 3 divided by 3 plus c epsilon, meaning is same. ठीक है? If you will say that okay, why you have taken epsilon 1 as 0? देखो जब भी हम डिफॉर्म कर रहे हैं तो प्लास्टिक जोन जो है ना, that something this way. So he has not given me the information from where I am deforming. Have I deformed that material initially or not? True strain, initial true strain. What is that initial true strain? कुछ नहीं बताया. He has not given any information whether you have deformed that material initially or not. When you are not deformed that initially, or even if he has deformed it initially, तो ये जो strain है, there is very small over here. तो इसलिए कुछ मेंशन नहीं किया है, but then interpretation comes okay, because he has not mentioned whether that material was initially strained or not, deformed or not. If not is given, then epsilon 1 is 0. So then I can write it this way. ठीक है? So this is how you are going to be do this. अब ये ध्यान रहे कि कैसे, जैसे मैंने कहा था आपको, ये फॉर्मूला जो है that is going to be quite helpful for you. अब ये क्योंकि इसने he has mentioned this true, he has mentioned by sigma bar, epsilon he has mentioned epsilon bar, so you can write it this way also, epsilon bar, that's all, no issue. Am I clear? So that is how you have to do this. That understanding will come if you have understanding of this and understanding of this. Potential question. So it's not difficult. Okay, it's not difficult, right? In the sense कि अगर ये term आपको clarity नहीं है थोड़ी सी, तो थोड़ा सा I think you may face the hurdle. But see, many of you, क्योंकि many of you have approached to find out the value of that drawing force and force for extrusion in different way, because I have used this method this way, so maybe I may be more familiar with this, and therefore I can relate this concept to this one. Maybe some of you may not have approached this way, so you may be missing this formula then. So if I have missed, then you can just definitely go through this also. Okay, go to the next problem now. I think ये related ही ऐसे, so you can just try it out. What he has given you, ये जो वैल्यू है ना आपकी, जो इसने दी है, that is the epsilon raised power point, epsilon bar है. This is not negative value. That is not negative value. Okay, that is epsilon bar. epsilon bar raised power 0.25. तो इसको मैं ऐसे डिनोट कर देता हूं, सिग्मा ट्रू okay. So what I'm doing is sigma true value of stress, because he has very clearly mentioned consider metal whose strain hardening behavior is as follows. That means this is not the mean value, keep it in mind. So this is the true value of strain hardening behavior. मतलब क्या हुआ? What is the meaning of strain hardening behavior? He's talking about this region, true stress strain diagram. ये strain hardening starts from here, so he's talking about this region, right? So how is displaying this curve? This way is equal to 250 epsilon raised power 0.25. Let's say you write it this way. That's all. In simplified format. It's an annealed bar, that is annealing has been done, pulled in extension from initial to this, and what is the work per unit volume? आपको जो है वर्क पर यूनिट वॉल्यूम निकालना है. दैट्स ऑल. प्रीटी सिंपल ना हो. ये लास्ट का ही क्वेश्चन अगर देखो उसी ऑन द सिमिलर लाइंस. सो वर्क डन पर यूनिट वॉल्यूम कैसे था? वर्क डन पर यूनिट वॉल्यूम, व्हाट वाज दैट? वर्क डन पर यूनिट वॉल्यूम वाज, हमने कहा ट्रू वैल्यू ऑफ स्ट्रेस इनटू डी एप्सिलॉन, दैट इज हाउ वी सेड, एंड एप्सिलॉन 1 टू एप्सिलॉन 2. यही तो किया हमने. इंस्टेड ऑफ दैट राइट द वैल्यू ऑफ दिस सिग्मा ट्रू, दैट्स ऑल. कुछ नहीं करना है हमने. So simply write the value of this and epsilon 1 0, because no information is given whether that material has been initially strained or not, right? So इसका मतलब ये हुआ कि can I say 0 to epsilon, simply epsilon लिख लो, epsilon 2 जो भी लिखना है, it carries no meaning. So 250 एप्सिलॉन रेज पावर 0.25 इंटू डी एप्सिलॉन। सो ये वैल्यू क्या आ जाएगी आपकी 250 इंटू, क्योंकि एप्सिलॉन नहीं बचा तो आई कैन से दैट एप्सिलॉन 1.25 divided by 1.25. That's all. 0 to epsilon 2. Either you write it epsilon 2 or epsilon 1. It is up to you. Epsilon 2 मतलब final strain. So तो मैंने यहाँ से निकाल सकता हूँ. So if you want to write to epsilon 2, you can write epsilon 2 also. ठीक है? Rest just epsilon. Can I find out the total true strain? Can I find out the total true strain? Of course I can find out because he has given you the ये. So epsilon 2 or epsilon simply is what? The natural log of A1 by A2. That is what? So natural log of A1 कितना है? 5/4 d square. So it is 12.7 divided by 11.5 square, right? Diameter है तो 5/4 cancel हो गया. So epsilon 2 is how much? Epsilon 2 आया मेरा 0.1985. ठीक है? Done? That's all. Input करो और you are going to get the value. अब unit देख लेना. That's all. So just input the value. So I'm inputting that value over here 250. ध्यान रहे कि ये मेगापास्कल में है ये टोटल वैल्यू. तो टोटल वैल्यू I'm going to get in मेगापास्कल. Epsilon 2.1985 रेज पावर 1.25 1.25 ये वैल्यू आई मेगापास्कल में. कितनी आई? जस्ट गेट इट डन. सो 26.49. नाउ दिस वैल्यू इज इन न्यूटन पर mm स्क्वायर. ओके, ये न्यूटन पर mm स्क्वायर में आपकी वैल्यू आ गई. अब इसको कन्वर्ट कर दो बिकॉज ही इज आस्किंग टू कैलकुलेट मीटर क्यूब. सो कन्वर्ट इट इनटू मीटर क्यूब. ओके, सो आई कैन पहले इसको मीटर स्क्वायर में कन्वर्ट कर दो. सो मीटर स्क्वायर मींस 1000 एंड इट इज स्क्वायर सो इट बिकम 6. सो 26.49 into 10 raised power 6, right? So this becomes what? Newton per meter cube. Sorry, Newton per meter square. Newton per meter square. So what I did is I converted mm square to meter square. So 1000, that is 10 raised power minus, it was 10 raised power minus 3 square down there. So when I take it over there in numerator, so it becomes 10 raised power 6. So it becomes meter square. Now rest is just simply the manipulation. What is asking? Mega Newton meter per meter cube. So can I say first convert it, or can I write it this way also? Newton meter divided by meter cube, meaning same. Newton per meter square is what? Newton per meter square is Newton meter per meter cube only. Meter will cancel out, it will go on main. And this is what? Mega. So this becomes mega Newton meter joule per meter cube. So you're going to have 26.49 what? Mega 10 raised power 6 is mega Newton meter per meter cube. So it means or megajoule per meter cube. That's all. So this becomes 26.5 he has given you. This is simply the manipulation of this. So I hope that questions could be framed in these lines. See, एक टॉपिक ऐसा है खासकर मेटल फॉर्मिंग में, व्हाट आई अंडरस्टैंड इज वेयर ही क्रिएट्स द मैनिपुलेशंस. बाकी टॉपिक्स जो है रिलेटिवली स्ट्रेट फॉरवर्ड है. दैट इज ऑफ वायर ड्राइंग. नॉर्मली इन वायर ड्राइंग ही normally basically clubs the concept of your this strength of material and then particularly this true stress strain concepts, right? So I think these are the some of the areas, gray areas where he can venture into. हर साल अगर देखोगे जब भी आपने उसने मेटल फॉर्मिंग में whenever he has to make the question difficult, normally वो क्या करता है वायर ड्राइंग में कुछ ना कुछ नया क्रिएट कर देता है. And something not new, but it is the basic concepts only. And these areas I think are the potential areas from where in future question could be framed. So ये दो questions I think they are going to be quite useful for you. And basic मैंने आपको already पहले explain कर दिया था उसका. दो तीन question जो last दो तीन question मैंने explain किए. Okay, should we go ahead now? Okay, let's go ahead. Okay, just go through the question. So इन वायर ड्राइंग ऑपरेशन, ओके इसमें मैंने मॉडिफिकेशन कर दी है, हैव आई डन दैट मॉडिफिकेशन? यस यस, मॉडिफिकेशन एफ, यस यस आई हैव डन इट, ऑलरेडी डन इट, ओके कोई बात नहीं. So in a wire drawing operation, if the pull force is this, that is the drawing force. Pull force means drawing force is applied for conducting the operation. A0 initial cross section, final cross section AF दिया गया है आपको, and A या alpha. Anyway, यहाँ पर alpha या जो भी है, this is alpha, you can say. Alpha is the die angle. Okay. Then actual work done per unit volume will be given by इस wire drawing में स्ट्रेट फॉरवर्ड तो नहीं निकलेगा, बट हाँ बेसिक अंडरस्टैंडिंग अगर है तो वहां से आप रिलेट कर सकते हो वर्क डन पर यूनिट वॉल्यूम और उससे अगर जो मैंने कहा था आपको. फॉर एग्जांपल इन वायर ड्राइंग में, इन वायर ड्राइंग आपने फॉर्मूला निकाला था ड्राइंग फोर्स का, क्या था? इट वाज A2, राइट, इफ आई रिमेंबर एग्जैक्टली, ट्रू, एंड नेचुरल लॉग ऑफ व्हाट, A1/A2. ठीक है, am I correct? Yes, right. ये ड्राइंग फोर्स है. वर्क डन पर यूनिट वॉल्यूम आल्सो यू कैन मेंशन हाउ you can write the work done per unit volume in terms of mean value of this natural log of, यही कहा था, natural log of A1/A2, यही है ना, सेम थिंग. सो अब देखो सिग्मा ट्रू नेचुरल लॉग ऑफ A1/A2 वो यहां भी अपीयर हो रहा है कि नहीं? सिग्मा ट्रू नेचुरल लॉग ऑफ A1/A2, दिस पार्ट ऑब्टेन तो हमने वहीं से किया था रादर. सो आई थिंक इट इज इजी टू कोरिलेट एंड इमीडिएटली गेट द वैल्यू जो यहां पूछ रहा है वो. सो आई थिंक A2, therefore I can say FD ड्राइंग फोर्स और PD जो भी हमने डिनोट की थी A2 into what, वर्क डन पर यूनिट वॉल्यूम. ये क्या है? वर्क डन पर यूनिट वॉल्यूम ही तो है, वर्क डन पर यूनिट वॉल्यूम, that's all. So can I say that work done per unit volume in a drawing process can also be written in terms of the drawing force divided by the final. A2 here क्या है? Final, और FD divided by final cross section area. A2 क्या है? Final cross section area. ठीक है. सो कई बार क्या है कि चीजें, फॉर एग्जांपल लेट्स से ये क्वेश्चन आपको जो है उसने हैड इट बीन गिवन, आपको बेसिक है आपका, यू हैव ऑलरेडी नो दैट दिस इज वर्क फॉर्मूला क्या है एंड ऑल दैट. क्वेश्चन फ्रेम कर दिया उसने आपको, ही फ्रेम्स द क्वेश्चन टू यू, एग्जामिनेशन फ्रेम कर देता है, तो आप क्या करोगे? हाथ पांव मारोगे ऑब्वियसली, बिकॉज यू विल राइट दिस फॉर्मूला आल्सो, राइट. सो यू विल राइट दिस फॉर्मूला आल्सो, यू विल आल्सो ट्राई टू रेट ओके वर्क डन पर यूनिट वॉल्यूम क्या होता है, दिस इज दिस फॉर्मूला, एंड वंस यू राइट दैट it does the job. मतलब इतना ही है. फॉर एग्जांपल जब आप ट्राई मारोगे तो ऑब्वियसली यू विल राइट इट. ओके, उसने वर्क डन पर यूनिट वॉल्यूम लिखा तो यू विल राइट इट, डेफिनेटली विल राइट इट, एंड डेफिनेटली यू आर गोइंग टू राइट इट बिकॉज़ ही इज आस्किंग टू कैलकुलेट द फोर्स पर यूनिट वॉल्यूम, सॉरी दिस जो ड्राइंग फोर्स की बात कर रहा है इन वायर ड्राइंग, तो डेफिनेटली यू राइट द फॉर्मूला एंड देन यू विल ट्राई टू थिंक ओके यार कुछ रिलेशन है क्या इसमें. तो व्हेन यू विल थिंक देन इमीडिएटली यू विल स्ट्राइक ओहो दिस इज दिस एंड दिस पोर्शन इज द सेम थिंग ओनली, right? So that is how these things are going to be helpful. So or maybe manipulation, he can do the manipulation, but basic part if you are knowing, then I think you can tackle those questions in the examination also. Okay, बढ़े आगे. Okay, let's go to the next question. See this question. Okay, for initial setup of wire drawing operation, wire reduction of the end zone is done by, do you know answer? क्वेश्चन समझ लो, जस्ट अंडरस्टैंड द क्वेश्चन क्या है. कई बार आप क्वेश्चन समझते भी नहीं हो, सो यू कैन कमिट द मिस्टेक. जस्ट अंडरस्टैंड दिस क्वेश्चन. क्या बोल रहा है ये? वायर ड्राइंग, यू नो क्या बोल रहा है ये कि ये वायर ड्राइंग है, राइट? आपने बार लिया, ये डाई है आपकी, अब इस बार को आप इस डाई में कैसे डालोगे, हाउ यू आर गोइंग टू पुट दिस बार, क्योंकि इसका डायमीटर तो ज्यादा है, यहां पर कम है, हियर इज स्मॉल। तो इनिशियली जो बार है आपका वायर रॉड जिसको हम बोलते हैं वायर रॉड, हाउ विल इनपुट दिस वायर रॉड इनटू दिस ड्राइंग डाई, यू कैन नॉट। क्यों? क्योंकि यहां पर डायमीटर कम है, एक बार प्रोसेस शुरू हुई उसके बाद तो आप खींच रहे हो, देन इट विल गो ऑन ग्रेजुअली रिड्यूसिंग। तो शुरू में मैं क्या करना पड़ेगा, मुझे इस पोर्शन का डायमीटर क्या करना पड़ेगा, कम करना पड़ेगा। सो हाउ टू रिड्यूस द डायमीटर ऑफ दिस पोर्शन, तो हमारे पास एक प्रोसेस होती है स्वेजिंग। स्वेजिंग कुछ नहीं है, इट दे आर डाइज काइंड ऑफ, फॉर एग्जांपल ये है राइट, ये डायमीटर है यहां पर, तो मैं क्या कर रहा हूं, यहां पर डाइज होती हैं, यहां 3 भी हो सकती हैं, 4 भी हो सकती हैं मे बी। सो यू आर अप्लाइंग द फोर्स ओवर हियर, तो इस तरफ से अप्लाई करोगे, यहां भी अप्लाई करोगे, यहां भी अप्लाई करोगे। सो बेसिकली यू विल अप्लाई द कंप्रेसिव फोर्स ऑन ऑल द डायरेक्शन, और इसको रोटेट भी करता रहेगा ये, सो दैट वे एंड पोर्शन यू विल उसका डायमीटर कम कर दोगे, समथिंग दिस वे, राइट, कम कर दिया आपने। वंस इट इज डन, so then you will put it inside it over here and now you can hold it. So once this wire with the reduced diameter, अगर आपने इसको reduce कर दिया something this way and say ये, let's say initially this portion you reduce to this one, now you can insert it over here and then now I can pull it from here, I can hold it and pull it over here. So ये जो काम है initial काम कौन करेगा, क्या process है, which process, what is the process which basically reduces this diameter, तो उस process को नाम दिया है swaging, right? So I already explained you with the help of this. अगर देखना चाहते हो something this way it looks like, right? For example, you are having the dies, ये rotate, इसको rotate करोगे workpiece को, and these are the dies which can apply the pull, the force in all direction, rotate भी कर रही हैं, and actual में अगर आप देखना चाहते हो these are the dies, they can apply push, something this way. That's all. So once it has got reduced, अब क्या करो उसको, you just insert into the die from the other end, start pulling it. So this process we call it as a swaging process. ठीक है, ओके, वी आर नॉट बॉदर्ड इन फीड स्वेजिंग, द स्वेजिंग, प्लंज स्वेजिंग नॉट रिक्वायर्ड फॉर यू, सिंपली आपको इतना कम से कम पता हो कि स्वेजिंग क्या है, दैट्स ऑल। गो टू द नेक्स्ट। चेक करो उसको, जस्ट सी दिस क्वेश्चन एंड ट्राई टू आंसर मी, गिव मी आंसर, इस क्वेश्चन को देखो एंड गिव मी द आंसर। Which of the following is not true regarding the power law behavior? ये जो आपको behavior rather जो equation दी है, what is it? It is Holomon relationship. Am I correct? Or you can say ये जो power law है, ये किसके लिए? We are talking about what? We are talking about the true stress strain diagram. ट्रू स्ट्रेस स्ट्रेन डायग्राम, और ये ट्रू स्ट्रेस है, ये जो इक्वेशन दी गई है आपको, दिस इज अ सिग्मा टी आर इक्वल टू के एप्सिलॉन रेज़ पावर एन, ये है, दिस इज सिग्मा टी आर इक्वल टू सिग्मा ट्रू इज इक्वल टू के को इसने एक्स डिनोट किया है, एप्सिलॉन रेज़ पावर एन, एप्सिलॉन ट्रू स्ट्रेन एंड एन आपको पता है एक्सपोनेंट। नाउ ट्राई टू इंटरप्रेट दिस इक्वेशन। Not true. Keep it in mind, he is asking not a true. True नहीं पूछ रहा वो. He is not asking true. Not true. Okay. This is your stress strain diagram. Okay. और ये तो आपको पता ही, you already know. This is a conventional stress strain diagram. I'm interested in this true stress strain diagram in plastic region. Plastic region में मेरा इंटरेस्ट क्या है? ट्रू स्ट्रेस ट्रू स्ट्रेन कर्व का है ये. I'm not talking about this because you know we are not dealing with this in metal forming. We are dealing with this. Now ये जो रिलेशनशिप है, होलोमोन रिलेशनशिप, ये कहां तक वैलिड है? See, जैसे यहां पर यू आर गोइंग टू हैव द अल्टीमेट, वैसे ही मैक्सिमम लोड के कॉरस्पॉन्डिंग कहीं पर यहां समवेयर हियर, जिसको हमने कुछ एक व्हेन वी डिस्कस्ड सम ऑफ द न्यूमेरिकल्स अर्लियर, we denoted, I said that this is ultimate, you can say, but carries, okay, you can denote it that way, the value of the true stress corresponding to maximum load, that way I can say. और if I say that which is the metal forming range, किस रेंज में हम काम करते हैं, इसके बियॉन्ड तो क्या है, इसके बियॉन्ड या इसके बियॉन्ड क्या है, उसके बियॉन्ड तो नेकिंग है, मटेरियल स्टार्ट्स ब्रेकिंग, इट इज यूजलेस फॉर मी, बॉन्ड्स स्टार्ट्स ब्रेकिंग सिग्निफिकेंटली, नेकिंग फॉर्मेशन हुई और टूटने की कगार पे है वो, सो इट इज नॉट रेलेवेंट फॉर मी। तो उसके लिए मेरा जो है जो होलो बॉन्ड रिलेशनशिप है, हाँ कहां से, जब यहां से ऑलमोस्ट इट स्टार्ट्स डिविएटिंग, देन दिस portion of the curve which is useful for me, and in this portion actual deformation of the material is takes place. In this portion we actually deform the material in the plastic deformation processes, इस रीजन में, that is till the maximum load, वो मेरा एरिया ऑफ इंटरेस्ट है। तो इसके बाद जो कर्व है, that is a, we call this region as a region of instability। तो इसके लिए ठीक है, कर्व तो आपका ट्रू स्ट्रेस स्ट्रेन की है, बट जो ये होलो बॉन्ड रिलेशनशिप डिफाइंड है, दैट इज विद इन दिस रीजन, दैट इज द सिग्मा ट्रू इज इक्वल टू के एप्सिलॉन रेज पावर n, दिस रिलेशनशिप इज वैलिड ओनली अप टू दिस पोर्शन टिल दिस पॉइंट, नॉट बियॉन्ड दैट। बियॉन्ड दैट तो इंस्टेबिलिटी का रीजन है। हाँ, बियॉन्ड दैट अगर डिफाइन करना चाहते हो, यू develop your own equation, or maybe some may have discussed, that is some investigators must have studied that behavior also, and they may have also given its laws also, but that region is only important because it starts breaking, then for that purpose they may have studied, but ये जो रीजन है वो किसके लिए इंपॉर्टेंट है, मेरे लिए इंपॉर्टेंट है प्लास्टिक डिफॉर्मेशन प्रोसेस के लिए, तो उसको किससे डिफाइन किया मैंने, इससे। सो ये वैलिड नहीं है इसके बियॉन्ड, ये वैलिड नहीं है इसके इस तरफ, अप टू अ सर्टेन मिनिमम, दैट मींस व्हाई, बिकॉज जो प्लास्टिक डिफॉर्मेशन कर्व है ये तो ऑलमोस्ट इलास्टिक रीजन कर्व है, यहां तक this true stress and conventional stress diagram almost overlaps. So after certain strain, when the curve deviates from here, then to define this curve, one investigator called as Holloman gave an equation called as Holloman equation, जिसको हमने पावर लॉ भी बोला, वो ये है। अब देख लो, डिस्क्राइब फ्लो ऑफ द स्ट्रेस फॉर ऑल स्ट्रेन्स, सारी स्ट्रेन्स के लिए डिफाइन नहीं करता ये, इट डजंट डिफाइन फॉर द स्ट्रेन beyond this, it does not define the strain within the elastic limit, ये वैलिड है प्लास्टिक रीजन में, तो ये तो आपकी करेक्ट नहीं है, एंड दैट इज व्हाट ही इज सेइंग इज नॉट ट्रू। तो एज पर दिस अब ये ट्रू है, डिस्क्राइब्स फ्लो स्ट्रेस बिहेवियर ओनली अंटिल यूटीएस, रादर ये जो टर्म यहां पर होना चाहिए था, इट शुड हैव बीन द व्हाट, it should have been what, it should have been the till the maximum force, but anyway लूजली अगर हम यूज करना चाहे कोई बात नहीं, पर फिर भी हम बोल सकते हैं इट इज ओके। डिस्क्राइब फ्लो स्ट्रेस बिहेवियर बियॉन्ड ए सर्टेन मिनिमम स्ट्रेन, बियॉन्ड ए सर्टेन मिनिमम मतलब यहां से हम डिफाइन कर रहे हैं इसको, इसके इस तरफ नहीं, इनिशियल पोर्शन में नहीं है। फ्लो स्ट्रेस इंक्रीजेस विद इंक्रीजिंग स्ट्रेन, वो तो है ही, जैसे स्ट्रेन इंक्रीज होगी यहां पर पहुंचा, फ्लो स्ट्रेस इज दिस, व्हेन आई एम ओवर हियर स्ट्रेन बढ़ रही है तो स्ट्रेस भी बढ़ रही है, स्ट्रेन बढ़ी स्ट्रेस भी बढ़ रही है, ट्रू स्ट्रेस। तो एज पर दिस, ठीक है, दैट इज हाउ यू हैव टू अंडरस्टैंड, बड़े ओके। सो नाउ वी कैन गो अहेड। नाउ ये which one is this, 24th, I think it is 24th, okay, right. Now for this in wire drawing, what is the drawing stress? In wire drawing, what is the drawing stress? If I ask you, sorry, ये फॉर्मूला मेरे पास है, आई एम हैविंग दिस फॉर्मूला. इन वायर ड्राइंग व्हाट इज द ड्राइंग स्ट्रेस? आप बोलोगे दिस इज द ड्राइंग फोर्स, दिस इज द exit diameter, so this is A2, this is a drawing force, so drawing force divided by the exit diameter, that becomes this divided by this becomes the drawing force or drawing stress, sorry, this becomes drawing stress. So I can say this is a drawing stress that I can find out. But is this equation valid in this case? But is this equation valid in this case? No, because he's talking about the friction also. He has given you the value of friction also. This equation is valid when there is no friction, homogeneous deformation hai. In that case, we can say this kind of ideal process, for that it is okay. उसके लिए हमने ये equation का use किया. But when friction is given, then I cannot make use of this equation. Then I have to make use of some other approach to find out those values of drawing stress and all that. And based upon that approach, we have that particular formula. तो जब आपका friction नहीं दी है, is not talking about anything about friction, then obviously definitely you can use these equations. But when he tells about that there is a friction also in the wire drawing, then how to find out the drawing stress? That value of drawing stress, you have to make use of this formula. अभी फॉर्मूला कहां से आया? दिस इज नन ऑफ आवर बिजनेस, बिकॉज आपको पूरी एक्सरसाइज करनी पड़ेगी उसके लिए, डिराइव करने के लिए. बट यस, इट इज इंपॉर्टेंट फॉर यू इन द सेंस दैट वी नो द फॉर्मूला एंड व्हाट आर द डिफरेंट टर्म्स एसोसिएटेड विद दिस, समथिंग दिस वे. ठीक है, ये आपको पता ही है ऑलरेडी. D1, D2. ठीक है. Okay, let me just write down the formula. That is, drawing stress is given by mean value of flow stress into 1 plus B 1 minus R2 by R1 2B plus R2 by R1 2B into sigma back pull. This equation seems to be something resembling with the earlier equation in extrusion, which I think we did one question. Okay, and there also I mentioned one thing that in wire drawing there was a question in one, I don't know, 2017 or something. उसने किया आपको ये पूरा फॉर्मूला दे दिया, ये पोर्शन नहीं दिया था उसने. What he did, he gave all the details, सब कुछ मेंशन कर दिया, B की वैल्यू, म्यू कोटेंजेंट अल्फा, all those R2 R1 something, everything was given, और साथ में ये फॉर्मूला भी लिख दिया उसमें. So what you had to do in that case, simply केवल वैल्यूज को इसमें डालना था and you had to get that value. That was all. But that was a surprise question. This was a surprise question that time, because sometimes कि हाँ, कई बार स्टूडेंट्स जो देखते भी नहीं है, इग्नोर कर देते हैं, तो they simply what he did, फॉर्मूला डाल दिया, सारी वैल्यूज दे दी और दे दिया. तो those who may have gone at least, किसी ने उसको देख लिया होगा या may have gone through that, then obviously they may have attempted it. So then it became very simple for them. For others it was become difficult. Anyway, so what could be the future possibility? Future possibility would exist in the form of like framing the question on this line, where values are given and formula is not given. You make use of that formula and all that. Now इसमें देखते हैं अब what are the things that you need to do. देखो इसमें जो है B म्यू कोटेंजेंट अल्फा, जैसे हमने उसमें देखा था, B की वैल्यू ट्रू मीन वैल्यू ऑफ फ्लो स्ट्रेस, या इसमें इस केस में बहुत करेक्टली मेंशन तो नहीं किया है, पर नॉमिनल वैल्यू ऑफ स्ट्रेस दे दी है. बट इन गेट डेफिनेटली ही विल give a clear statement about this stress. For us over here is the mean flow stress only. Otherwise he should have mentioned it clearly. Gate में वो करता है, वो क्लैरिटी काफी रखता है, तो don't worry about that. Rest is B. B you know, mu cotangent alpha. It is same as we had earlier. R2 R1, this is D1, D2, exit. I think this over here you're having B. B is sigma B. Sigma B is the stress due to back pull. Stress ड्यू टू बैक पुल. इसका मतलब ये हुआ कि अगर मैंने इस वायर रॉड को इस तरह से खींच के रखा है, लेट अस से टू कीप इट स्ट्रेट और समथिंग दैट वे, सो इन दैट केस देयर इज गोइंग टू बी अ सर्टेन अमाउंट ऑफ स्ट्रेस, जिसको उसने नाम दिया स्ट्रेस ड्यू टू बैक पुल. सो इफ ही हैज गिवन यू stress due to back pull, right? In that case you will use this. अगर कैलकुलेट करना चाहो तो डायरेक्टली भी निकाल सकते हो एरिया. फोर्स अगर उसने फोर्स या बैक टेंशन दे दी उसने, टेंशन मतलब इस तरफ खींच रहे हो, तो फोर्स डिवाइडेड बाय द क्रॉस सेक्शन एरिया, दैट वे आल्सो यू कैन कैलकुलेट. बट इफ ही हैज नॉट गिवन देन यू कैन इग्नोर दिस टर्म, होल टर्म. सो यहां पर भी उसने ही हैज नॉट मेंशन एनीथिंग अबाउट द बैक पुल, सो आई कैन इग्नोर इट. रेस्ट इज इन फ्रंट ऑफ यू. म्यू कोएफिशिएंट ऑफ फ्रिक्शन, एंड जो एंगल है दैट इज द अल्फा is semi diangle, semi half to alpha diangle. So semi diangle इसने अल्फा आपको देके रखा, this value he has given you, he has given you the value of semi diangle, that is alpha. mu उसने आपको देके रखा, just get the value. b की कितनी आ गई, mu कितना है, just और कुछ नहीं है इसमें, just simply the value input करनी है और कुछ नहीं. 0.04 multiplied by 1 by tangent. Okay, anyway I have calculated it. आप directly calculate कर सकते हो. cotangent alpha, alpha is how much, that is 10.1, and this value turns out to be 0.224. ये वैल्यू आ गई आपकी. बाकी आप इसमें इनपुट करो, जस्ट इनपुट एंड गेट द वैल्यू. just a minute. Okay, so I'm just inputting the value. Drawing stress is going to be true कितना है, 35 into 1 plus b, that is 0.224, divided by b. b is 0.224. 1 minus r2 by r1, तो इसको चाहे डायमीटर के टर्म में डाल दो, कोई फर्क नहीं पड़ता, बिकॉज ये भी हाफ हो जाएगा, ये भी हाफ हो जाएगा. सो इट इज r2 कितना है, r2 is 5.6 diameter, r2 5.6 divided by 2, or r1 6.25 by 2. So 2 will cancel out, so I can directly input the value. 5.6 divided by 6.25 into 2 into 0.224. That's all. Plus 0. Back pull is 0. No back pull is given to you. That's all. So here you're going to add as 9.18 megapascal. देख लो 9.17 जो भी आ गया आपके, ठीक है. सो ध्यान रहे, इसको इग्नोर मत करना पर्टिकुलरली, क्योंकि फॉर्मूला थोड़ा सा बड़ा है. समटाइम्स वी ट्राई टू इग्नोर, लीव इट, कोई जरूरत नहीं है, पूछेगा नहीं वो, एंड समथिंग लाइक दैट. डोंट कमिट द मिस्टेक. सिंपल फॉर्मूला है, केवल आपको टर्म पता होनी चाहिए, ऑल दैट्स ऑल. बाकी वी आर नॉट बॉदर्ड, इसके अलावा और कुछ पूछ नहीं सकता उसमें, ठीक है. ओके, सो ओके देन लेट्स गो टू द नेक्स्ट वन. Done. Okay. The true sliding strain for the low carbon steel bar, 25, right? 25. Okay. True sliding strain for low carbon steel bar which is doubled in length by forging. So forging does not simply mean that you are always going to reduce the length. जैसे फलरिंग है, तो फलरिंग प्रोसेस में क्या है, नॉट ओनली फलरिंग, आई थिंक दैट this other process, right? एक और प्रोसेस थी उसमें, that you were taking that material away and that time elongating it. So forging does not mean simply reducing the length. Like furring, you are increasing the length, right? Cogging, there is also one process called as cogging in forging, where you deform the material towards the ends. Furring में आप towards the middle, in cogging towards the end. Cogging down भी बोलते हैं उसको, right? So wherever you deform in those processes, आपकी elongation बढ़ेगी. So it is pretty simple. कुछ खास नहीं है इसमें. क्या है, आपकी लेंथ बढ़ रही है, simply you have to get it. So true strain, sliding strain. True sliding strain means true strain only for a low carbon steel bar which is doubled in length. So L2 is equal to 2L1. True strain क्या है? Natural log of L2 by L1. L2 by L1. L2 is 2L1. 2 double 2. It becomes 2. L1 will cancel. I think it is going to be 0.639. Am I correct? Yes. 0.693. Nothing special. Okay. वैल्यू पॉजिटिव, ध्यान रखना इसमें, ऑब्वियसली इट हैज टू बी पॉजिटिव इन द सेंस क्योंकि आपका जो है वो लेंथ क्या हो रही है, इंक्रीज हो रही है. हैड इट डिक्रीज तो ऑब्वियसली यू मे हैव टेकन इट एज ए, इट वुड हैव कम एज ए नेगेटिव, ऑटोमेटिकली उसमें नेगेटिव आ जाती है. इन दिस फॉर्मूला जो ट्रू स्ट्रेन का जो फॉर्मूला है नेचुरल लॉग वाला, उसमें ऑटोमेटिकली द वैल्यू विल कम पॉजिटिव और नेगेटिव डिपेंडिंग ऑन वेदर दैट लेंथ इज इंक्रीजिंग और डिक्रीजिंग. Okay, go at this. I think it is also on the similar lines, but nothing kind of. A rod of 1 meter is elongated to. Go ahead. A rod of 1 meter elongated to 2 meter. Okay, good. And after that is compressed to original length of 1 meter. फिर ले आए आप यहाँ पर. So 1 meter. फिर आपने इसको 2 meter में भेज दिया. And then compressed to original length of 1 meter. दोबारा आपने इसको compress किया, compressed and then again 1 meter. The true strain for elongation and engineering strain. True strain for elongation. The true strain for elongation and engineering strain for compression. कुछ नहीं बोल रहा है. ट्रू स्ट्रेन इस स्टेप में बोलता है आप क्या करो, ट्रू स्ट्रेन निकालो. फर्स्ट स्टेप के लिए ट्रू स्ट्रेन निकालो. व्हाट इज ट्रू स्ट्रेन इन दिस स्टेप. एंड इस स्टेप के लिए बोलता है व्हाट इज द इंजीनियरिंग स्ट्रेन. इस स्टेप के लिए व्हाट इज द इंजीनियरिंग स्ट्रेन, ये पूछ रहा है. प्रीटी सिंपल. ट्रू स्ट्रेन कैसे लिखते हो आप. ट्रू स्ट्रेन इज गोइंग टू बी नेचुरल लॉग ऑफ 2 मीटर, दैट इज L2 by L1. इस केस में बोल सकते हो आप, या नेचुरल लॉग ऑफ व्हाट 2 by 1. 2 by 1 which is 2 again 0.693. And what about this? He is asking you to calculate this as a change in length to the original length, right? So इस केस में सेकंड स्टेप में ओरिजिनल लेंथ कौन सी होगी, ये चेंज इन लेंथ क्या हुई 1 by फाइनल लेंथ. फाइनल लेंथ इज व्हाट 1 मीटर. सेकंड स्टेप के लिए पूछ रहा है वो. ही इज आस्किंग यू फॉर दिस स्टेप ओनली. सो फाइनल माइनस इनिशियल, दैट इज 2 divided by what is the original length for this. This is this 2. So this becomes 1 by minus 1 by 2 point. Sorry, minus 0.5. Okay, that's pretty simple. Okay, so चलो ये तो स्ट्रेट फॉरवर्ड है, नथिंग इन दिस. फॉर एग्जांपल इसने इस स्टेप के लिए ट्रू स्ट्रेन पूछ ली, इसके लिए कन्वेंशनल भी पूछ सकता था, दैट इज अप टू दिस. बट हाँ, आपकी यू नीड टू हैव द योर अंडरस्टैंडिंग, क्लियर अंडरस्टैंडिंग होनी चाहिए. नाउ माय क्वेश्चन इज, you can obtain the, he can ask you, okay, done. So this is a straightforward, right? So I'm not elaborating more on it. It is simple. Let's say had he asked you true strain, let us say इस process में, had he asked you the true strain for the whole process, पहले elongate किया फिर compress कर दिया, तो इस step में के लिए true, तो either देखो true strain में, in true strain how you would have calculated natural log of what, final by initial, यही है. So for the entire process what is the true strain, you will say या तो final ले लो, final ये है, initial ये है. So 1 by 1, natural log of 1, right? So ये मेरी वैल्यू आई थी. सेम वे अगर आप लेट अस से क्या कैलकुलेट करते हो फॉर द, हाँ स्टेप वाइज, दैट वाज माय क्वेश्चन, कि अगर आप इसको स्टेप वाइज कैलकुलेट करते हो तो क्या सिचुएशन बनती है, दैट यू नीड टू सी. लेट अस से मैं क्या करता हूं, आप बोलते हो कि क्या मैं यही वैल्यू ऑब्टेन करूंगा इफ आई विल कैलकुलेट स्टेप वाइज, बिकॉज वी नो एप्सिलॉन 1 total true strain, I can also say this way, epsilon 1 plus epsilon 2. So this one, let's say epsilon 1, epsilon 2. How I can write the epsilon 1? आप बोलोगे natural log of, इस step के लिए final is this, initial is this, 2 by 1 plus next step के लिए final by initial. Natural log of final क्या है इसके लिए, because this इसके लिए initial ये हो गया, that is 1 सॉरी फाइनल दिस 1 डिवाइडेड बाय 2, 1 डिवाइडेड बाय 2. बात तो एक ही है वैसे देखोगे आप, 2 will cancel out, you are left out with natural log of 1 only. सेम ही बात है, एक ही बात है. बट आई वांट टू टेल समथिंग डिफरेंट फॉर यू इन द सेंस दैट नेचुरल लॉग ऑफ 2 तो आपका यही आएगा, व्हाट इज दैट, 0.693, राइट. नाउ ये जो वैल्यू है नेचुरल लॉग ऑफ हाफ 0.5, दिस विल टर्न आउट टू बी माइनस, वैल्यू उतनी आएगी बट कितनी आएगी, माइनस 0.693. ओके, नाउ क्या मतलब हुआ इसका, व्हाट आई वांट टू टेल यू, आई वांट टू टेल यू इज दैट साइन लेने की जरूरत नहीं है इन केस ऑफ किसमें, ट्रू स्ट्रेन में. व्हाट समटाइम्स देखो अल्टीमेटली क्या है, वैसे देखो ना आप, यहां से यहां तक कितना कोई स्ट्रेन हुई नहीं, सो दिस इफ यू आर गेटिंग इट डायरेक्टली जीरो, नो इशू. बट लेट अस से मैं क्या कर रहा हूं, ट्रू स्ट्रेन लिख रहा हूं ऐसे, सिंस दिस इज नेचुरल लॉग, ऑटोमेटिकली डिपेंडिंग अपॉन, ऐसा नहीं करना है आपने, बिकॉज आप क्या करोगे, समटाइम्स यू कैन कमिट द मिस्टेक दिस वे. व्हाट यू विल डू, यहां से यहां आए, आपको लगा कि इलोंगेट हुआ, तो आपको तो पता लग रहा है कि ये पॉजिटिव ही आएगी, बट यहां से क्या हो रहा है, इट इज गेटिंग कंप्रेस्ड, तो आप क्या कर सकते हो यहां पर, you will try to write it this way, epsilon 1 minus epsilon 2, this will be net epsilon, because you will have the tendency over here to write negative. Kyun? Because you're visualizing this way, that okay, this dimension is getting decreased from in the second step, so if it is getting decreased I should take it as a negative. No, simply sum low, simply take the sum, because this value, if it is getting reduced, this dimension is getting reduced, is automatically is going to come as a negative. So you don't have to write this way in case of a natural strain, simply write it this way, summation लो और plus minus जो भी होगा automatically वही आएगा. So this is just to tell you that somehow, sometimes, let us say आप में से कोई जो है ऐसे कैलकुलेशन करने लग गया और and then immediately you will find it out that okay यहाँ पर माइनस लगा दिया तो टोटल वैल्यू क्या हो जाएगी, it will become plus and it will become positive, so that will be wrong. Okay, so that's one thing that, so you cannot write this way, you cannot write sorry, epsilon 1 minus epsilon 2, this is wrong, you can write not right. So आप एक रिमार्क लगा दो so that it remains in mind कि हाँ इस तरह की गड़बड़ी हो सकती है. 25 I think 25 it was 0.693. Done. Okay, so that is how, that was the point that I wanted to make over here. Go ahead. Okay, so in plastic region of stress strain curve for ductile metal, I think you can answer it because हमने already discuss किया हुआ है, we have already discussed it, so I don't think that तो obviously plastic region में stress does not remain proportional to strain. Elastic region में आपको पता ही है, even for this is a true stress strain curve, क्योंकि वो overlap करती है true stress and conventional in this region. So उसके बाद कहाँ रहती है, it does not remain, ना ही true आपका जो है क्या रहता है, proportional रहती है, because यहाँ भी curve है, यहाँ भी ये curve की form में ही है, something this way, right? So stress does not remain proportional to strain. किसमें, plastic region में, it's not proportional, it follows some power law. So since we don't normally deal with this portion of convention stress strain, तो इसलिए हम इसको power law में define नहीं करते, but if you want you can definitely do that, but I think may not be required in the normal engineering application in plastic region when we talk about, and definitely इसके लिए तो हम power law Holomon equation की form में देते हैं जो हमने discuss किया. Distance the tool has plunged into the workpiece surface is called, which one is this, 28th. Okay, just try to interpret it. What is the answer? Can you just answer it? So please try to answer it. distance the tool has plunged. Okay. Yes. Okay. Mur, Abhinav. Okay. You have good interpretation. Plunged मतलब how much? देखो depth of cut क्या है? जैसे मान लिया if I am having a bar over here, so you set the tool, right? This is a feed direction. If it is turning, let us say, तो आप कहीं set करते हो उसको. So this is what? This is the depth of cut. So plunging means getting inside something that way. It's you can also for simple orthogonal cutting also you can say. For example, simple case है आपका, तो उस case में भी if you see what is that? Let's say tool is this is the tool. So what is this? This is depth of cut. How much it has plunged inside that particular material. तो ये क्या है? Depth of cut है. Depth of cut इसको हम uncut chip thickness भी बोलते हो. In simple orthogonal cutting ध्यान रहे इसमें we will discuss some questions but you know it. This is depth of cut बोल दो. Sometimes we also call it as a uncut chip thickness in case of simple orthogonal cutting. But anyway, this is depth of cut. Over here, this is the depth of cut. So plunging means you are inserting or getting inside that particular workpiece. Something we call it as a plunging. So depth of cut we call it as a C. Okay. Before getting into the question number 29th, what I need to do is I will get into the question number first 35 and 36. Okay. 35, 36. Which one is this? No. 35, 36, 35. Yes, let me just discuss this question first with you. Then 36. Then I will go back to the 29. Okay. Just go through this question. Go through this question and try to answer. So we'll go sequentially and so things are clear to you. For a mild steel bar of 50 mm diameter is being turned using a tool with signature this as per ASA system, right? The feed rate depth of cut during this is given to you. Undeformed chip thickness, width of cut, chip width. Okay. Undeformed chip thickness T, then chip width B. What is that? Now, first question that arises over here, if you see this particular configuration, that means ASA configuration that he has given you, is it an orthogonal cutting operation? क्या ये orthogonal turning operation है? Is it an orthogonal turning operation? Obviously not. कहां से पता चलेगा? Tool signature से. So you know how is the sequence? First is the rake angle, then relief angles and the cutting edge angles. This is how so back rake, side rake, then end cutting edge, side cutting edge, then these are the relief angles, rake angles, and then end cutting edge angle and side cutting edge angle and then nose radius. ये आपका नोमेनक्लेचर है. एंड उसमें भी आपका जो है साइड कटिंग एज सी 30 डिग्री है. तो पहली बात है, फर्स्ट रिक्वायरमेंट तो है कम से कम आपको जो है उसको साइड कटिंग एज एंगल को 0 करना पड़ेगा. यू हैव टू मेक इट 0 या लैम्डा को मुझे क्या करना पड़ेगा? 90 करना पड़ेगा. ओके, लेट मी नाउ सी, ये आपका कटिंग ऑपरेशन है. ओके, आई एम रिमूविंग इट भाई. यहां पर मैं फोकस कर रहा हूं साइड कटिंग एज एंगल. बात कर लेते हैं यहां पर. सो लेट्स से दिस इज योर समथिंग दिस वे, राइट? इस तरह से टर्निंग चल रही है. नाउ इन दिस टूल यू नो दिस इज अ फीड डायरेक्शन. कटिंग perpendicular to this, you are having which angle, which is this angle? ये एंगल कौन सा है? साइड कटिंग एज एंगल. एंड विच एंगल इज दिस? सेम कटिंग एज. ये आपको पता है दिस इज द मेन कटिंग एज. एंड इफ आई आस्क यू अबाउट दिस एंगल, दिस इज लैम्डा. लैम्डा क्या है साइड कटिंग एज एंगल ही, प्रिंसिपल कटिंग एज एंगल बोल रहे हैं, बट ये ओआरएस में, ऑर्थोगोनल रेट सिस्टम में मेजरमेंट हम इसका सेम कटिंग एज एंगल का एंगल जो हम यहां से मेजर करते हैं, वेयर एज इन केस ऑफ द एएसए सिस्टम वी मेजर इट फ्रॉम हियर. तो अगर आप इसका रिलेशनशिप देखोगे, दैट इज गोइंग टू बी 90, दैट इज CS प्लस लैम्डा इज इक्वल टू गोइंग टू बी 90. ये रिलेशनशिप आपको पता होना चाहिए कि फॉर द सेम कटिंग एज, अगर मुझे साइड कटिंग एज एंगल दिया है जो कि एएसए में है, एंड अगर मुझे जो है वो इफ लैम्डा विच इज द प्रिंसिपल कटिंग एज एंगल, मतलब एज तो वही है, only difference being that is how you are measuring, you are taking the which system you are taking, this ORS, so these two angles are going to be this. एक तो ये पता होना चाहिए. And to make this particular turning operation as orthogonal, कम से कम at least requirement क्या है, आपको lambda 90 करना पड़ेगा. अब ये मेजरमेंट है आपका ऐसे, ठीक है. अब ये you are measuring it like, अगर मैं इसको ऐसे करता जा रहा हूं, लेट्स से मैं थोड़ा सा इसको ऐसे नीचे करता हूं, तो साइड कटिंग लैम्डा क्या हो रहा है आपका, लैम्डा इज इंक्रीजिंग, CS विल बी डिक्रीजिंग. सो यहां पर जैसे जैसे आप ऐसे करते जाओगे तो लैम्डा विल बी इंक्रीजिंग, यू आर मेजरिंग इट फ्रॉम हियर, सो एंड CS विल बी डिक्रीजिंग. तो यहां पर CS क्या हो गया, डिक्रीज हो गया आपका. देखो ये ज्यादा है, कम है, CS बढ़ गया, सो CS इज डिक्रीजिंग. सो फॉर अस व्हेन आई विल मेक दिस एज एज वर्टिकल, मतलब वर्टिकल तो नहीं, इफ आई से दिस वे, दिस इंक्लिनेशन आई विल ब्रिंग इट ओवर हियर, ये मेरा टूल आ गया. So lambda will become 90. So in this case, when I will bring this way, lambda will become 90. Then I can say we are approaching towards the orthogonal cutting. So इस केस में तो वो केस है नहीं. तो first what we need to do is we need to know the relationship जो आप इसके लिए obtain करते हो. This is the oblique cutting operation, right? So इसको भी रहने देते हैं ऐसे ही. So this turning operation is, इसको बोलते हैं हम oblique turning. Now you must have these two relationship. आपको पता होंगे कि फीड पर रेवोल्यूशन जो हम देंगे इस केस में, इस ऑपरेशन के लिए, ऑब्लिक टर्निंग के लिए, दैट इज गिवन बाय T बाय साइन लैम्डा, एंड जो विड्थ है, विड्थ ऑफ द चिप इज गिवन बाय डेप्थ ऑफ कट एंड साइन लैम्डा. सो आई होप दिस मच डेफिनेटली यू मे बी नोइंग. अगर नहीं है पता तो ये तो याद रख लो, किसी भी हालत में जरूरत पड़ेगी आपको. कहा व्हेन इट इज नॉट ऑर्थोगोनल टर्निंग ऑपरेशन, ऑर्थोगोनल नहीं है ये, अभी ऑब्लिक टर्निंग ऑपरेशन है. ऑब्लिक टर्निंग ऑपरेशन का मतलब है कि डेफिनेटली यू आर गोइंग टू हैव सम वैल्यू ऑफ लैम्डा, सॉरी इन दिस सिस्टम यू आर गोइंग टू हैव CS, दैट इज साइड कटिंग एज एंगल की होगी. अगर ये ORS में होता तो डेफिनेटली लैम्डा भी कुछ वैल्यू होगी. इसी में भी अगर देखोगे आप क्या होगा, अगर CS जो है वो 30 है तो लैम्डा कितना होगा, 90 minus 30, that is 60. So until and unless this lambda becomes 90 or CS becomes 0, it cannot be orthogonal. तो इसका मतलब है जब आपका oblique turning केस है तो ये रिलेशनशिप एग्जिस्ट करेगा. If that be the case, then इसका यूज करके हम क्या कर सकते हैं, we can find out the value of what. क्या पूछ रहा है वो, T क्या है, अनकट चिप थिकनेस, राइट, एंड B क्या है, विड्थ ऑफ द चिप. किसके ऊपर डिपेंड करेगी, एक तो एंगल के ऊपर डिपेंड करेगी, दूसरा जो है डेप्थ ऑफ कट के ऊपर डिपेंड करेगी, ये विड्थ निकालने के लिए, और ये डिपेंड करेगी फीड के ऊपर. नाउ दीज वैल्यूज हैव बीन गिवन टू यू. फीड पर रेवोल्यूशन, कीप इट इन माइंड, दिस इज फीड पर रेवोल्यूशन. सो फीड पर रेवोल्यूशन, यू नो लैम्डा, you know, because you know this relation, and over there CS I know. This value is over here CS, you are already having, this is CS 30 degree. So just simply input this value over here and you are going to get T. मुझे T चाहिए, uncut chip thickness will be equal to what? Feed. How much is feed per revolution is 0.175. 0.175 sin lambda. Sin lambda, you know, 90 minus 30, that is 60. What is this value? T की वैल्यू जो आपकी आएगी uncut chip thickness की 0.151. And over here, if I want to find out the width of the chip, चिप जो विड्थ है वो कितनी होगी, so that will depend upon these two factors. So उसने डेप्थ ऑफ कट देके रखी होगी आपको. What he has given you, the feed rate is this much, depth of cut is how much, 0.25, mm। तो डेप्थ ऑफ कट कितनी देकर रखी है, ये वाली, ये डेप्थ ऑफ कट है, इस केस में क्लियर है डेप्थ ऑफ कट ये। So this is depth of cut. So how much he has given you? Depth of cut he has given you 0.25. So depth of cut is given to you is 0.25. So I can write it, width of the chip will be equal to, depth of cut is 0.25 mm divided by sin lambda 90 minus 30. मैं इसको आई एम नॉट एक्सप्लेनिंग दिस कि कैसे ऑब्टेन किया, वैसे ज्योमेट्री से आप ऑब्टेन कर सकते हो यहां से, बट इट विल टेक ए लॉट ऑफ टाइम, इसलिए मैं इसको एक्सप्लेन नहीं कर रहा हूं, मैं डायरेक्टली वैल्यू दे रहा हूं आपको। सो ओवर देयर बी की वैल्यू कितनी आ जाएगी आपकी 0.288 mm। क्लियर, दैट्स ऑल। तो ये फर्स्ट, इसको एक एक करके जो है नेक्स्ट क्वेश्चन लूंगा, उसमें मैं जो ऑर्थोगोनल की तरफ जाऊंगा, फिर न्यूमेरिकल के ऊपर जाएंगे, तो कि आपको क्लैरिटी रहे कि हाउ द थिंग्स आर गोइंग ऑन। सो व्हेन यू आर हैविंग ए ऑर्थोगोनल टर्निंग ऑपरेशन, तो ऑर्थोगोनल टर्निंग के लिए पहली रिक्वायरमेंट तो आप यही देख लोगे, सॉरी नॉट ऑर्थोगोनल, ऑब्लिक टर्निंग ऑपरेशन, वेयर यू विल कम टू नो, क्योंकि जो टूल सिग्नेचर है, टूल नॉमेनक्लेचर है, फ्रॉम देयर जस्ट लुक एट द वैल्यू ऑफ दिस पर्टिकुलर लैम्डा और सीएस। अगर ये एएस से है तो ऑब्वियसली दिस इज सीएस, और इफ इट इज ओआरएस तो ये यहां पर जो पोजीशन पे जो एंगल होगा वो कौन सा होगा, लैम्डा होगा। ओआरएस के ऊपर भी हम देखेंगे, राइट। एंड दिस रिलेशनशिप यू शुड नो, एंड इफ दिस सिचुएशन एग्जिस्ट, तो उस केस में मेरा जो है ये रिलेशनशिप एग्जिस्ट करेगा। अगर कोई भी वन पैरामीटर इज गिवन टू आउट ऑफ दिस, देन आई कैन फाइंड आउट दीस वैल्यूज। एम क्लियर? नाउ इन नेक्स्ट क्वेश्चन वी विल मूव टुवर्ड्स द ऑर्थोगोनल। अगर इसी ऑपरेशन को ऑर्थोगोनल बना दिया जाए तो हाउ द थिंग्स विल चेंज इन दिस केस, तो उसको मैं यही एक्सप्लेन कर देता हूं पहले, जस्ट की रिलेशनशिप क्या आएगा, सो दैट again I need not to draw the same diagram over there in next question. तो हटा रहा हूं, this question is complete. Now in next question that I am saying is, maybe I am talking about the orthogonal. So orthogonal के लिए पहली रिक्वायरमेंट क्या है आपकी, एटलीस्ट जो आपका ये जो एज है कटिंग, मेन कटिंग एज या प्रिंसिपल कटिंग एज, ये एंगल जो है 90 लैम्डा वैल्यू इन ओआरएस शुड बिकम इक्वल टू 90, एंड सीएस जो है वो 0 हो जाएगा, क्योंकि अगर आप देखोगे सीएस अभी ये है, अगर मैं इसको ऐसे कम करता हूं कम हो रहा है, राइट। सो दैट मींस फॉर दैट इफ आई विल मेक दिस एटलीस्ट, और भी रिक्वायरमेंट्स हैं, बट एटलीस्ट चलो इस केस में हम ये मान लें, लेट्स से इफ दिस एज बिकम्स 90 डिग्री, तो रिमूव कर रहा हूं अब। नाउ सेम थिंग, नाउ व्हाट आई डिड इज आई मेड लैम्डा एज 90, ये देखो लैम्डा 90 डिग्री हो गया, सो दिस बिकम्स द ऑर्थोगोनल टर्निंग ऑपरेशन। नाउ तो टर्निंग कैसे चलेगी, अब इसको मॉडिफाई कर रहा हूं, व्हेन आई एम डूइंग दिस, तो अब ऑब्लिक से हम कहां जा रहे हैं, टुवर्ड्स द, ये सॉरी बनाने पड़ गया, ओके एनीवे, ये समथिंग दिस वे, फीड ऐसे चल रही है, नाउ दिस वे, सो तो प्रिंसिपल कटिंग एज एंगल ये 90 हो गया आपका, सो दैट मींस इन दिस केस लैम्डा इज इक्वल टू 90। So when this is the case, then it becomes orthogonal turning. तो सेम टर्निंग ऑपरेशन को मैं ऑर्थोगोनल टर्निंग ऑपरेशन बना सकता हूं इफ आई मेक लैम्डा इक्वल टू 90 और सीएस इक्वल टू 0। बात एक ही है, अगर लैम्डा 90 है तो इट बिकम 0 और सीएस इक्वल टू साइड कटिंग एज एंगल है 0, तो ये एसए में, एएसए में होगा, ये ओआरएस में है। नाउ इफ दैट बी द केस, तो ये रिलेशनशिप कैसे मॉडिफाई हो जाएगा, इफ दैट बी द केस देन हाउ दिस रिलेशनशिप विल मॉडिफाई, इनपुट द वैल्यू। अगर ये, if you know this much, then your job becomes easy. If you know this formula, put lambda equal to 90, so 91. So it means for orthogonal turning, क्या जाएगा, sin lambda feed will become equal to t by sin 90. 1 feed per revolution will be equal to the uncut chip thickness, and put value lambda as 90, so it becomes and b is equal to d divided by sin lambda 90. That means b will equal to depth of cut. So when there is a case of orthogonal turning, in that case जो width of the chip है, देखो depth of cut कितनी है, ये है, और अगर मैं आपसे पूछूं फीड यहां से जा रही है आपकी, ये रोटेट कर रहा है, देन दिस इज द डेप्थ ऑफ कट, देन द विड्थ ऑफ चिप जो आएगी इस केस में, दैट विल बी इक्वल टू कितनी आएगी, देखो चिप कैसे आएगी, चिप यहां से आएगी ऐसे ऐसे घूम के, इस तरीके से घूम के। सो इसका मतलब ये है कि जो विड्थ ऑफ चिप जो बन के आएगी व्हेन आई मेक दिस दिस एज दिस, सो ये क्या आएगी, डेप्थ ऑफ कट, जितनी डेप्थ ऑफ कट है उतनी ही विड्थ की चिप जो है आपकी ऐसे निकलेगी कट करके। तो आपने यहां से भी देख लिया। एंड जो फीड पर रेवोल्यूशन आप दे रहे हो, हर एक रेवोल्यूशन में कितनी फीड दे रहे हो, एमएम पर रेवोल्यूशन में दे रहे हो, सो जो अनकट चिप थिकनेस है वो जो है दैट इज गोइंग टू बी इक्वल टू फीड। वेयरएज इन ऑब्लिक कटिंग इट वाज नॉट द केस। वो आप वैसे भी देख सकते हो, ऑब्लिक कटिंग में क्या होता कि अगर आपका ये एज है, देखो ये, सो जो चिप की विड्थ होती, डेप्थ ऑफ कट तो ये होती, जो चिप की विड्थ होती वो क्या होती, समथिंग दिस वे, तो दिस वैल्यू एंड दिस वैल्यू वुड नॉट हैव बीन सेम, तो वो दैट विल गवर्न्ड बाय दिस रिलेशनशिप। बट जब इसी एज को मैं ऐसे ले जाता हूं तो द डेप्थ ऑफ कट बिकम्स इक्वल टू विड्थ ऑफ द चिप व्हिच इज कमिंग आउट। रिलेशनशिप आपको क्लियर पता होना चाहिए। इफ दैट बी द केस, तो आ जाते हैं अब इसी क्वेश्चन के ऊपर जिसके बारे में मैं एक्सप्लेन कर रहा था। राइट नाउ सी दिस वन, दिस nomenclature has been given to you in ORS system, right? ORS system में if I can perfectly I can recall, तो होपफुली मैं रिकॉल कर पाऊंगा। इसको हम डिनोट करते हैं, ये है रेक सरफेसिस के लिए एंगल, ये भी रिलीफ एंगल्स हैं और ये कटिंग एजेस के लिए हैं। इसको हम आई से डिनोट करते हैं, इसको ऑर्थोगोनल रेक बोलते हैं, इसको एंड रिलीफ, साइड रिलीफ ऐसे बोलते हैं। और एक एंड कटिंग एज एंगल, और ये जो साइड कटिंग एज एंगल है, दिस साइड कटिंग एज एंगल वी कॉल इट विद लैम्डा, है वो सेम ही सरफेस इसका, एंड दिस इज नोज रेडियस, दिस इन ओआरएस सिस्टम, राइट। सो अब मुझे बताओ कि कौन सा ऑपरेशन है, वैसे इसने बोल ही दिया खुद, कहीं नहीं बताया, राइट। देयर इज अ सिंगल पॉइंट टर्निंग टूल, ये मेंशन कर दिया इन ओआरएस सिस्टम। इन दिस केस द अनकट चिप थिकनेस वुड बी इक्वल टू, आई यहां पर जीरो है, बेसिकली आई का जीरो होना परफेक्ट, उसके लिए प्योर ऑर्थोगोनल टर्निंग के लिए, कटिंग के लिए और टर्निंग के लिए आई नीड टू बी जीरो, एट द सेम टाइम लैम्डा नीड्स टू बी 90, ये फुलफिल होंगी तब जाके होता है। बट उसने बहुत क्लियरली दिया हुआ है, आई को भी जीरो कर दिया हुआ है एंड लैम्डा भी 90 कर दिया है। So first thing that you will see over here, that is lambda is 90. Lambda 90 है तो इसका मतलब ऑर्थोगोनल टर्निंग होगी। ऑर्थोगोनल टर्निंग होगी तो पूछ क्या रहा है ये, इन दिस केस द अनकट चिप थिकनेस वुड बी इक्वल टू, अनकट चिप थिकनेस T विल बी इक्वल टू व्हाट, हमने देख लिया लास्ट में, T इज इक्वल टू F डिवाइडेड बाई साइन लैम्डा, B इज इक्वल टू D बाई साइन लैम्डा, ये रिलेशन है। तो अनकट चिप थिकनेस दिस वुड बिकम इक्वल टू फीड, ये आपका आंसर आ जाएगा। तो फीड अप्लाइड, फीड क्या है, फीड पर रेवोल्यूशन, मोर अप्रोप्रिएटली फीड पर रेवोल्यूशन, अप्लाइड बात ये है, इसका मतलब है ही इज रिप्रेजेंटिंग इट विद द फीड पर रेवोल्यूशन, एमएम पर रेवोल्यूशन। So this is going to be the answer. He may frame the question on the similar lines, how the width of the chip is going to be equal to. So you will say the width of the chip is going to be equal to the depth of cut, which I have already explained you. So see the nomenclature part, get the clarity on this. Most probably he is going to give you the clarity over here also, but most importantly over here. And then this becomes the orthogonal turning operation. And ये रिलेशंस वैलिड हो जाएंगे। ओके, अब आते हैं वापिस, कहां पर थे हम, वेयर वर वी, 29th और समथिंग देयर वी वर ओवर देयर, 29th पे चलते हैं। See this question. If that much understanding you have developed, which I discussed, one is the oblique cutting relationship, and then after that I converted it into the orthogonal turning operation. Now go through this particular question and try to solve it and read this statement clearly. इसकी statement को थोड़ा clearly देख लो। So even though you gave me the answer, but इस क्वेश्चन को थोड़ा सा रीड कर देता हूं कि क्या है. I don't know whether you understood this question or not, but हाँ, क्योंकि आपने आंसर निकाल दिया, you know the formula, so you got it, right? But जो क्वेश्चन whatever he has mentioned in the question, थोड़ा सा उसको उसने confusing कर दिया है. Okay, in terms of formula, I think आपने उसको अप्रोच किया, वैल्यू डाली और आपको पता चल गया डेप्थ ऑफ कट. पर पूछना क्या चाह रहा था, I don't know whether you have judged that correctly or not. So let me just draw it this way. ये आप कलर से ऑब्लिक कटिंग था टूल पहले ये सिचुएशन थी. दैट इज व्हाट ही इज सेइंग, राइट? ये तो दिस अ केस ऑफ व्हाट, ऑब्लिक टर्निंग. और ऑब्लिक ही दिया हुआ वैसे उसने, क्योंकि आपको टूल विद एन ऑर्थोगोनल टर्निंग प्रोसेस विद ए टूल विद 60 डिग्री साइड कटिंग एज एंगल. देखो साइड कटिंग एज एंगल 60 डिग्री अगर दिया तो वो ऑर्थोगोनल हो नहीं सकती. इट कैन नॉट बी ऑर्थोगोनल. पहली बात तो ये है, राइट? If it is side cutting edge angle, he is giving you 60 degrees. Obviously, it is not orthogonal cutting. But anyway, initially he has given you. This question should be read this way. That initially he, ये तो reframe, इसमें frame करने में कुछ गड़बड़ है, इसमें properly frame नहीं कर पाया. But what is the end result? That is what he want to ask. I will explain you. कि let's say side cutting edge angle इतना है, oblique turning का tool है, ये situation है. Let's say side cutting edge angle कितना है? This is 60 degree. So he has given you side cutting edge angle which is 60 degree. And 2 mm width of cut. Width of cut, it means this one. Width of cut कितनी होगी? ये width होगी इस केस में. यहां से ले ये, लेके ये. So width of cut is 2 mm. The depth of cut is given in mm. Let us say अगर ये सिचुएशन होती तो depth of cut तो आप निकाल ही सकते हो, because you know the relationship. So ये depth of cut है, right? So depth of cut आपने निकाल ली डायरेक्टली. कैसे? आपने कहा कि देखो I am having the relationship. अगर tool if it is oblique turning case, lambda इतना है. So B you know 2 mm equal to depth of cut I want to find out. And sin lambda कितना हो जाएगा? 90 minus 60 that is 30. So ये मेरी depth D कितना आ गया? 1 mm आ गया. ये आपने obtain कर लिया. इसका मतलब है कि when I am keeping the tool as a ऑब्लिक टर्निंग टूल है, तो उस केस में भी डेप्थ ऑफ कट मेरी ये है. लेट अस से इफ आई मेक इट कीपिंग ऑल द थिंग्स सेम. नाउ इफ आई मेक इट व्हाट, इफ आई मेक इट ऑर्थोगोनल, इसी टूल को अब मैं ऑर्थोगोनल बना देता हूं. ऑर्थोगोनल कैसे बनाऊंगा? इस एज को यहां ले आऊं, ऑर्थोगोनल बन गया. सो इफ व्हेन आई विल मेक दिस एज और दिस टूल एज ए ऑर्थोगोनल, और इसको कन्वर्ट कर देता हूं इसी ऑपरेशन को ऑर्थोगोनल में, तो क्या डेप्थ ऑफ कट में फर्क पड़ेगा? इफ आई विल कन्वर्ट इनटू ऑर्थोगोनल, इज इट गोइंग टू इन्फ्लुएंस द डेप्थ ऑफ कट? नो, डेप्थ ऑफ कट तो वही आएगी. कितनी? सेम. फर्क इसमें आएगा. वेयर यू आर गोइंग टू गेट द डिफरेंस? यू आर गोइंग टू गेट द डिफरेंस इन द विड्थ ऑफ द चिप. अर्लियर विड्थ ऑफ चिप इज दिस वन, यहां से लेके यहां तक. अब विड्थ ऑफ चिप कितनी आएगी? इक्वल टू द डेप्थ ऑफ कट. When I will make this one, so width of the chip will be this much. Earlier it was this much. But in terms of depth of cut, वो तो change नहीं होगी ना. Depth of cut तो same रहेगी, keeping all other parameters same. So basically, his question over here was not to ask you to calculate the depth of cut in the oblique turning case. He was saying that okay, oblique turning का tool है, और let us say उसको मैं if I convert it into the orthogonal, then what is going to the depth of cut? So in that case, first you would have calculated the depth of cut for oblique turning, and then if I make it orthogonal, then obviously depth of cut is not going to change. It is going to remain same. I hope you got it. But anyway, क्योंकि आपने शायद उसको इंटरप्रेट नहीं किया होगा, the way he has framed बहुत clearly, क्योंकि see the way he has framed for an orthogonal turning process with a tool of 60 degree side, वो तो हो ही नहीं सकता. वैसे if you see 60 degree side cutting edge angle है तो वो तो orthogonal turning हो ही नहीं सकता. So it means what he wanted to ask was what I explained to you, right? I hope you got my question. So sometimes just pay attention to little things. कई बार हम मिस कर जाते हैं. But anyway, maybe इसमें मैं थोड़ा सा benefit of doubt दे सकता हूं आपको, because the way he may have framed it. Okay. Okay. So let's now go to the next. So okay. See this question. Just see and try to give me the answer. Okay, go ahead. The strength of the tool cutting edge. The strength of the tool cutting edge in orthogonal cutting in comparison to that of oblique cutting. हाँ बताओ. Right, this is an oblique turning case. This is depth of what, right? Now बोलता किस केस में strength of the tool cutting edge in orthogonal. Now see, when you are turning this with this tool which is orthogonal, let us say this one, I am making this one. Now compared to this oblique cutting, the tool action was over this length, right? Tool action was over this length of this particular edge. Now when I am making the same tool as orthogonal, the edge which is coming in contact is only this much, right? तो बोलता है स्ट्रेंथ किस केस में ज्यादा होगी, लेस होगी या ज्यादा होगी. सी, in oblique turning case your cutting action is distributed on the larger length पे distributed है. At the same time the heat which is getting generated is will get easily dissipated because आपको more area मिलेगा उसको dissipate करने के लिए. In comparison to this portion, इस केस में आपका जो लेंथ ऑफ द वर्क टूल, सॉरी कटिंग एज ऑफ द टूल is concentrated on the small portion. At the same time, in this portion, the length which you have in order to dissipate the heat is also less. तो heat buildup इसमें compared to this will be more, क्योंकि आपको कम एरिया है, यहां पर कम लेंथ है. अगर आपने इस तरीके से देखना, if you want to see this way, less length is to dissipate the heat. So more buildup of heat. This more buildup of heat means it will lose strength easily compared to the what? Oblique cutting edge. So when you are having orthogonal turning operation compared to the this oblique turning operation, you are going to have the less strength in this case compared to this one, because cutting action is concentrated on a narrow zone or narrow length of that particular cutting tool edge. ठीक है, इस तरीके से आपने इसको इंटरप्रेट करना. तो आंसर इज गोइंग टू बी ए. लेट्स सी दिस क्वेश्चन नाउ. what is he asking? The rake angle of the tool is given to you, and if the shear angle is this, cutting speed is this. If shear angle is this, cutting speed is this. I think something is missing over here. Basically, rake angle of the tool. In this case, missing, I think line has been missed. Typing इसमें mistake हो गई मुझे लग रहा. Basically, he is asking you to calculate cutting speed is this, and then after that it is the chip velocity. Basically, chip velocity in meter per minute. ये क्वेश्चन था एक्चुअली. this what I have solved. I think the original question tha. He's asking you to calculate the chip velocity. Okay, because statement is missing over here. Yes, question is incomplete. I think typing mein we have missed that. But originally when I was solving it, it was chip velocity. Okay, so okay, now rake angle diya hai aapko, shear angle is given to you, cutting speed is also given to you, and he's asking to calculate the chip velocity. So I hope you are having, either you remember the formula for chip velocity directly. Even if not, then I think you can get it done from that velocity triangle also, right? For example, if I say this is the tool and workpiece, then if I ask you velocity in this direction, this is phi, this is rake angle of the tool. So how do you write? You say in this direction you are having the shear velocity, in this direction you are having cutting velocity, cutting velocity if I denote, and along this direction chip flows, so chip velocity, right? ये velocity triangle आपको हमेशा पता होना चाहिए, and immediately you must be able to draw the way I draw it. अगर भूल जाओ रिलेशन तो इमीडिएटली ड्रॉ करो. रेस्ट एंगल आप पता कर सकते हो बिकॉज ये एंगल फाई है इस डायरेक्शन में. दिस एंगल इज फाई. व्हाट इज दिस एंगल? वर्टिकल से दिस इंक्लिनेशन, फ्रॉम वर्टिकल दिस इंक्लिनेशन, chip direction, this is alpha, rake angle. So if this is 90 minus alpha, and then this is 180 minus 90 minus, so it becomes 90 plus alpha minus phi. That's all. Rest you can use the sine rule. V divided by opposite angle, Vs divided by opposite angle, sine of opposite angle, Vc divided by sine of opposite angle. So you must be, जब भी आप कोई फॉर्मूला भूल जाओ, just see the basic part also. If you know this, then I think you will be able to do it immediately. So Vc जो आएगा आपका रिलेशनशिप आएगा, Vc is equal to V into sine phi divided by cos phi minus alpha. ये रिलेशन है, that you can do it simply. Phi I am having, right? रेक एंगल 0 है, फाई जो है वो 30 है, राइट? सो V इज हाउ मच? इज 50 into साइन ऑफ फाई. फाई इज हाउ मच? 30 डिवाइडेड बाई अल्फा 0 है आपका, तो कॉस ऑफ 30. सो यू आर लेफ्ट आउट विद 28.867 मीटर पर मिनट. ओके, सो दिस इज what? So simply you need to know the relationship between these velocities, and by knowing that you can find out the velocity of, even he may ask you to calculate the shear velocity also, velocity along the shear plane, that also you can calculate by making use of those formulas. So I hope yes, okay, all of you are getting the only simply the calculation part, and just to remind you that okay, this must be you must have in mind this configuration, so that immediately you must be able to draw it. Okay, so let's go ahead with the next question. So we have done 35 and 36 we have done. So let's go to the 33 and 34. So before the break, okay, still we are having I think 31, 32. Okay, let's do. So we will take a break. Let's first see how many questions we can do. So let's go to the next question now. So see the question. It is not ceiling, it is a cutting edge. Okay, cutting edge angle. It's not ceiling. Okay, it's cutting edge angle, side cutting edge angle, side cutting edge angle, 10 degree, orthogonal rake angle. Okay, see in this case, even though he has framed the question, okay, but in past he has not framed the question from this. Normally if you will see in GATE, normally direct formula in the sense की क्रैम किया फॉर्मूला उसको यूज करके आपने निकालना पूछता नहीं है, बट यू नो व्हेन वी से दैट ओके ही हैज टू गो फॉर दोस ग्रे एरियाज, तो वो कुछ ऐसे क्वेश्चन पिक कर लेता है रैंडमली जहां से क्वेश्चन फ्रेम कर देता है. So you must be having some relationships which you may have known to correlate the angles in orthogonal rake system and ASA system. So basically वो formulas जो भी है 3-4 formulas, just remember them. If let us say he frames the question, गलती से अगर frame कर दिया तो you must be able to handle, because उस केस में वो directly formula based question हो जाएगा. So that is a similar, on similar line this question is over there. What is asking you to find out the orthogonal rake angle. You already know जो मैं बात कर रहा था I alpha, this is end relief, side relief, and end cutting edge angle, and lambda and r, right? This was the ORS nomenclature. So ये क्या है, inclination angle है, this is the orthogonal rake angle. So how to find out the orthogonal rake angle? The formula that you already you are already having. When ASA angles are given, when the angles in ASA system are given, right? From there, how to find out? So that formula you need to make use of directly. So the formula is tangent alpha. That means over here orthogonal rake angle. ये alpha find out करना है. And on the other side, you are having tangent alpha s into sine lambda plus tangent alpha b into cos lambda. So when, if you see on this side, all the angles that you are having, we can either find out from the ASA system or they are directly given. For example, over here lambda I can write it as a 90 minus CS. So if I write it this way, sine 90 minus CS, sine 90 minus CS. So anyway, well, let me just write it same way. But lambda, as you know, I can find it as 90 minus CS. So that means on this side, all the angles that I'm having are of ASA system, and orthogonal rake angle of ORS system I need to find out. Right now, see this value, side rake angle CS given to me, back rake angle I need back rake angle, side rake angle. So this is side rake angle is 10 degree, back rake angle is how much, 5 degree, and side cutting edge angle CS is equal to 10 degree. So from there I can find out the lambda also, and end cutting edge angle is given, end cutting edge angle is given, so that is not required in this. So just simply input the value tangent alpha is equal to tangent 10 into sine of lambda that is 80 plus tangent of alpha b 5 degree into cos of again 80 degree. As simple as that. So tangent lambda आपकी value आ जाएगी, I think it will come out to be 0.1888 and alpha is going to be 10.69 degree. और ये रेडियन में पूछ रहा है आपका, तो 0.185 रेडियन आ जाएगा. So nothing special in it, but हाँ जैसे मैंने कहा, this is a gray area. यहाँ से क्वेश्चन उसने डायरेक्टली पूछा नहीं है, बट जो 2-3 फॉर्मूले हैं, just remember all those formulas which are related to the conversion of from ASA system to ORSA system. Just remember those formulas so that अगर वो पूछ लिया क्वेश्चन तो आपका ये easy question रहेगा. Okay, not for 2 marks, but definitely for 1 mark you can frame this question, right? So just go through this also. Done. Okay. Let's go to the next question. Okay, go through this question. So it is make the correction, 2 corrections. Rake angle 5 degree, ठीक है. Width of cut 50 mm. Sorry, it's not 50, it is 5 mm. 5 mm. So let me just make the corrections over here. First is this one. This is 5 mm. 5 degree, okay. This is 0.38. That is also okay. 0.65189. 1589. ठीक है. Rest is okay. तो ये आपने information you are having. Yes, yes, yes. This Avinav, yes, this option जो है ना, just cross check it. I think he has not given the option correctly. Right, right. So ये जो last question था, that was 30 question number 32. उसमें आपकी option match नहीं हो रही है. The options that he has given you, we are getting the answer 0.1863. I think you just cross check also, just calculate it. This value is going to become this one only. So I think he may have done some mistake in framing the options. But if our this calculation is correct, then we will move ahead with our answer only. ठीक है, just cross check it. एक बार अपनी end पे cross check कर लेना. I have cross checked it twice, I think. So I don't think कि option में नहीं है, but don't bother about that. So just go ahead with this answer. Okay. So now we are having this cutting force and thrust force on cutting, orthogonal cutting. Now, first of all, you know, he has given you this thrust in orthogonal cutting operation. देखो पहले cutting operation है ये, and this is a simple cutting operation, which simple orthogonal. There are two things. One is a simple orthogonal cutting operation. Second one is the orthogonal turning operation. We'll see the difference when I will solve the question of orthogonal turning at a later stage. But as of now, this is a simple orthogonal cutting operation which you already know. जैसे ये वाला simple orthogonal cutting operation है, turning नहीं है ये cutting हो रही है simply, right? Something this way, right? So ये simple orthogonal cutting का operation जिसके लिए we are having all the relationships, right? जो भी relationship आपने discuss किए हैं that you study at your level, they are all for the orthogonal machining only. ये ध्यान रखना आपने. Oblique machining के लिए आप discuss नहीं करते हो. Now अगर ये ऑपरेशन है तो saying that cutting force आपको दिया उसने and thrust force which we can measure, इसलिए वैल्यूज दी गई हैं. रेक एंगल आपको दिया गया 5 डिग्री, which you know already, this is a rake angle alpha, 5 डिग्री दिया हुआ है. width of cut is 5 mm. ठीक है, so width of cut means perpendicular to you. width जो चिप की है या जो भी है, width of cut वो 5 mm है. तो B you already know. Uncut chip thickness is this, uncut T, chip thickness is ratio is this. तो T आपको दिया उसने कितना, how much? He has given you 0.6 mm and uncut chip and chip thickness जो उसने दी, sorry ratio दी है उसने, ratio uncut chip thickness ratio, sorry chip thickness ratio is 0.38 and uncut chip आपको जो उसने दी है 0.6. uncut chip कौन सी होती है इस केस में? Now let me just point out this point to you that okay, this in this case whether you call this as depth of cut or whether you call this uncut chip thickness is hardly going to make a difference, right? बात एक ही है. तो uncut chip thickness उसने आपको दिख रही है 0.6. shear strength of the worn material, that means when you are cutting the material, what is its shear strength? shear strength क्या होगी इसकी? shear strength, how you are going to calculate? shear strength is equal to, yes, shear force on the shear plane. तो shear plane ये है and the area of the shear plane. इस plane का area कितना है? ये, this is 5, right? So what is its area? What is the area of this shear plane? You will say area of the shear plane will be the length of this shear plane, this much, into the width, which is not, width may be this one, this way. So width is not clear over here, which is given, but yes, this is the length. So if I say this is the AB, then can I say that what is this AB length? You know this is the thickness of the chip. So can I say this is the triangle, which is this thickness? So can I say sine phi is equal to this divided by hypotenuse? So perpendicular is this. So this is how much? T divided by AB. So that means I can say the length of the shear plane is equal to T divided by sine phi. And what is the area of the shear plane? So this length and then width, multiply by this length with the width B. So can I say that this becomes shear force divided by shear area? तो shear area कितना आ जाएगा आपका? AB into B, small b. So B into T divided by sine phi. It means Fs into sine phi divided by Bt. B I know clearly because he has given you B दिया है उसने क्या? Width of the 5 mm दिया मुझे. B I know clearly. T I know clearly. So my job becomes pretty easy. B is equal to 5 mm. So only thing that I need to find out is the phi and shear force along the shear plane. क्लियर है? जस्ट फाइंड इट आउट. और फाई तो मैं निकाल ही सकता हूं. कहां से? आई हैव द रिलेशनशिप टेंजेंट फाई इज इक्वल टू इन टर्म्स ऑफ r cos alpha divided by 1 minus r sin alpha. Alpha, you know, already alpha has been given to you how much? 5 degree. So 5 degree you know, which is alpha. Alpha आपको वैल्यू दी हुई है उसने. Input that value r I know 0.38. From here I can get the value of tangent phi. Tangent phi की वैल्यू जो आपकी आएगी वो आएगी 0.3915. And from here I can get the value of phi which is equal to 21.38. ठीक है? Done. Now my job is to calculate the shear plane. Force acting along the shear plane. इस plane के along कितनी force लग रही है? That I need to find out. अब यहां पर you need to find out the yes you have अभिनव ठीक है आपका आंसर. So now rest is shear force कैसे निकालनी है. तो I hope जो मर्चेंट सर्कल से 4 रिलेशंस हैं फोर्सेस के वो आपने निकाल. You may be knowing those. कौन कौन से हैं? एक तो आपका जो है shear force, मैं लिख लेता हूं उनको फिर then I will remove all of them. जैसे shear force, because why we normally you know FC and FT we can measure, ये values we can measure, and other force is acting on that particular machining process we can calculate by these relations. तो ये तो मैंने मेजर कर सकता हूं, बाकी फोर्सेस मैं कैलकुलेट कर सकता हूं बाय दिस रिलेशनशिप. तो एफएस देखो कैसे करते हो आप. दैट इज द एफसी cos phi minus ft sin phi. सेम वे एफएन लिख रहा हूं पर इसको रिमूव कर दूंगा मैं. एफसी sin phi plus ft cos phi. सेम वे shear force fc sin alpha plus ft cos alpha. एंड n जो आता है आपका उधर इज fc cos alpha minus ft sin alpha. समझिए मतलब क्या मतलब हुआ इसका. आई विल नॉट मेक हॉचपॉच. यहां पर ड्रॉ कर रहा हूं. ये शेयर प्लेन है ए बी. इसके ऊपर एक शेयर फोर्स लग रही है ये एफ एस एंड एक लग रही है एफ एन. हाउ कैन वी कैलकुलेट फ्रॉम दीज टू फॉर्मूलाज एफ एस एंड एफ एन in terms of FC and FT which are given to me, which I can measure. Same way along this particular face, जो कि आपका फेस ये है, which this face, वहां भी आपकी फोर्स लग रही है. एक लग रही है shear force, एक लग रही है नॉर्मल. तो ये नॉर्मल है, this is shear force. How we can calculate? I can calculate from these formulas in terms of FC and FT. तो ये तो आपको याद रखना है. और if you are remembering these two, I think you can remember them also. For example, अगर देखो इसको, ये और ये फॉर्मूला, these formulas are no this and over there. Sorry, if you see this formula and this formula, they are more or less look similar. फर्क क्या आ रहा है? केवल अल्फा का आ रहा है. यहां अल्फा है वहां फाई है. सेम वे दिस फॉर्मूला एंड दिस फॉर्मूला लुक सिमिलर. यहां फाई है और यहां क्या है? अल्फा है. So easy to remember. So I hope you may have remembered. So anyway, any of these forces, this or these two forces, all these four forces can be calculated from if FC and FT is given to you. As simple as that. That be the case, then now my job is here to find out the fs. So I'm removing all other things, and now if that be the case, then just calculate the value of fs. So fs कितनी आई? fc देख लो, 1470 cos of phi 21.38 minus ft कितना है? 1589 sin 21.38. So from here fs मेरी वैल्यू आ गई 789.56 न्यूटन. ठीक है. ओके, रेस्ट इनपुट दिस वैल्यू. टॉ विल बिकम इक्वल टू हाउ मच? एफएस जो है वो 789.56 मल्टीप्लाइड बाई, हैव आई रिटन करेक्टली? यस राइट. साइन फाई कितना हो गया? साइन ऑफ 21.38 डिवाइडेड बाय व्हाट? बी. बी हैव बीन गिवन टू 5 mm एंड टी अनकट चिप थिकनेस इज 0.6. सो ये मेरी न्यूटन पर mm स्क्वायर में वैल्यू आ जाए. सॉरी न्यूटन, सॉरी, दिस शुड बी न्यूटन पर mm स्क्वायर, not Newton. This should be Newton per mm square. So this is 95.945 Newton per mm square. So these values I have already taken as Newton. ये mm और mm में है, so these values are going to be this much. Stick to the exact value that you're getting. I'm getting this value 95.945. I don't know 96 you are mentioning, whether you're getting it exact or not, but whatever the exact value that you will get, just mention that only in the GATE examination, right? Don't okay, done. Okay, that's all. I think you may have done many questions on similar lines also. Mostly on these lines, he frames the question in GATE also, right? Okay, let's go ahead now. Just see this question. None. Okay, what he is asking you to calculate the strain. $34.2. What is it? 1850. What is it? 34.2. What is that? 2185. Okay, 21. 2 point. Okay, I got your point. Okay, right. Okay. So on strain, right? So for example, this is the orthogonal cutting operation. So this is a shear plane, right? So in an orthogonal cutting operation, tool has a rake angle of this. So alpha is given to you as 15 degree, and uncut chip thickness is given to you is 3 mm, and cut yields a deformed chip thickness of this. इसका मतलब है chip thickness भी दी हुई है आपको उसने 0.65 mm, 0.65 है. The shear strain for the operation is shear strain. So shear strain कहाँ होगी? When the shear force is acting in this direction, then definitely there is going to be strain along this plane. So how much strain is produced? Obviously, because this force is trying to slide one layer over the another. This is a shear force. So that means there is going to be shear strain over there. So how to calculate the shear strain? So for that you are having the formula. So shear strain in this case can be calculated as cotangent phi. This formula you need to remember. And directly, if anything he asked based upon the formula only over here. Phi minus alpha. दो चीजें आपको पूछेगा वो. वन इज इस पर्टिकुलर सेट में वन इज द shear strain. Okay, for example, in this question we want to find out the shear strain. Sometimes he may ask you to find out the value of the shear strain rate. So shear strain rate we denote with s dot, and shear strain rate mean shear strain over with respect to time. ये shear strain rate है. This is shear strain, this is shear strain rate. Rate means with respect to time. So how we get this in terms of the, finally when we simplify, input the values and all that, then we get in terms of this formula. So shear strain rate is given by the shear Vs is the shear velocity. That is the velocity in this direction. Shear velocity, and over here this is the thickness of shear plane. Ts is the thickness of shear plane. Okay, so it means thickness of shear plane, that means this thickness. We assume this is very small, even though it's very small, but this is the thickness, this thickness. So how much is that? This is the thickness of shear plane. So if he has asked you to find out the shear strain rate, so you can make use of this. For that, he will be going to provide you the sufficient information to calculate these values, right? So Vs, shear velocity, and thickness of the shear plane, right? Only these two things could be asked in this from this particular section, nothing else. Anyway, let's focus on this now. Our job is to find out. Okay, so how to find out now? Phi. I need to calculate the phi. Phi you can calculate very easily. So tangent phi is equal to r cos alpha divided by 1 minus r sin alpha. So just input the value r, you know, r you can calculate t by tc, right? So how much is that? T by tc you will get it 0.461. Just input the value. Tangent phi will come out to be 0.5056, and phi from here is going to be 26.82 degree. Okay, just input the value. So shear strain is going to be cotangent of phi 26.82 plus tangent of phi minus alpha. So 26.82 minus 15, that is this. So this value is going to be 2.1871. Okay, this is going to be our answer. Good. Okay. So next question, I think we have already done. 35th we have done. 36th we have done. Right. So now we can, I think, take a break, and then we can move on to the next section. So I think we will take a 5. It is 5:20. So we can come at 5. Okay, 35. Okay, let's take 15 minutes break. Okay, so 35. So we'll start resume at 5:35. Okay. Okay, so let me just, so that is 35 we have done, 36 we have done. Now we will start with the 37 questions. So let's come, and then we will. Okay. Okay, so we meet at 5:35. Okay, so let's get back and let's resume the session now. So we have already done this question, as you know. So let's move on to the next question. Okay, so now what it says, a turning is performed on a work material with shear strength of this, right? And you have been asked to find out the shear force on the shear plane. Details have been given to you, and this is a turning operation, right? So we have already discussed, right? So that for turning, let's say something you need to have this kind of tool. This feed per revolution. This is rotating. This depth of cut you already know. Now, work material with shear strength, I think he is using orthogonal model as an approximation of turning. The shear force in Newton will be. Now, see, I have already discussed with you that orthogonal cutting and orthogonal turning, there is going to be little difference, right? For example, this is orthogonal turning, and simple orthogonal cutting is this one, which I think last example that we discussed. Now, what is the case in case of simple orthogonal turning? When we simplify this oblique turning into orthogonal turning, and simple cutting. In simple cutting, you are having two, three things. For example, you are having this uncut chip thickness is equal to depth of cut, right? This is what you have. Whereas in case of turning, orthogonal turning, what do we say? This uncut chip thickness is equal to what? Uncut chip thickness is equal to the feed. There is a difference. In case of simple orthogonal machining, uncut chip thickness is also equal to the depth of cut. Whereas width of the chip will be equal to the width of that particular workpiece. For example, if this is the workpiece which I am machining, then this is the width of that particular workpiece. So width of the chip will be equal to the width of that particular workpiece in this case. Whereas the uncut chip thickness will be equal to the depth of cut. Whereas in this case, the uncut chip thickness is equal to the feed per revolution, that is mm per revolution. Whereas the depth of cut, width of the chip in this case will be how much? In orthogonal turning, it is going to be equal to the same, which we have discussed. We can find it from the formula. Whereas, now see the difference. This is the only difference. In simple orthogonal machining, uncut chip thickness is equal to the depth of cut. Whereas uncut chip thickness is equal to the feed per revolution. Here, width of the chip is going to be equal to the width of the workpiece, whereas width of the workpiece, width of the chip is going to be equal to the depth of that cut, depth of cut. So this difference you should understand it clearly. Now we are not dealing with this. We have already discussed this example earlier. Now we are dealing with this. If that be the case, then I think he has given me the sufficient information. Now what I want to find out, he's asking me to calculate the formula is on the similar lines. As you know, shear stress is equal to Fs divided by shear area, which you know I have already discussed with you, Bt by sine phi. So Fs into sine phi. Fs I need to find out. Tau he has given me. So what I need to find out? Just find out the tangent phi. So tangent phi is equal to r cos alpha is equal to 1 minus r sin alpha. Now r he has given you what? Feed दिया है उसने, depth of cut दिया है, velocity. This is cutting velocity, okay? V. And the rake angle is given to you. What he has not given me? Yes, resulting chip thickness ratio is r. He has directly given me. So I know the 5. Okay, 0.5 into cos of 0.5 into cos of what? Into cos of alpha. Alpha is how much? Alpha is 7 divided by 1 minus 0.5 into sine of 7. So this value tangent phi आ गई आपकी 0.528 और phi जो है आपका सिंपली 27.83. ठीक है, ये मेरी वैल्यू आ गई. सिंपली इनपुट करो यहाँ पर. एफएस मुझे पता करना है एंड इसने दिया हुआ ऑलरेडी कि वर्क मटेरियल इज गोइंग टू शेयर स्ट्रेंथ दिया 250. सो 250 आई हैव ऑलरेडी बीन गिवन. एफएस शेयर फोर्स आई वांट टू फाइंड आउट हाउ मच फोर्स इज एक्टिंग अलोंग दैट शेयर प्लेन. यहां पर विजुअलाइज करना शेयर प्लेन थोड़ा डिफिकल्ट है आपके लिए, लिटिल डिफिकल्ट. इट इज वेरी क्लियर. यहां पर आई हैव बीन गिवन दिस केस, राइट? सो इट इज लिटिल डिफिकल्ट फॉर यू टू विजुअलाइज वेयर इज द शेयर प्लेन. कटिंग एज इज ओवर हियर, डेफिनेटली इज गोइंग टू बी एट पर्टिकुलर इंक्लिनेशन, बट यहां पर वेरी क्लियर कि आपको शेयर प्लेन दिख रहा है. एनीवे, so shear force into sine phi. Sine phi is what? Sine phi you have already got it, 27.83, and bt. B is how much? Now B. How much B? B is going to the depth of cut. Depth of cut he has given you 3 mm. And what is uncut chip thickness? Uncut chip thickness is equal to the feed mm per revolution. So it is 0.2 mm. Orthogonal. Orthogonal gonal turning. That is the only difference between this and this. So okay, anyway, so B is 3 mm and T 0.2 mm. Get it? So from Fs you are going to have in Newton, because I have taken in Newton per mm square, mm. So Fs is going to be 321.3 Newton. So I think some of you may have also got this, right? I mean, now you have already got it. So okay, this is how you are going to do it. Okay. So rest, this question was almost on the similar lines as to earlier. Only thing is that I wanted to make you differentiate between the orthogonal turning and orthogonal machining. Simple orthogonal machining. This is simple orthogonal machining. This is orthogonal turning, for which you have these relations, and accordingly you have to make use of this. Right? Okay, let's go to the next now. So what is it for better surface finish? Okay, BD. Some of you are saying B. See, one thing you need to know, take note of this. Tool has to be sharp. आपको पता है कि pointed tool, we don't keep the tool as pointed because it creates a, जो आपका edge भी weak हो जाएगा, and also it creates a lines. So definitely we cannot have a very sharp cutting tool. We don't keep that way. We provide the nose, right? So sharp cutting tool is not going to give you the good surface finish, because आपको lines दिखेंगी, fine lines over there. सेम वे फीड रेट हैज टू बी लार्ज. अगर फीड रेट लार्ज है आपका, तो इसका मतलब है हो सकता है वो कई बार कट लगा, कई बार कट लगा ही नहीं. थिंक ऑफ द सिचुएशन, फॉर एग्जांपल, यू आर हैविंग टर्निंग गोइंग ऑन एंड यू आर जस्ट मूविंग दिस टूल very fast. So obviously it may create the lines over there if you're moving it very fast. So feed rate is very fast, so obviously क्या होगा, surface finish will be poor. Now when we talk about the rake angle, now these both of these two have been, we have to decide between these two. Rake angle you have to decide based upon this. Simply अगर आप इसको सोचोगे, let's say small rake angle, sorry, rake angle नहीं दिखाया मैंने, I have just done the mistake. ये rake angle, right? Alpha 1 and alpha 2. So when you are having a small rake angle, now think of a situation where you are having a tool where large rake angle is over there. That means you are over here. Chip may flow smoothly. Whereas when you are having a small rake angle, this angle is small, you are bringing it close. That means chip which is coming will get immediately broken. It means every time when tool is moving, if it get easily broken, you have to create the new cut, something like of. Whereas if rake angle is large, then continuously that material will flow, and therefore new cut is not getting generated frequently. So it means if rake angle is large, then there is a possibility of having a better surface finish because new cut is not getting generated every time. Whereas if rake angle is small, then new cut will be generated every time when the chip breaks. Because as you know, as you will bring it closer, then as chip will be coming, it will break easily. When it will go down there, then chip will flow smoothly. Right. So it means rake angle should be relatively higher. अगर आप चाहते हो better surface finish. Why? Better surface finish means if it is higher, then chip will flow smoothly. But if it is smaller, it will break the chip easily, and therefore new cut has to be formed each time, which may deteriorate the surface quality. इस तरीके से आपको उसको सोचना पड़ेगा. Let's move on to this. Which of the following is not a assumption of merchant's first relationship? अब ये तो if you have already gone through the merchant first analysis, so some of the assumption he has made, but अगर आपको पूरी भी assumption नहीं भी पता है तो as you go through these particular assumptions, then you may find kind of some deviation. Like for example, if I say cutting edge is perpendicular to the cutting velocity, that is required because orthogonal machining. Keep it in mind, all the analysis that has been carried out is for the orthogonal machining. So yeah, definitely it has to be cutting edge should be perpendicular to the cutting velocity. That has to be, that is a basic requirement. Coefficient of friction is constant. ये भी आपने उसने assume किया. See, it is not that you need to remember, you need to identify. There is a difference between identification and recalling. Identification, it seems okay here. Coefficient of friction of variable है, तो analysis becomes difficult. So definitely this must have a good constant. Coefficient chip, sorry, I think it is continuous. Sorry, this is continuous chip with built up edge. So built up edge तो आपका क्या है? This will make the machining process unstable. Built up edge जो है, we say that built up edge में क्या होता है कि build something kind of edge पे जो है वो material gets deposited and then further it क्या बोलते हैं, it take a cut and it gets welded and something that way. So interrupted cuts will follow and which will deteriorate the surface quality. So basically built up edge is a kind of a problem for us. So definitely we will not start analyzing the problem from the built up edge, right? So if you see out of all these things, this will look awkward, right? So definitely this is not the assumption. So this is going to be the answer. Let's see other one. Deformation takes place in a thin zone, which if you think that, okay, we basically, if you may have studied, we think that, okay, this along this thin zone, basically thickness is very, very small. This shear plane thickness is very small. So deformation takes place along a very thin zone. So this is also one of the this assumption. Workpiece material should be rigid and perfectly plastic. ये इस तरह के assumption है already. So I think just go through those assumption of the merchant first analysis. But sometimes tool nose radius is 0. Tool nose radius is 0. Obviously, why 0? Because we assume that tool edge should be sharp, right? So that is why we are saying this is also the assumption. So just go through those assumptions, and even when if you have not gone through and something, if you go across these options, sometimes you find some awkward things. For example, I don't find this in any case doesn't fit in the whole scheme of things, even if you don't know other things, right? So that way elimination approach also you can apply. Anyway, just go through the merchant, what are the analysis that those assumptions which were made, pretty simple, which I mentioned over here, right? Go to this one, next one. Okay, let me just make a small correction over here. This is 0.5. Cutting ratio is 0.5. Cutting velocity, and this is meter. This is meter. Okay. Okay, now go through it. He's asking you to find out the frictional power. How much energy is lost in frictional? No friction. That is what he is asking you to calculate. Okay. So first of all, total power. Total power is how much? Total power, as you know, if you want to calculate, some power goes in shearing the material. We say this is the shear force into shear velocity plus friction force into chip velocity, because as you know, friction force is along the direction in which chip is moving. So that is why chip velocity. And if you want to calculate, we can also say cutting force into cutting velocity. This is how we denote. So total power, we can denote this way either, or total will be along shear plane and along the friction power. So this is basically the energy that is lost, you can say, along that particular shear plane, right? So shear plane, ye aapka, this is your, right? Yeah. So this is the shear cutting chip velocity, and along that direction, shear this friction force. And so if I multiply that along this plane, so how much power is lost, right? So rate of energy which is getting over here along this, that you need to overcome, right? So that we need to calculate. So that means he's asking us to power dissipated, that is the frictional work done, rate of frictional work done. This I need to, so I can say power dissipated is equal to rate of frictional work done, rate of frictional work, right? Rate of frictional work क्या आ जाएगा? Force into velocity, that is force, which force? Friction force into the chip velocity. VC is not cutting, but it is the chip velocity. So total power also he can ask you, many times he asks you to calculate the shear, that is energy which is consumed along the shear plane. Sometimes he asks you the total power also, right? So right now he has asked this value. Now you have to find out the relevant values. Power dissipated, so first you need to calculate the chip velocity also. So I think it's the calculation part only now. Chip velocity you already know. So for chip velocity, first I need to find out phi. How? Tangent phi. From here I will not calculate r cos alpha divided by 1 minus r sin alpha. Input the value. What is r? Rake angle, cutting force is this, thrust force, cutting ratio is given. Cutting ratio means r, which is r. R is given to you. Input the value. Alpha you already know, 0. From here you will get the tangent phi. So 0.5, and from here you can calculate the value of phi, which is equal to 26.565. ठीक है, phi आ गया मेरा. And chip velocity we have already calculated somewhere in earlier case also, sin phi divided by what? Cos phi minus alpha. ये है. Input the value. Cutting velocity I know already. कहां पर दी हुई है उसने? He has already given you the 85 meter per minute. ये cutting velocity है V. So he has already given input these values, and phi you already know. Alpha I am having 0, which is 0. So input this value, you are going to have the 42.5 meter per minute. What? Simply calculation part है. On the similar lines we have already done the. अब आपको फ्रिक्शनल पावर निकालनी, फ्रिक्शन फोर्स के लिए आपको यूज करना पड़ेगा फॉर्मूले जो मैंने आपको पहले दिए थे, इन टर्म्स ऑफ कटिंग फोर्स sin alpha प्लस ft into cos alpha. And what is that? Cutting force उसने दी हुई है आपको 280, thrust force 180. So cutting force 280 into sin alpha sin 0 plus ft. Ft is how much? Thrust force he has given me 180 into cos 0. Cos 0 1. So ये sin 0 0. So it becomes 180 Newton. तो मेरी cutting force भी आ गई, sorry, friction force है ये. Friction force into chip velocity I am already having. So power dissipated, I can calculate power dissipated, right? So it becomes 180 न्यूटन, और चिप वेलोसिटी इन मीटर पर मिनट है, तो मुझे वॉट में निकालनी है, तो मिनट को कन्वर्ट कर दो, कन्वर्ट मिनट इनटू सेकंड. तो 42.5 डिवाइडेड बाय 60. So this becomes meter per second, that means Newton meter per second. So ये मेरी वैल्यू आ गई Newton meter per second, that means watt. So how much is that? So this power dissipated will be 127.5 watt. ठीक है. So he can either ask you, तो ये सारी चीजें जो है you should know, or only ये फॉर्मूला पता होना चाहिए फ्रॉम द मर्चेंट जो फोर्स एनालिसिस है फ्रॉम देयर एंड दिस। तो दो तीन चीजें जो फ्रेम करता है नॉर्मली इस एरिया से जो क्वेश्चन फ्रेम करता है, वन इज रेट ऑफ फ्रिक्शनल वर्क डन, रेट ऑफ फ्रिक्शनल दिस हीट लॉस्ट या पावर डिसिपेटेड, दैट इज दिस वन, ये फॉर्मूला। सेकंड वन इज हाउ मच एनर्जी, रेट ऑफ एनर्जी कंज्यूम्ड along in shearing the material, rate of energy consumed along the shearing in shearing the material, तो उस केस में shear force and velocity in that direction vs, so fs into vs, so this plus this added together becomes the total power consumed, and या तो आप इसको प्लस इसको ऐड कर दो, total power consumed, or if he has given you the cutting force and if you know the cutting velocity, that way also you can calculate. So these are the only formulas that you have to make use of in doing these things. So दो तीन क्वेश्चन ये फ्रेम कर देता है इस एरिया से। ओके, जस्ट सी दिस वन। So basically he's talking about he's asking you to about justify the statement based upon the orthogonal, pure orthogonal cutting operation in cutting of pipe by single point turning tool. This is a pipe, right? और पाइप का पता, दिस इज वॉल थिकनेस ऑफ द पाइप, ये वॉल थिकनेस है, लेट्स से यू आर कटिंग इट। ऑर्थोगोनल टर्निंग के लिए ये आपके पास टूल है, दिस इज योर ऑर्थोगोनल टर्निंग। क्यों ऑर्थोगोनल टर्निंग? लैम्डा आपका 90 हो गया, एंड ऑब्वियसली इंक्लिनेशन एंगल आल्सो विल बी 0, बट आई एम नॉट टॉकिंग अबाउट दैट ओवर हियर। ये सिचुएशन एग्जिस्ट कर रही है, ये इसकी वॉल थिकनेस, दिस इज वॉल थिकनेस ऑफ दिस पर्टिकुलर पाइप। नाउ टेल मी, विल देयर बी एनी, where is the auxiliary? Auxiliary matlab end, smaller, that is having not that much importance. Main cutting edge, where is the main cutting edge? This is the main cutting edge, this is the auxiliary cutting edge. So in this orthogonal turning of the pipe, this auxiliary cutting edge, there is a end cutting edge angle, we sometimes we call it, that does not take part in cutting, because if that takes in part in cutting, then it will deviate the chip. Since only this cutting edge is taking play, is cutting the material, then material only flow in one plane. I will see one this particular एक और एग्जांपल देखेंगे। सो ये अगर प्लेन है तो इसमें क्या होगा कि काटने के बाद चिप जो है वो और तो इस प्लेन पे ऊपर फ्लो कर रही है ऐसे, दिस वे, सो सेम वे कटिंग एंड दिस इज फ्लोइंग दिस वे। इफ कटिंग इज बीइंग टेकन बाय, कटिंग इज टेकिंग प्लेस ओनली बाय दिस पर्टिकुलर कटिंग एज, इट मींस इस प्लेन को हम ऑर्थोगोनल प्लेन बोल देंगे उस केस में, एंड व्हेन द चिप विल फ्लो, इट विल फ्लो ऑन दिस ऑर्थोगोनल plane, and thereby we say that this is a orthogonal cutting operation or orthogonal turning operation. So in this case, if you see what it says, in cutting by single point turning tool with zero inclination angle, obviously I, as I was mentioning, I should be zero only, then ortho, and phi basically here he is talking about lambda. इसने terminology basically है, phi means shear plane angle नहीं है, he is mentioning it to lambda, that is the what we call it as a principal cutting edge angle, right, in ORS. So this is lambda is equal to 9. Pure orthogonal cutting is said to take place as कब? Chips are not at all produced when pipe is cut. ऐसा तो हो ही नहीं सकता, chip are going to produce because आप काट रहे हो, तो ये तो गलत है। There are no chips produced from the auxiliary cutting edge. Auxiliary cutting edge is end cutting edge. This is true in this case. So ये तो इतना part correct है। To deviate the chip flowing from the main cutting edge, since it is not taking part, therefore chip is not getting deviated. So only उसी डायरेक्शन में फ्लो करेगी जिस डायरेक्शन में आपका मेजर कटिंग एज का वो होगा। सो दिस इज करेक्ट। देयर आर नो चिप्स प्रोड्यूस फ्रॉम द मेन, ये मेन है, मेन कटिंग एज, मतलब ये देयर आर नो चिप्स प्रोड्यूस फ्रॉम मेन कटिंग एज, ये तो हो ही नहीं सकता, चिप्स आर प्रोड्यूस बाय द मेन कटिंग एज ओनली, तो ये भी गलत है, तो यू आर लेफ्ट आउट विद नो ऑप्शन। ओके, सो दिस इज हाउ यू हैव टू आंसर इट। सो लेट्स नाउ गो टू द नेक्स्ट वन। on increasing the shear plane angle phi, cutting force required for the okay, answer this question. Go ahead and answer this question. Okay, on increasing the shear plane angle, the cutting force required for the metal. That is phi 1. Now you are increasing this angle to phi 2. Right? Now tell me in which case you have to spend more energy. When you are having this plane to cut this plane or this plane. See, when we increase the phi 2, increasing shear plane angle, this one, that is increase the angle to phi 2, cutting force required for the metal cutting increase hogi or decrease hogi. Then you decide it that how much area I have to cut. In this case, when I will increase the shear plane angle, this length of the shear plane, this will get reduced. Width is same. In this case also, width is same. Width is that. This is the width. So whether this or this width is same, only difference is going to be on the length of this shear plane. So when I increase the shear plane angle, the length of the shear plane is decreasing. It means the area of this shear plane is less than the area of this shear plane. It means by increasing the shear plane angle, the area which is getting cut will get reduced, and therefore what happens? Therefore the amount of force required to cut the material will reduce, because you have to cut the less area. ये मतलब हुआ इसका. तो इसका मतलब है कि आपकी जो force required will reduce. A is going to be answer. Abhinav, it is not that way. As shear angle increases, rake angle increases. No. You will not say that way. You will say that as the rake angle will increase, shear angle will also increase. That way you have to say, because shear angle will not decide the rake angle. Basically, tool you are using, by changing the tool rake angle, you will see how the shear plane angle will be affected. Okay, so that is how you have to decide whether how much force is required in terms of the shear area. Shear area will get reduced, so it will reduce. Go to this particular question now. If the cutting speed is doubled, then I think go ahead, be fast on this. So I think 41 का आंसर बता दिया मैंने. बी ऑप्शन एक्सप्लेन किया मैंने डिटेल में. एक्सप्लेन यू इन डिटेल. Okay. If the cutting speed is double, then what will be the effect of tool life according to Taylor's tool life? N जो आपको दिया हुआ है. So simply go ahead. You know, he's saying if I'm increasing the N आपको दिया है उसने, and if I increase the cutting velocity, sorry, what he's saying? If the cutting speed is doubled, that means cutting speed is doubled. Initial cutting speed is V1, so cutting speed double कर दिया आपने, तो उस केस में what is going to be effect on the what tool life? कैसे relation आएगा? So let's say, so you know V1 T1 raised power N is equal to V2 T2 raised power N is equal to constant. So इस केस में V1 tool life T1 we don't know, but V1 obviously N 0.596 equal to velocity you are increasing, doubling this into T2 raised power 0.596. So V1 will cancel out. So you are left out with T2 by T1, which will be equal to 0.52 T2 by T1, 0.5 raised power T2 by T1, and then this will half, and this will 1 by 0.596, right? So this values will turn out to be, so ये आ जाएगी आपकी 0.3125. ये वैल्यू आई आपकी. Cross check it from here, which one is going to match. So obviously it is going to be 5 by 16 will be equal to this basically. So जो tool life है, he is asking you what will happen the tool life अगर मैं velocity increase कर देता हूँ twice of initial. So when I increase the velocity to v2, then tool life t2 will be equal to 0.3125 times t1 initial tool life, और ये also it is going to match with this one also. So your option B is going to be the correct answer. Okay, simple, nothing special. Okay, so let's go to the next one now. With the relate less values of tool rake angle. Okay, go ahead. Tool becomes thinner. Just see, in these kind of questions when you are having, just simply try to draw it. I think that would be better way. अगर आप draw करोगे ना, बहुत सारी चीजें clear हो जाती हैं. You can just imagine. Simply देखते रहोगे, सोचते रहोगे तो you will not get the answer so easily. Rather confusion बढ़ जाएगा. So if you want to avoid the confusion, immediately draw it. For example, with relatively less value of tool rake angle. Let us say मैं simple orthogonal turning cutting बना देता हूँ. You get the idea. For example, tool rake angle with relatively less value of tool rake angle. Okay. So ये मेरा वर्कपीस है. So ये दो सिचुएशन होगी. एक रेक एंगल ये है. लेट्स से दूसरा रेक एंगल क्या है, अगर मैं क्या करता हूँ सरफेस को और करता हूँ, बढ़ा देता हूँ लेट्स से. सो लेट्स से मैं रेक एंगल ये कर देता हूँ. सो मेरा टूल क्या है, आइदर आई कैन हैव दिस मच टूल और आई कैन हैव दिस मच टूल. सो इस केस में जब टूल मेरा ये है तो उसका रेक एंगल दिस वन एंड दिस वन. तो बोलता है कि रिलेटिवली लेस वैल्यू ऑफ टूल रेक एंगल. जब ये रेक एंगल है टू इस टूल का इंस्टेड ऑफ दिस, तो देखो क्या हो रहा है, टूल बिकम्स थिनर. क्या थिनर हो रहा है यहां पर? नो, थिनर तो तब होगा जब मैं वैल्यू बढ़ाऊंगा. सो व्हेन आई एम मेकिंग अल्फा 2, रेक एंगल बढ़ा रहा हूं, व्हेन आई एम इंक्रीजिंग द रेक एंगल फ्रॉम अल्फा 1 टू अल्फा 2, इट इज गेटिंग थिनर. ये तो नहीं हो सकता. डिसकंटिन्यूअस चिप्स आर फॉर्म. देखो, आई थिंक द सेम थिंग आई डिस्कस अर्लियर आल्सो. एज यू गो ऑन इंक्रीजिंग डिक्रीजिंग द रेक एंगल, इसको कम करते जाओगे, रेक एंगल बढ़ रहा है, रेक एंगल कम करते जाओगे, तो चिप इमीडिएटली क्या होगी, ब्रेक हो जाएगी. देखो इमीडिएटली ऐसे ऐसे कर्वेचर इमीडिएटली फॉर्म होगा. बट अगर रेक एंगल ज्यादा है, रेक एंगल ज्यादा है, तो चिप ऐसे जाएगी, थोड़ी सी ऐसे फ्लो करेगी, ऐसे स्मूथली. राइट. इसका मतलब ये है कि जो ऑप्शन है डिसकंटिन्यूअस चिप्स आर फॉर्म. ऑब्वियसली रेक एंगल कम करते जाओ, चिप इमीडिएटली जो कर्वेचर बनेगा, इट कर्वेचर विल फॉर्म एंड इट विल ब्रेक इमीडिएटली. टूल बिकम स्ट्रॉन्गर. ऑब्वियसली इंक्रीज दिस, टूल बिकम वीकर बिकॉज लेस मटेरियल ओवर हियर. डिक्रीज दिस एंगल, टूल बिकम स्ट्रॉन्गर. ये भी ठीक है. बिल्ड अप एज डज नॉट फॉर्म. मतलब बिल्ड अप एज डज नॉट एंटायरली डिपेंड्स अपॉन द रेक एंगल. बट लेट अस से वी आर नॉट श्योर अबाउट इट. अभी मुझे नहीं पता है कि ये क्लैरिटी है इसमें कि नहीं है. लेट्स फॉरगेट इट, लेट्स सी द अदर ऑप्शंस, फिर बाद में आ जाएंगे. सो tool can dissipate more heat. Now tell me which case tool can dissipate more heat. This case, जब tool आपका, when tool you are having this tool or when you are having this tool, to dissipate more heat you need to have more material. And in which case you are having more material? You are going to have more material when rake angle is small. तो rake angle जब अल्फा है तो ये इस केस में मेरा ज्यादा मटेरियल है. Then when you are having this. So इसका मतलब है कि when you are having less value of rake angle, that means this tool you are having larger material at the tip, and therefore tool can dissipate more heat. I think आपका आंसर यही मिल जाएगा. So directly you don't need to even go further. क्या है 2 3 4 5 2 3 5. Do you have 2 3 5? B is going to the option. Discontinuous chips with build up edge occur. So ये जो है you cannot directly on based upon the rake angle only. Other parameters also you have to see speed and all that also. So directly you cannot say. So sometimes even when you are not having much clarity on all these kind of options, go with the maximum possible which you can just think and get the answer. I think उससे आपका जो है कई बार क्वेश्चन आंसर मिल जाएगा आपको. Okay, so this is how you have to go. So when you will draw this way, it becomes easy to interpret. देख के आपको लगता है कि नहीं यार ये बड़ा हो रहा है, मटेरियल कम है यहाँ पर कि ज्यादा है. अगर अल्फा एक एंगल बढ़ा दिया, टूल को मैंने इतना कर दिया, तो what is going to happen? So that way you can get. So always, particularly in metal cutting, sometimes you are having difficulty of imagining. So do this method. If you see most of the other theoretical questions which I have explained to you, I have been drawing these diagrams. So उससे क्या है, clarity ज्यादा आती है, you can answer them easily. Okay, let's go to the next one. Which of the following is not true for shaping process? You know, shaping and all that. So go ahead. is not true for shaping process. Cutting tool is provided reciprocity. Shaping, shaper में, if you can imagine the shaper process, shaper में क्या करते हो? You ram move करता है. When ram moves, reciprocates, it means tool is given the reciprocating motion, right? That you have understanding. Cutting tool is provided, which is not true. We have to find out which is not true. So cutting tool is provided reciprocating motion. This is true, right? Reciprocating motion देते हो आप ram के through. Workpiece is fed parallel to the cutting direction. Workpiece is fed parallel to the cutting direction. ये workpiece है, right? This is workpiece. This is tool reciprocating. Now tell me, cutting direction ही है. This is the cutting direction. तो feed motion किस direction में होगी? Give me the direction of feed. Perpendicular to this board or in the direction of this? If I will start from this end, I have to cut the entire this surface. So if starting from this end, cutting velocity direction is this. Feed direction will be this. It means it is going to either this direction or this direction. If I'm starting from this end, then obviously it is going to be this way. So it is perpendicular to the cutting directions. Workpiece is fed. ये feed direction है. Workpiece is fed perpendicular to the cutting direction. Perpendicular direction, cutting direction. Workpiece is fed parallel, not parallel. Feed direction is this, cutting direction is this. So ये statement जो है वो not true, not true. Got the answer? It is called intermittent cutting. Intermittent break में. Intermittent cutting. Obviously intermittent ही है, it is intermittent only. One cut, no cut, there is a pause, then again cut. So intermittent breaks. So this is true. So it means you are having this. Okay, let's go to the next one now. Which of the following is correct for up milling? So easier chip disposal, cutting and food feed direction are same. Feed है. This is R. Okay. This is up milling, right? This is workpiece. You are giving the feed motion this way, and this is cutter, and you are this. Now, upward forces tend to lift the workpiece. Which of the following is correct? कौन सा correct है? Sorry. Which of the following is correct for up milling? Which is correct? So, okay, upward forces tend to lift up workpiece. ये life नहीं है इसमें, थोड़ी गलती है. Upward forces tend to lift up the workpiece. This is the workpiece. Basically, this is the workpiece. So obviously, as you know, as this cutting starts, it will try to, because here you have clamped this workpiece down there. So when it is rotating, it is trying to lift that workpiece upward, right? So it means this statement is correct. So यही पूछ रहा था, वो correct होगी. Rest अगर देख लो, easier disposal, easier chip disposal, easier. It is not going to have easier chip disposal because chips are going to fall over here. It is going to create the trouble for you. Cutting and feed direction are same. No, cutting and feed direction is this. Feed direction is this. Cutting direction is basically perpendicular to the teeth, right? When you are having cutting edge over here, so tangential to that. So cutting direction is tangential to that particular cutting edge, whereas feed direction is this one. So obviously this is not correct. So this is also not correct. This is also not. Less power is required. You cannot say. And comparing to what? This is a general statement. So we cannot say less or more power is required. And comparing to what? No information is given. So anyway, initially we got the idea. This is the A is going to the correct option. See this one? So I think you must be able to answer this. Heat transfer, if the heat transfer to the atmosphere is neglected, then what is the average amount of heat in percentage carried away by the chips? See, ध्यान रहे आपने, you must have carried out the cutting, okay, this in the lathe, you must have done the turning operation at least in the workshop, and you must have seen that, okay, the chip which comes out is red hot, right? It means largest amount of heat is carried. So this is roughly, if we talk about chip, roughly carries out 80% of the heat. And then if we talk about the tool, then almost roughly about 15%. And then workpiece, so least amount of heat goes into the workpiece, and this is roughly about 5%. So this general idea of the heat which is being carried by the different members you need to have. अब इसने बोला कि चिप का कुछ, when chip is coming out, तो obviously कुछ एक dissipation उसने इग्नोर कर दी, but if we have to most probable, अगर हमें find out करना है based upon this much understanding, which one will you go for? Chip cannot carry that much heat, as simple as that. Rest are less values, so you are left out with no option other than the 70. So normally you can say if the value is roughly about 75 to 80, you can just think of like that much amount of heat is being carried out. So around that value, any value if it is mentioned, you will go ahead with that, right? 75 to 80%, right? That's general idea you need to have. Okay, go through this. In orthogonal turning, he's saying, what is the situation that you are going to have? अब ये जो whatever that we discussed, for example, हमने orthogonal turning की भी बात की, let's say pipe की भी बात कर रहे थे when we were talking. For example, this was the case when you are having this one and you are turning it, and let us say this was the feed. So this becomes the orthogonal turning. Now, इस केस में ध्यान रहे, आपने एक चीज ध्यान रखनी है, because जो चिप है, I think somewhere in the earlier question also I explained you, इस केस में in orthogonal turning में, अगर इस केस में अगर आप just imagine you are having this way, this is turning taking place, this is, and here you are having the tool, right? This is the workpiece which is rotating, and here you are having the tool which is cutting is being carried out. Now when the cutting is being carried out, right, let's say this is the plane, front plane. Now tell me, right, so this is being cutting is being carried out. Now tell me the direction of the cutting velocity. He's talking about the cutting force. Okay, tell me the direction of cutting force. Clear? ये rotate कर रहा है ऐसे, और ये tool का है जो यहाँ पर, the same thing which I have displayed from the top view, you can say. So direction of the cutting force. Direction of cutting force is what? Vertically upward or downward. ये cutting force की direction है ये, because यहाँ पर आपका material कट रहा है. And what about the thrust force? इस direction में. And if I ask you on which plane both of these forces are lying, one is vertical, other one is the horizontal. Both these forces are lying on this plane, front plane, जो सामने plane दिख रहा है आपको. तो एक तो cutting force downward है, and दूसरा thrust force है ऐसे. तो on which plane it is lying? It is lying on this plane. And what is the resultant of these two forces? Somewhere here, एक vertical है, एक horizontal है, which is thrust force. This is cutting force. Then resultant may be somewhere here. So it is lying on which plane? On this plane only. And this plane in this case is the orthogonal plane. Right? And in orthogonal cutting, I have earlier mentioned also why we call it as orthogonal cutting, because chip flows in the orthogonal plane. अगर मैं आपसे कहूँ in which plane the chip is flowing, so you will say after getting cut from here, chip will flow this way. It will go and flow. कौन से plane में? ये board का plane ले लो, and chip after getting cut will flow in this direction, this way. So when chip will flow in this way, then this plane in which is flowing, we call it as the orthogonal plane, and this is how the situation is going to be. तो ये जो plane जो मैं mention कर रहा था आपको यहाँ पर, कि ये सामने वाला plane where cutting was taking place, which I explained you, vertical force, sorry, cutting force, thrust force, and resultant is going to be somewhere on the same plane. So see, resultant cutting force is always confined in the cutting plane. No, cutting plane ये नहीं है, ये plane cutting नहीं है आपका, right? So resultant cutting force is always confined in the orthogonal plane. Resultant cutting force is always confined in the orthogonal plane, which I told you. So here is plane पे दो forces and resultant. So ये आपका. So if you can visualize this, then I think you can answer this very easily. In orthogonal turning, what kind of situation is going on? Okay, so that is how you have to answer this. The force component Py, transverse force is always 0, right? So transverse force, now he's saying, I don't know, he may be mentioning this component as the perpendicular to that, but it may not be always be 0, but okay, maybe minimum. So let's now go to the next one. Let's see this one now. Okay, let's see this. Underformed, this is undeformed, just small correction, undeformed. This is undeformed and this is coefficient. Okay, this has been corrected. And you are having all other things are okay. Okay, go ahead. During an orthogonal machining with a HSS tool, rake angle was this. Undeformed chip thickness और uncut chip thickness इसको हम बोलते हैं uncut chip, clip not clip, chip, uncut or undeformed chip thickness was this. Coefficient of friction between the chip and the tool was this. Using Merchant's first solution, chip thickness, right? So you have been given this rake angle 5 degree. What else? Undeformed chip thickness, that is T is equal to 0.2. Orthogonal machining है ये. And coefficient of friction is given to you 0.6. And what else? Chip thickness आपने निकालनी है कि how much is the 0.6 and आपने chip thickness निकालनी है. What is going to be the thickness of the chip in the orthogonal machining operation of this kind? You know, I can find it out if I can find out the R. You know, R is equal to T by TC, right? If I can find out R, I can find out this value of, because T I know, chip thickness I can find out. And you know, I have this relation tangent phi is equal to R cos alpha divided by 1 minus R sin alpha. I can find it out from here. Sin alpha. But from here, to find out the value of R, I need to find out phi. And alpha I already know. And phi, to find out the phi, he has already given you one hint. Using Merchant's first solution. What is Merchant's first solution? Merchant's first solution is 2 phi plus beta minus alpha is equal to 90 degree. ये आपका relation है Merchant के through. Merchant's first solution जो है आया आपका, right? In cutting, in orthogonal cutting. So over here I know alpha, I don't know beta, phi I also don't know. Beta I can calculate. How? Because you know mu he has given you. How you can calculate? Beta is the angle of friction over here in this equation. So coefficient of friction is equal to the tangent of angle of friction, that you know. From here I can find out the value of angle of friction beta. So 0.6 is equal to tangent of angle of friction beta, and beta becomes what? How much is that? Angle of friction beta becomes 30.96. So if that be the case, then input this value over here, and from here get the value of phi. So 2 phi plus beta 30.96 minus rake angle phi and equal to 90 degree, right? From here I can get the value of shear plane angle phi, which is equal to 32.02 degree. Am I clear? If that is the case, then now simply input the value. Tangent phi I know now, tangent 32.02 degree equal to R I want to find out. Cos of alpha I already know, 1 minus R into sine of phi. So from here I will be able to find out the value of R, which I got as 0.595. Okay, and R is equal to T by TC, so which is also equal to T by TC. So since I know T, I can calculate the TC. So chip thickness that I'm going to get over here is will be 0.336 mm. Okay, in parallel also you should try these questions. Okay, keep trying. So because that will increase your speed also, and your like kind of thinking ability also, because you will try to interpret these questions as fast as possible. So that way it is going to be quite a good exercise for you. Okay, done. That's all. So Merchant's first solution you should know, and one more thing that you should note down is the, you know, you're having Merchant's first solution and second solution. let's say if he has not mentioned anything, he simply say use merchant solution. That means you're talking about the merchant's first solution. Either you should categorically say merchant's first solution or merchant's second solution. In this question, he has clearly mentioned. If he has not clearly mentioned, simply says the merchant solution, then it means he's talking about the merchant's first solution also, or only merchant's first solution only, right? So that is the point that you need to take note of. Okay, let's move on to the next now. Basic purpose of reaming. I hope you will be able, all of you must be able to answer. Go ahead. What is the purpose of reaming? Drilling, boring. Okay. Okay, so basic purpose of reaming is, drilling to make a hole, boring to increase the diameter of the hole, reaming to finish the hole. अगर आप finish करना चाहते हो hole की accuracy, you want to improve the accuracy of that particular hole which you have drilled or boring you have done, then we can go for the process called as reaming, and the tool that we use we call it as a reamer, right? So improve the surface finish of the hole which you have, increase the hole diameter. ये तो क्या है आपका after drilling, ये driving नहीं है, drilling है. Increasing, this is what, this is boring, right? Increase the depth of hole and all that, this is not relevant. In a horizontal milling machine, the milling cutter is mounted on. Okay, go ahead. ये आपका milling cutter था. This was milling cutter. So let's say this was the process that I was talking about earlier that we explained. Let's say, so ये जो यहाँ पर स्पिंडल सा दिख रहा है, इसके ऊपर जो माउंट करते हैं इसको बोलते हैं आर्बर, राइट? समथिंग दिस वे, राइट? ये आर्बर है और वी विल माउंट दैट टूल ओवर हियर, समथिंग दिस वे, एंड यू आर हैविंग this teeth on this cutter over here. So with this arbor it is going to rotate this way, right? So this, the spindle, or you can say on which it is mounted, this cutter is mounted, we call it as a arbor, this one. So ये क्या है आपका arbor. Okay, go ahead with this. Rotates at, okay, I have modified it. Okay, it is given to you. Which one is that? For machining of 150 long workpiece, this is given to you. It is machining cost, right? So what it says that overhead paid per minute was this. पर मिनट जो कॉस्ट आ रही है उसको मशीन करने की, दैट इज 60 रुपीज पर मिनट टू machine that component. The overhead, that means 60 rupees per minute you are spending, right? Now let's see how much time it will take for that machine or for that component to be machined. ये पता करना है आपने. So क्या है, you are having this workpiece. So what I want to find out, you know that per minute you are spending this much money. So if I will come to know that how much time I am taking to machine this workpiece, then I can tell you that how much machining cost will be required, how much cost will be required to machine this component. तो मुझे क्या करना है, when I started the tool from here, let us say, then I need to find out what is the so this is the length of this. So how will you find out the machining time? I hope you know machining time. I can find out length of cut divided by the feed per minute. So ये क्या जाएगा, लेंथ ऑफ कट कितनी, और द डिस्टेंस इस केस में फीड लेंथ ऑफ कट, और इस केस में द लेंथ दैट दिस पर्टिकुलर टूल हैज टू ट्रेवल डिवाइडेड बाय द फीड पर मिनट. नाउ सी द डायमेंशंस ऑफ दिस. सो लेंथ ऑफ कट दैट मींस इन एमएम, लेट अस से, एंड फीड पर मिनट एमएम पर मिनट. ये बेसिकली कुछ नहीं है, ये सिंपली फॉर्मूला आपका वेलोसिटी और डिस्टेंस का फॉर्मूला, और कुछ नहीं है. ये क्या है, टाइम कितना हो गया, डिस्टेंस, डिस्टेंस देखो ये क्या होगी, स्पीड, speed, this becomes speed only. So the can I say speed is equal to what, distance over time, यही तो है. So इस केस में क्या होगा, when I start machining this particular workpiece, then how much, with what velocity it is moving. This velocity, we call this velocity as feed velocity. So I have two ways of representing this velocity. You know, I can represent it as mm per revolution. That is one way of representing, or I can also represent the feed as mm per minute. Am I clear? So if I will represent this feed in terms of mm per minute, then I will say this is the feed velocity. So with what velocity it is moving in this direction? This. If I know with what velocity it is moving in this particular direction, and if I know that how much distance it has to travel, it has to travel the distance equal to the length of that particular workpiece. So this is the distance it has to travel. Then I can tell you how much time this tool took to reach from this point to this point. That is the meaning of this, right? That you know. So वही फॉर्मूला ये. तो लेंथ इस केस में क्या होगी आपकी, डिस्टेंस जो आपने ट्रेवल करना है उसने. सो नाउ लेट्स राइट इट दिस वे. Length of cut, or you can say distance this tool has to travel. How much is that? You know, length he has given you. How much? Now feed per minute I can represent because he has given me the feed in per revolution. So feed per minute can be represented this way also. So length into feed per revolution multiplied by revolution per minute. Feed mm per revolution multiplied by revolution per minute. So this will become, unit will become what? Mm per minute. Revolution will cancel out. So you are left out with what? Mm per minute. Sorry, minute. This is mm. So total units are going to be mm will cancel out. You are left out with the minutes. So now write it down. Length is how much? Distance you have to travel is 150 mm. Feed per revolution is how much? He has given you 0.15 mm per revolution. And what is the revolution per minute? Sorry, revolution per minute RPM he has given you 1500. So this becomes the revolution 1500 revolution per minute. So time taken to machine this workpiece or time taken by this tool to reach from this end to this end will be how much? ये मिनट में वैल्यू आपकी आ जाएगी. That will become 0.667 minute. So machining cost कितनी आएगी? So machining cost will be going to be per minute you are spending 60 rupees in terms of overhead. So how much money you spend to machine this particular workpiece which took this much time? So machining cost, you will say machining cost is going to be per minute you are having 60 rupees. If you multiply the time it took for you to machine that particular component 667, then you're going to get it as rupees 40.02 whatever. ये मेरी वैल्यू आ गई. Good. Okay, great. So ये तो this formula you use everywhere, not only in turning but also drilling also you are having in milling also. So I think this basic formula you are clear about. Okay, let's go to the next now. Go through it. So tool changing time is, let me just correct, tool changing time is corrected, paid. Okay, correct. Okay. इसमें थोड़ा सा कंफ्यूजन होगा आपको इस क्वेश्चन में, मे बी बिकॉज ऑफ द वे दिस क्वेश्चन इज फ्रेम्ड. For machining operation it takes 35 seconds. Tool changing time is 20 seconds and tool life is 10 minutes. Tool changing time is 20 seconds. If the overhead and labor cost per minute paid for this operation is 30, tool changing cost, देखो टूल चेंजिंग कॉस्ट का कंसेप्ट कहां आता है? टूल चेंजिंग कॉस्ट इज द कॉस्ट इन्वॉल्व्ड व्हेन यू चेंज द टूल, एंड व्हाइल चेंजिंग द टूल जो आपका टाइम वहां पर वेस्ट हुआ, आइडल टाइम है, दैट इज बेसिकली द कॉस्ट इन्वॉल्व्ड. बिकॉज ड्यूरिंग दैट टाइम व्हेन यू आर चेंजिंग द टूल आपने निकाला and maybe you are sending it for grinding. तो उस प्रोसेस के दौरान, during that particular process, you're wasting the time. During that time, your tool is not getting used or machining is not taking place, and therefore there is a cost involved in it, right? So if you see, for machining operation it takes 35 seconds to complete the operation. Tool changing time, ये जो time है tool changing time कितना है? 20 seconds का है. It means 20 seconds your machine is getting remaining idle. 20 सेकंड तक कोई काम नहीं हो रहा है. इसका मतलब क्या है? टूल चेंजिंग कॉस्ट कितनी होगी? The time for which this machine remain idle. And what are the overheads? Overhead and labor costs combined together per minute paid for this operation is ₹30. तो per minute जो आपका जो कितने हैं, बेसिकली जो एडिशनल कॉस्ट लगानी पड़ेगी, लेबर को तो चार्ज देना पड़ेगा आपको, मे बी अदर ओवरहेड्स आल्सो, सो दे आर इन्वॉल्व इवन ड्यूरिंग द आइडल टाइम आल्सो. सो इसका मतलब ये हुआ कि इफ आई से टूल चेंज टाइम कितना है इन टर्म्स ऑफ मिनट्स, 20/60. इतना टाइम, दिस मच टाइम you invested, or sorry, not invested, this much time it took for to change the tool, and per minute you are spending this much. So for how much is the cost involved? Total tool changing cost involved will be how much? So per minute it is ₹30. So how much time it took for that tool changing time is how much? This much. So it means if I multiplied that tool changing time with the every time per minute how much you are spending in terms of overhead and labor cost, then this is going to give me this one ₹600, right? ₹10, right? But point is, ये कब इन्वॉल्व होगा? ₹10 जो खर्च कर रहे हैं कब होगा ये? When the tool life will be over. उसके बाद ही तो करोगे चेंज. When you are going to change the tool? When the tool is getting replaced or you are taking the tool out and sending it for grinding, तब होगा ये. इसका मतलब है after the tool life of 10 minutes. तो ये जो cost आप बात कर रहे हो, when you're talking about this cost, then this will be after 10 minutes. क्योंकि टूल जो उसके बाद आप रिग्राइंड के लिए भेजोगे या whatever, तो टूल लाइफ 10 मिनट के बाद इतनी कॉस्ट इन्वॉल्व होगी. ठीक है. नाउ बट ये क्या होता है टूल चेंजिंग कॉस्ट? ये टोटल टूल चेंजिंग कॉस्ट नहीं बोल रहा, बेसिकली क्या कह रहा है? टूल चेंजिंग कॉस्ट per operation. Basically this was his question. इसने जो he has not framed this question very properly, but he has asked you to find out the tool changing cost per operation. This is question actually. This should have been framed this way. Per operation tool changing cost कितनी है? तो what you need to find out, आप बोलोगे कि total tool change cost इतनी है, but life of the tool अगर इतनी है, तो उस during that life of the tool how many operation were conducted? How many operation were conducted? ये तो इन्वॉल्व होगी after 10 minutes, but during that 10 minutes how many operations were conducted? So if I know the number of operation during that 10 minutes tool life, then if I will divide this cost by the total number of operation performed during that particular tool life of 10 minutes, then my job will become easy. I can find out the tool changing cost per operation. So you know what he's saying, that in machining operation it takes 35 seconds to complete the operation. One operation it takes 35 seconds. So can I say for one operation it takes itne minutes? ठीक है क्या मैंने? I have written it correctly. For one operation it takes 35 seconds, this much minutes it takes. Then since tool life is 10 minutes, so during 10 minutes of tool life how many operations were conducted by this tool? You will say in 1 minute 1 divided by this, and during 10 minutes it will become equal to 10 in 10 minutes of life, minutes of tool life, number of operations performed. कितने होगी? कितने ऑपरेशन परफॉर्म किए? आप बोलोगे 1 divided by this multiplied by 10, so it becomes 60/35 multiplied by 10 minute. So this become इतना ऑपरेशन. So how much is that? कितना आ जाएगा देखना. 60/35 10 is becomes 17.143 ऑपरेशन. इतना ऑपरेशन परफॉर्म किए. Clear? So tool life is of 10 minutes. So during the tool life of 10 minutes you perform this many operations, and after 10 minutes when that particular tool life was over you spend 10 rupees. Then if I want to calculate that cost of what? Tool cost, tool change cost per operation, then what do you need to do? You just divide this total cost with the total number of operation performed, then you will get the tool changing cost per operation. Tool changing cost per operation. Per operation basis. See, doesn't carry any meaning. आप बोलोगे after the tool life is over, only after that you have to have. But let us say if you ask to calculate this on per operation basis, then you have no other way just to go this way only. So that means rupees 10 divided by 17.143, which becomes equal to rupees, कितने rupees आ गए ये? 0.5 rupees 0.58 per operation. ये आ गया मेरा. तो हर एक operation के basis पे if I want to calculate, then I can calculate this much is the tool changing cost. If he is asking simply total tool changing cost, तो ये story जो है वो carries no meaning. Carries no meaning. Then my job answer should have been this much, because I can only change the tool when the tool life is over, or I am sending it for grinding. Because even if I am sending it for grinding, for me this tool life is over, right? Right. So I hope 171 point. Okay. Just check it. Not 171. It should be 17.14. You committed a mistake somewhere, I think. Okay. Okay. Then let's go ahead to the next question. I think this would be easy for you to go ahead with this. Go ahead. In a milling operation, the feed velocity used was, okay. So rotational frequency was this much. Feed velocity, that means he has given you the feed per minute दिया उसने 5 meter per minute. He has given me rotational frequency, that is RPM, speed 200 RPM, and the number of teeth on the milling cutter. So I will denote with that. It is up to you how you are denoting, but the number of teeth on milling cutter is 8. The feed per tooth in mm per tooth. So feed per tooth, basically you are going to calculate this one was how much. You already know that how we calculate the feed per minute, right? Feed per minute is equal to feed per revolution multiplied number of revolution, right? That is how you calculate. So this is mm per minute or meter per minute. That is up to you how you calculate it. Mm per minute, let us say, and if I mm per revolution and revolution per minute. And in case of milling, as you know, the value is given in terms of cutter, number of teeth on the cutter. So for example, if you are having n number of teeth on the cutter, then बोलता per tooth कितनी है. So what you need to do is, when it rotate by a distance between the two teeth, then how much is that? So in terms of, I can write this in feed per tooth multiplied by number of teeth. So this becomes feed per revolution multiplied by n. It remains same. So feed per tooth multiplied by feed per tooth multiplied by number of tooth right. So this becomes a feed per revolution. So just simply now input it, nothing special in it. F, where you are having 5 meter, so let me just take it in mm only, because he's asking me to calculate in mm per tooth. So I'm converting this value meter per minute into 5000 mm. 5 meter become 5000 per minute equal to feed per tooth. How much? That is what I want to find out. Feed per tooth, that is mm per tooth. That is what I want to find out. So multiply the number of teeth is 8, and revolution per minute 200. So this is per minute, revolution per minute. So I'm not dividing by 60. So as simple as that, feed per tooth आ जाएगी आपकी in mm. So how much is that? 3.125 mm per tooth. Clear? Okay, good. So that is how you have to find. Pretty simple, I think. In this case, you can find it out easily. Go ahead. Okay, give me the answer. Are you getting? Similar lines पे है, it is on the similar lines as we have seen earlier question also. क्या बोल रहा है? Mild steel workpiece turned within 30 seconds. मतलब ऑपरेशन टाइम कितना है? What is the operation to carry out one operation? How much is the time? ऑपरेशन टाइम, एक ऑपरेशन को कैरी आउट करने का टाइम, what is the time to carry out one operation? What is it? That is the 30 by 60, that is a half minute. And the tool life for that operation was 1 minute. Tool life कितनी है? 1 minute. इसका मतलब है after every one. Now what he says that tool cost per grinding was this. Now it means when you will send the tool for grinding, you send the tool for grinding only when its life is over. As simple as that. इसका मतलब ये है कि you are spending 16 rupees as a tool cost for grinding, 16 rupees after 1 minute. 1 मिनट के बाद आपको after every 1 minute you have to spend 16 minutes. So if I want to calculate that on per minute per operation basis, then how much is going to be? Why you are saying 32? भाई एक ऑपरेशन के लिए तो टाइम तो आपका आधा मिनट लग रहा है. And how much you are spending? You are spending 16 rupees after 1 minute. तो अगर पर ऑपरेशन के बेसिस पे कैलकुलेट करना चाहूं तो that means after half minute. In half minute how much you are spending? 8. As simple as that. तो पर एक ऑपरेशन to perform one operation you are only taking half minute, and after every 1 minute you are spending 16 rupees. So if I want to calculate on per operation basis, so tool cost per operation for this operation, that means one operation, tool cost per operation, तो simply क्या हो जाएगा? Tool cost after 1 minute is 16, and since in tool life of 1 minute, how many operations you are performing? You are performing 2 operations, so that means 8 rupees. ये सेम ही है तो जो हमने earlier question, the same question which we have done earlier. It is relatively simple rather. तो हर ऑपरेशन के लिए आप in terms of tool cost जो होगा that is going to be 8 rupees. उसको सिंपल बना दो क्वेश्चंस को. लाइक जब आपको वो स्टेटमेंट दिए, जस्ट थिंक एंड पुट इट इन ए वेरी सिंपल फ्रेमवर्क. एज सिंपल एज दैट. है ना क्लियर? तो ग्राइंडिंग तभी होगी जब टूल लाइफ ओवर हो जाएगी. एज सिंपल एज दैट. ग्राइंडिंग के लिए इफ आई एम सेंडिंग द टूल फॉर ग्राइंडिंग, इट मींस now this tool life has become over and now I have to regrind it and then I have to bring it back. See this one? Go ahead. I hope you can do it. Right? I hope you got this. So simply I'm having a this is surface grinding, let us say tool. So you are having this disc of that particular grinding disc, and you are having on periphery you are having those cutting edges in the form of grinding grains and all that. So how much you are moving? He's saying feed velocity. ये आपको दी हुई है 6 मीटर पर मिनट. So how much is the what material removal rate? Material removal rate कैसे निकाल सकते हो? In this case, material removal rate is going to be what? If I know how much material, see, this is the cross section area which you are removing, and with which particular velocity you are moving in that direction. So you are taking any particular cross section area. If you take, how much is that? Add area into velocity. So in this case, I can say feed velocity, whatever you call it. So this is equal to feed, sorry, not feed, I can say this whatever width of cut, which is this dimension, which is 5 mm, into what is this 0.05 mm. So this becomes area which is being cut with what velocity? Feed velocity of 6 meter per minute. So 6 meter means, so he's asking me to calculate mm cube. So I'm converting into mm per minute 60. So this becomes mm. So this becomes total becomes how much? 0.05. So this becomes your 25 mm cube per second. So simply okay, right? So simply draw that operation immediately and you can get it done. So this becomes my machining cost. Okay, or not machining cost, material removal rate. How much material you are removing, right, per second. Okay, so let's go to the next one. The tool life reduces the just see this one. Tool life reduces for rake angle larger than the optimum one. I think you can get the answer for this question from the earlier one, which we have discussed. I think a similar lines pair. Just go through it. Okay, I will give you just so that you can read it out, or rather you are already having that one. So just a minute. Let me just. Rake angle. Right. So life reduces for rake angles. Tool life reduces for rake angles larger than the optimum one. अगर हम ज्यादा कर लेते हैं optimum से one, because क्यों? Of the chipping of the, so what happens if we increase the rake angle larger than the optimum? So obviously यहाँ पर space क्या हो जाएगा? You're going to have lesser material and therefore it may chip off. So ये तो correct है आपका. Tool edge gets weakened. Interpretation is same. This one and this one is more or less very much related, because at the this particular over here you're going to have very less value of material and therefore it can easily chip off, or we can say this also gets weakened. So cutting force acting on the tool increases. How to interpret? Let's see. So you're going to have of the strain hardening of the work material workpiece. Strain hardening to hoti hai. How does it related to only rake angle small v hota? So rake angle small v hai, then also it is going to have of larger temperature accumulation in the tool. I think we have discussed already. यहाँ पर क्या होगा? Less material, larger accumulation of the temperature, and therefore it is going to be right. So when we cutting force acting on the tool increases, it carries no meaning. Rather, what happens is when we increase the rake angle increases, shear plane angle also increases. Shear plane angle increases, so shear area decreases and amount of force required to shear the material decreases. So total force is acting will decrease. So this may not be correct, and so you are left out with only three options are given. Strain hardening तो आपका दोनों cases में होगी. You cannot, strain hardening is the material को जब आप deform करोगे, whether rake angle is small or larger, it is going to be over there. So not relevant from this context. So go 1 to 5, 1 to 5, 1 to 5, 1 to 5. Related, I think it is the same, one of the similar lines as we have discussed earlier also, right? So B is going to be the correct option. Go to this question. Okay, so just you solve this question. In the meantime, within 1 minute, I'm coming back. I hope you will do that by that time. Okay. Take care. 1 to 1.5 minutes. So, hope you have done it. Turning operation using the high-speed steel tool. Cutting velocity आपको दिया, Taylor tool life equation parameter दिया हुआ, and the operation is conducted dry and all that. Okay. So what he's saying is, so cutting speed, high-speed steel cutting velocity. Speed, let us say this is V1 equal to 90 meter per minute. Taylor tool life equal to N equal to 0.12. And C is 130 meter per minute. So you know C is the cutting velocity for a tool life of 1 minute. So that is why it is units have been given in meter per minute when the operation is conducted dry. Now when the coolant is used in the operation with the same cutting speed, that means V2 is same. The value of C is increased by, now C, you in this case C you are increased by 10%. 10% of earlier. 10% of earlier मतलब 1.1 times 130 meter per minute, right? Right. So, right. The percent increase in the tool life. That means I am supposed to find out T2. Kitni ai? Over here, I am also not sure about the T1. So first I need to find out the T1 and T2. So just find out these values. So first, you know very well, you can just go ahead and V1 T1 raised power N is equal to C. So what is that? V1 is 90. I don't know T1. T1 raised power N is 0.12 and which is equal to, keep it in mind, this value in this equation, this value should be in meter per minute. Don't commit the mistake of like units. Velocity should be meter per minute and time should be in minute, right? So it means if I'm inputting this value in meter per minute, automatically this has to be in minute, is equal to how much? C I'm already having, that is 130. So from here I can find out the value of T1, which is equal to how much? 21.366 minute. ये मेरी value आ गई. Now what about the T2? So when V2 T2 raised power N is equal to C, now C is changed, keep it in mind. So I can say this is C1, C2 also, but if you want to differentiate, but V2 is how much? V1. V1 is 90, T2 raised power 0.12 is equal to 1.1 times, that is 10% more, if I'm correct. He's saying 10% more, yes, increased by 10%. So that is why I'm writing it is 1.1. So 1.1 times 130. So from here you're going to add the T2. T2 is how much? This is 47.378 minute. So if that be the case, then he's saying percentage increase in tool life. Percentage increase in tool life, that means compared to this, that means percentage increase will be equal to T2 minus T1 with respect to initial T1. So it means 47.378 minus 21.366 divided by 21.366. Okay, so this turns out to be how much percentage increase? 121.7%. Okay, done. N will be same, and is not going to change because he's changing the, by changing the parameter, he's saying that C value is getting changed. Okay, so let's now go to the next one, shaping. Again, shaping question, I think. What is that? Shaping operation cutting speed is this one. Which one is this? 59. Go ahead with this and let's see what you find out in this case. It's, I think this question is going to be relevant for you in the sense that sometimes he can frame the questions. He has framed on these lines earlier also. So I think that is going to be useful for you. This question, I think, and next question also maybe. Go ahead. He's asking you to find out the power consumption of the process in watt, right? Shaping operation. Let's say I'm showing this way. This is a tool. Tool is moving this way, okay? So in the shaping operation, cutting speed is this. This is a cutting speed direction, as you know. Feed is going to be perpendicular to that. Feed direction, jo hai, wo ye hai. This is a speed direction. So anyway, so cutting speed, he has given you 5 meter per minute. Feed 0.2 mm per stroke. Depth of cut, you know, 0.3 mm. Specific energy for the process is this much. Now, I hope you know the specific energy that in single point cutting tool case also you may have studied about it. So specific energy consumption, when we talk about specific energy is given by power, the power consumed in the process, right? So cutting power, we can say this as a cutting power with respect to material removal rate. ये आपका जो है वो स्पेसिफिक एनर्जी होती है कि टू रिमूव ए यूनिट फॉर द यूनिट मटेरियल रिमूवल रेट, how much cutting power is used. That is the meaning of this. That is how we call it as a specific cutting energy. Now point is, I need to have units, set the units, because I want this in process is in watt. I want in watt, but what he has given me, specific energy he has given me in joule, that is Newton meter per mm cube. This is how he has, these are the units, right? Set the units over here. To match the units, cutting power I need to have in Newton meter per second. Cutting power, right? Joule per second. And material removal rate mm cube per second. Am I correct? Second is going to cancel, so it is going to be second will cancel, and Newton meter per mm cube. Newton meter per mm cube. It means on this side, if I will input the units this way, then I think that 10 is going to match with that. Now, what is the cutting power? That I need to find out, because he's asking me to calculate the power consumption of process, because I need to find it in watt. So that is why Newton meter, this becomes watt. So now, first of all, and what about the material removal rate? Material removal rate, you can find it out, right? How? Because again the same thing which I have shown you. This portion is getting removed, right? So how much is that? Because you know the cutting velocity in this direction. So can I say material removal rate is going to be feed into depth of cut into cutting velocity? Okay, just remember this is a tool, right? Let's say this is the first stroke in which this one. So when the stroke starts, see, I can also find out the material removal rate from the total volume of the material that is removed in one cut divided by the time for machining. But that way I will not be able to do that because I don't have the sufficient information to calculate that way. But for me, the information is because he has given me the cutting velocity when the tool is traveling this way. So tool travel direction is this way. And if I know the velocity and the cross-section area in that direction, which is getting removed. So what is feed? This is feed. And what is depth of cut? This is depth of cut. So if I multiply this becomes the cross-section area, and perpendicular to that velocity, that is cutting velocity of the tool, which he has given me, what is that, 5 meters per minute, and my job becomes easy. So it means for me, I can write the material removal rate in this case this way, which is equal to feed how much? 0.2 mm per stroke multiplied by what is the depth of cut? 0.3. This mm, and velocity I need to convert into mm. So 5,000. This becomes mm cube per minute. So should I take it in minute? I need this in second. So I'm dividing it by 60 per second. Am I clear? So I have calculated the material removal rate for this from here, which I understand this one. So this becomes my unit as mm cube per second. Just input this value. Over here on this side, I'm having 10 Newton meter per mm cube. 10 Newton meter per mm cube. So I'm inputting this value as 10 Newton meter per mm cube equal to cutting power, which I want to find out, calculate in watt Newton meter per second. And down there I need to input this whole value, ये जो आपने लिखी है 0.2, 0.3, 5,000 divided by 60. So in mm cube per second. So units are matched. So from here I think I can calculate this value. How much is that? So it turns out to be cutting power कितनी आ गई मेरी? It will be cutting power will be equal to how much? You have got, some of you have got 60 watt, that is Newton meter per second. Clear? Yes. Oh, good, right? So this is how. So in this case, he will play with the units. So don't get confused with this. Simply write, since he has written the units this way, so sometimes you will get confused, but write the definition part of the specific, how you have defined the specific energy, which you know that amount of power that is needed in order for the 1 unit of material removal rate. So that is the cutting power divided by material removal rate. That becomes my specific energy. So if you are able to write it, then you can set the units accordingly. It becomes easy for you. Okay. So this is how you have to attempt this question. Not only in this shaping, he has framed the question in drilling also on similar lines once. I think milling also. I'm not pretty sure, but yes, I remember exactly about the drilling process where he has framed the question on this line. Okay. So let's go to the next one. Okay. I think we have for drilling also. Just go ahead. I hope if we have done that, this earlier question, you will be able to attempt this one also. On the similar lines, only thing is that you have to calculate the material removal rate correctly, and I think your job will be done. Material, okay, he's asking only material removal rate, so then it becomes pretty easy. Okay, go ahead. Exactly on the similar lines. So here you are having a drill. Right? What is saying? 10 mm hole is being drilled. That means diameter of the hole that is being 10 mm is being drilled in a mild steel block with 500 rpm. Speed is 500 rpm of the drill rotational frequency. Anyway, this is speed he is talking about, and drill feed. Now, you know, feed we is talking about is the 0.2 mm per revolution. Material removal rate. See, two things I need, like we did in earlier case. If I know the feed velocity in the direction of cutting, my job becomes easy. So, do I know? Obviously, I know the cross section area which is being cut. ये cross section area जो कि मैंने cut करना है, right? And if I know the feed velocity, then I think I can find out the material removal rate. So, what is the feed velocity which he has not given? So, this feed velocity I can find out if I know feed per revolution of this tool multiplied by revolution per minute. I can find it out. So, if I can find it out, the material removal rate can be found out from here. That is the cross section area over here. That is pi by 4 d square. This and the, in this case, this velocity of this cutting tool, right? This is not the cutting velocity. Keep it in mind. Cutting velocity will be tangential. It will be cutting on the periphery, right? And through these edges also. But the feed velocity in this direction, perpendicular to this cross-section area, is this one. So this is important for me, not the cutting velocity. So that is why I need this feed velocity. So what is this feed velocity I have written over there? That is F into N. Now what is the cross-section area? Pi by 4. What is D? D kitna? 10 square into feed per mm. Mm per revolution multiplied by, he's asking me to calculate meter mm cube per minute. So I'm writing it in terms of 500. So obviously it is going to be mm cube per minute only. So how much is that? 0.2 500. Okay, that is, it is I think 7850. Okay, mm cube per minute. 7853. Okay, you calculated it. ठीक है, 7850. I have calculated 7850 mm cube per minute. Maybe very near to you. 7850. You have calculated 7853 also. But anyway, it's very close. Okay. Now this is what next question is basically. If you see, if you are having that problem, he has extended the same question and he is asking to calculate what? If you see the question number 61. So I want to just relate it over here. He has given you the specific energy consumed in the process is 1.5 joules per mm cube. The power consumed in the process in watt is. Isn't it the same like we did in earlier example? So he has given you the question. So what he has given you, I'm just solving the next question over here only. Or you need to remember this one then. Okay, I will go to the next one. On the similar lines, what you need to do, he is asking you to, for the problem given in the previous question, is the specific energy consumed. Specific energy he has given is 1.5 joule per mm cube. Again on the similar lines. So, and then you need to find out the power consumption in watt, right? So remember this value. So we'll go to the next and then I will solve it over there. Consumption rate, right? So let's go to the next question then. So what he's saying on the similar lines like you're having. Specific energy consumption is equal to cutting power divided by what? Material removal rate. So material removal rate, I need to be mm cube per second if I'm taking it as Newton meter per second. And over here he has given me as a Newton meter per mm cube. This value he has given me a specific cutting energy 1.5. So over there I have already calculated this cutting power I want to find out in Newton meter per second. So this value he has given me, you just calculated how much was that? 7850. So 7850 if I divide it by 60, so this becomes mm cube per second में मेरी value आ गई है, right? And cutting power I want to calculate in Newton meter per second. And over there I'm matching the units because I have matched these units with this. So over here you're going to have 1.5 Newton meter per mm cube. It's just a game of these units. Just cutting power you are going to get, multiply it, how much you are going to get. I think give me the value 196.5 24 Newton meter per second. That is what? As simple as that. Just yes, okay, good. Clear? So this concept that you have, you can apply to any particular this process, cutting process, whether it is a shaping, planing, or whether it may be drilling or milling also. So he invariably basically try to juggle these similar concepts to the different cutting processes, right? Sometimes he will ask in drilling, sometimes he will ask in milling, sometimes he will ask in shaping and all that, right? So bas the only thing is that you have to keep it in mind, units में गड़बड़ नहीं करनी है, that is all, right? और बेसिक जो अंडरस्टैंडिंग है आपकी जो है दिस स्पेसिफिक कटिंग एनर्जी की, दैट यू हैव टू उसको ध्यान रखना है, राइट? ओके, लेट्स मूव ऑन टू द नेक्स्ट नाउ. ओके, go ahead with this question. This is okay. This is now related to some questions related to your this. Okay, try to answer this. B. Some more answers. Okay, give the answer. Be fast. लिमिट फिट्स जो टॉपिक है, ऑलवेज ड्रॉ इमीडिएटली. ये होल है, राइट? लेट्स से दिस इज द टॉलरेंस ऑफ होल, दिस इज शाफ्ट, टॉलरेंस ऑफ शाफ्ट. Right? So if you want to have interference fit, okay, for interference fit, if you want to have the interference fit always, then what do you have to do? ये जो शाफ्ट है आपका किसी भी हालत में होल से छोटा नहीं आना चाहिए, राइट? इफ यू वांट टू हैव द इंटरफेरेंस फिट, तो जो दिस शाफ्ट जो है आपका किसी भी हालत में in any case should not be smaller than this. It means to obtain this interference fit, the smallest possible shaft could be this, largest possible hole could be this. So the lower limit of the shaft should always be greater than what? Highest possible limit of this hole. Only then you can have the interference. If you want that always interference should exist, then शाफ्ट, छोटे से छोटा शाफ्ट जो है वो बड़े से बड़े होल से भी बड़ा होना चाहिए. ये मतलब हुआ इसका. तो क्या मतलब हुआ इसका? इसका मतलब है दिस वन, छोटे से छोटा शाफ्ट क्या हुआ? लो लिमिट ऑफ द शाफ्ट शुड ऑलवेज बी ग्रेटर देन द हाईएस्ट लिमिट ऑफ द होल. सो लो लिमिट ऑफ द होल नहीं, द लो लिमिट ऑफ द शाफ्ट शुड, दिस इज द लो लिमिट ऑफ द होल, द शाफ्ट, लो लिमिट ऑफ द शाफ्ट शुड बी द, ये हाई लिमिट ऑफ होल है, should be greater than the upper limit of the hole. You will always going to have interference. Interfere करेगा आपका shaft hole के साथ. Am I clear? So D, why you are giving the answer D? Am I clear? So to have always interference, draw करो immediately, it becomes clear. So it means in this situation always you are going to have, अगर ऐसी situation exist कर रही है, you are always going to have the interference. Am I clear? Okay. Let's go ahead now. Limits, fits and tolerances में immediately draw करो. The only option that you are having, हवा में वो नहीं करना है आपने. Immediately draw those, this information को आप pictorially present करो. You are going to have the solution. Immediately आपको solution मिल जाएगा. Go to this, through this question. इट इज पॉसिबल टू ड्रिल ए नॉमिनल होल टू एक्यूरेसी ऑफ दिस, आपको दिया गया है शाफ्ट है, ये शिफ्ट नहीं है, शाफ्ट इज टू बी मशीन टू ऑब्टेन ए क्लियरेंस फिट in the bow hole in such a way that, now it is clear in this case that you are basically, you need to have the clearance fit such as that allowance should be this much. मतलब clearance fit अगर है, he is talking about the clearance fit, तो clearance fit में तो क्या होगा, आपका शाफ्ट हमेशा छोटा ही होगा. This is your hole, शाफ्ट किसी भी केस में छोटा ही होगा. ये सिचुएशन है. So a shaft is to be machined to obtain a clearance fit in above hole such that the allowance should be 0.01 mm. Now पहली बात तो ये है कि it is possible to drill a hole. तो let's say मुझे नहीं पता कितना है, but okay, minimum limit कितनी हो जाएगी 25 point this 98 24.98, right? Am I clear? क्योंकि 25 minus 0.02, so this will become 24.98. so ये तो होगी मेरी लो लिमिट ऑफ किसकी, होल की. हाई लिमिट कितनी हो जाएगी, हाउ मच इज गोइंग टू बी 25.02. ये मेरी, दिस बिकम्स माय हाई लिमिट ऑफ शाफ्ट, oh sorry, hole, I'm talking about the hole. He has given you this one, plus minus 0.02. now और शाफ्ट की बात कर लेते हैं. शाफ्ट की बात करें तो उसने कुछ ऐसा स्पेसिफिक नहीं दिया है, बट व्हाट इज गिविंग यू इज अलाउंस. आपको चाहिए एक तो क्लियरेंस फिट एंड द अदर वन ही सेइंग अलाउंस. अलाउंस, व्हाट इज अलाउंस, व्हाट इज अलाउंस? अलाउंस इज द डिफरेंस इन द मैक्सिमम मटेरियल लिमिट्स. ध्यान रहे, अलाउंस इज द इंटेंशनल डिफरेंस केप्ट बिटवीन द मैक्सिमम मटेरियल लिमिट्स ऑफ द बोथ द मेटिंग पार्ट्स. व्हाट इज द मैक्सिमम मटेरियल? मैक्सिमम मटेरियल लिमिट का मतलब क्या है कि चाहे होल है चाहे शाफ्ट है, व्हेन उस होल और शाफ्ट के ऊपर मैक्सिमम मटेरियल लगा है. तो मुझे बताओ कि मैक्सिमम मटेरियल, जस्ट टेल मी, शाफ्ट के केस में मैक्सिमम मटेरियल कब लगा होगा? यू विल से जब सबसे बड़ा होगा, जब सबसे बड़ा होगा शाफ्ट, तो मैक्सिमम मटेरियल लिमिट तो शाफ्ट की ये है, क्योंकि इस कॉरस्पॉन्डिंग टू दिस साइज इसमें मैक्सिमम मटेरियल लगा होगा. इवन दिस पोर्शन इज ऑल्सो देयर. टॉक अबाउट द no. मैक्सिमम मटेरियल लिमिट्स के बीच का डिफरेंस लो आप पहले. सो व्हाट इज द मैक्सिमम मटेरियल लिमिट फॉर होल? होल के केस में कौन सी ऐसी सिचुएशन है व्हेन आपको मैक्सिमम मटेरियल लगा हुआ मिलेगा? तो यू विल से जब शाफ्ट सबसे छोटा होगा, जब आपने शाफ्ट को मशीन नहीं किया अभी, और इट कॉरस्पॉन्ड्स टू द स्मॉलेस्ट पॉसिबल साइज. सो व्हेन होल इज कॉरस्पॉन्डिंग टू लोएस्ट लिमिट ऑफ द साइज and shaft is corresponding to the highest limit of its size, then ये बोलूंगा मैं, this corresponds to the, this size corresponds to the maximum material limit of the hole, this size corresponds to the maximum material limit of the shaft. तो इसको आपने कैसे ध्यान रखना है? मैक्सिमम मटेरियल लिमिट का मतलब क्या है? होल के केस में मैक्सिमम मटेरियल कब होगी? जब वो सबसे छोटा होगा. जब आप उसको बड़ा करना शुरू कर दोगे तो ऑब्वियसली क्या होगा, उसका साइज जो है वो मटेरियल क्या होना, कम होना शुरू हो जाएगा, बिकॉज यू स्टार्ट ड्रिलिंग. शाफ्ट के केस में कब होगा? मैक्सिमम साइज होगा, एंड व्हेन यू स्टार्ट टर्निंग इट देन साइज विल डिक्रीज. तो साइज क्या हो जाएगा? डिक्रीज हो जाएगा, उसका मटेरियल जो कम होना शुरू हो जाएगा. सो दिस हाउ वी, सो इट मींस फॉर मी द डिफरेंस बिटवीन द मैक्सिमम मटेरियल लिमिट्स इज अलाउंस व्हिच ही हैज गिवन मी, दिस वन. एंड मैक्सिमम क्लियरेंस शुड नॉट बी मोर देन 0.08 mm. और मैक्सिमम क्लियरेंस कब होगी? टेल मी व्हेन यू आर गोइंग टू हैव द मैक्सिमम क्लियरेंस. मैक्सिमम क्लियरेंस तब होगी जब शाफ्ट सबसे छोटा बनेगा और होल सबसे बड़ा बनेगा. सो व्हेन शाफ्ट कॉरस्पॉन्ड्स टू दिस साइज एंड होल कॉरस्पॉन्ड टू दिस साइज, तो ये जो आपका जो बनेगा, तब आपको जो मैक्सिमम क्लियरेंस मिलेगी. शाफ्ट सबसे छोटा, होल सबसे बड़ा, तो शाफ्ट सबसे छोटा बनेगा ये इतना, होल सबसे बड़ा बनेगा ये, तो ये इतना गैप आएगा आपको, मैक्सिमम पॉसिबल गैप आएगा कितना? हाउ मच इज दैट? 0.08 mm. समझिए? इफ यू आर एबल टू डिस्प्ले दिस इंफॉर्मेशन, योर जॉब इज डन. अब क्या चाहिए आपको, बोलता है द टॉलरेंस ऑन द शाफ्ट इन mm शुड बी, टॉलरेंस इन द शाफ्ट, मुझे नहीं पता ये टॉलरेंस है शाफ्ट की, लेट्स से दिस इज x, कितनी आएगी, व्हाट इज द टॉलरेंस ऑन द होल, वो आप पता कर सकते हो, क्यों, बिकॉज आपको दिया है SM25 प्लस माइनस 02, तो टॉलरेंस ऑन द होल इज दिस मच, सो दिस साइज माइनस दिस, सो ये क्या है, प्लस माइनस का मतलब है जो टॉलरेंस आएगी आपकी ये क्या है 0.04 है, प्लस 0.02 माइनस 0.02, तो कितना रेंज है ये, दिस बिकम्स 0.04, अगर अदरवाइज ऑल्सो देखना चाहते हो 25.02 माइनस 24.98, इट बिकम्स 0.04. That's all. So if you have displayed the information, the job become simple now. क्या पूछ रहा है, मुझे x निकालना है, टॉलरेंस ऑन द शाफ्ट इन mm निकाल लो, सो ये टोटल 0.08 है, x plus this should be equal to 0.08, so from here x plus 0.01 plus 0.04 should be equal to 0.08, आपके सामने है, this much plus this is already given you, तो x क्या आ जाएगा आपका 453 0.03 mm, that's all. डन हो गया काम आपका. सो वट एवर द जो भी इंफॉर्मेशन आपको दी है उसको क्या करो, डिस्प्ले करो, दैट्स इट बिकम्स इजी. जो चीजें आपने समझी हैं, अलाउंस क्या होती है, टॉलरेंस क्या होती है, क्लियरेंस के मैक्सिमम क्लियरेंस क्या होती है, सिंपली यू हैव टू बताना ही है, आपने दिखाना है बस, उसके बाद जो ये जॉब बिकम इजी. क्लियर, बढ़े, ओके डन. लेट्स गो टू द नेक्स्ट नाउ. Okay, just see this particular question and try to answer. आपको पता है प्रिसीजन और इसमें yes, accurate और प्रिसीजन में डिफरेंस पता होना चाहिए. You can solve it. जो भी है then all is in diameter only. Why? Because जो भी इंफॉर्मेशन होगी वो तो डायमेंशन तो आपका डायमीटरली है ना. We show it on one side. हम जो है वो एक तरफ शो करते हैं, बट है तो डायमीटरली है. Okay. Predict the characteristics of data given below. If the true measurement is this. Okay. इसको आप ही आंसर कर लोगे. लेट्स से एक एक्यूरेट डेटा और प्रिसाइज डेटा के लिए ये एक डायग्राम बनाया जाता है. लेट्स से दिस इज एक्यूरेट, प्रिसाइज. So let's say ये डिफरेंट डायमेंशन, जस्ट एक पिक्टोरियल रिप्रेजेंटेशन. ये टारगेट साइज है. लेट्स से एनी वैल्यू जो मैं ऑब्टेन करना चाहता हूं, यू गेट द वैल्यूज अराउंड दैट. इसका मतलब है एक्यूरेट. इफ आई वांट दिस डायमेंशन एंड इफ आई गेट द वैल्यूज अराउंड दैट, मे बी क्लोज टू दैट, I will say it is accurate. When we say precise, let's say target dimension ये है, but जो मेरा actual component sizes बन के आ रहे हैं वो ये आ रहे हैं. हो क्या रहा है, अब देखो कंपेयर करो इससे. लेट्स से ट्रू मेजरमेंट मुझे चाहिए दिस 0.3 mm, जो कि ये है और ये है. अगर मेरी ऑब्जर्वेशन वैल्यूज ऐसे आती हैं कि 0.29, 0.28, 0.295 अगर आती हैं तो वो वैल्यूज यहां होंगी. अगर वैल्यूज मेरी ऐसे आती हैं 0.23, 0.24, 0.22 और समथिंग अराउंड दैट, अवे फ्रॉम दैट, बट ऑल वैल्यूज आर क्लोज टू दैट, दैट इज आपने कहा 0.24, 0.25, 0.22, 0.23, दे आर क्लोज टू ईच अदर बट दे आर अवे फ्रॉम द टारगेट वैल्यू, देन आई विल से दैट इज द प्रिसाइज. Okay, so I hope now you got this idea. 0.33 had it been accurate तो आपका क्या होगा, ये डेटा यहां होना चाहिए, बट देखो डेटा कहां है, they are close to each other but they are away from the target value of 30. It means target value is this but there is away from this where you are going to get these values. इसका मतलब ये जो डेटा है मेरे पास, this is not the accurate data. Had it been accurate data then these values should have been 0.29, 0.28, 0.27 or maybe like 0.295, 0.285, something that way. But it is not that way. It is away but they are close to each other like this one. So it means this data is precise, about data is precise, ये case, but not accurate. Okay, good. So this is going to be the case. But go ahead with this. 65. I think all of you must be able to answer this one. This is not something difficult. I think most of you will be able to. Maximum material limits, straightforward है. Plus minus this. So shaft है आपका. Maximum material limit क्या है? Maximum size, as simple as that. ये directly we cannot say maximum size. Okay, then it will be wrong interpretation for the whole, right? So ये. So 30 plus minus 0.8. So कितना आएगा? 29.2. ये मिनिमम और मैक्सिमम कितना आ जाएगा आपका? 30.8. ये maximum limit and minimum limit for this particular shaft. So he is asking you to calculate the maximum material limit of the shaft. Maximum material limit of the shaft is the maximum size. Maximum size क्या है इसका? 30.8. So 30.8 is going to be the answer. Option C, 30.8 mm. So I think जो आपको मिले होंगे क्या कहते हैं earlier those that soft file which you may have downloaded, यहाँ पर सेंटीमीटर गलती से लिखा हो, उसने already printed वैसे ही है in those NPTEL assignments. So I think there it is centimeter, but anyway there is a typing mistake from their end. But anyway I have corrected it over here. It is 30.8 mm. Okay, done. Okay, let's go ahead. I think this is basic question, so you must be able to answer that one. So in limit fits and tolerances, you are going to have the different grades of tolerances, right? So how many grades of tolerances are there in ISO system? As per ISO system, you are having different grades of tolerances and they are going to have different values. So you're having total 18 grades of tolerances and we denote them with IT01, IT0, then it starts with IT1 and then IT2 and goes on till IT1, 2, 3, 4, 5 and IT16. So if you see, these becomes total 16, this and plus 2, these two. So total becomes 18. So these are the 18 grades of tolerances as per the ISO system of limits and fits. And to calculate that values, we calculate the value of that tolerance value based upon this, and you are having these values. So for the exam, you need to remember those values, particularly I think from IT2, IT1 or 2. From here, you need to remember those values because sometimes he doesn't provide those values directly to you. So remember those values, it is easy to remember. So right now, I think I forgot to mention those over here. Otherwise, I think this is 24i, something this is 16i, 24i, sorry, 25i and something that way. Just remember those values, okay? So easy to remember also. They are in a sequence pretty till IT16. They're not difficult to remember. So because sometimes he can directly, he will not give you the value and simply based upon he will give you the grade and a tolerance grade, and from there you need to calculate the particular value. Okay, done. Now go to the next. Okay, this question will check your understanding. Just go through this question and let's see. All of you try this question. In an automobile industry, during the inspection of a drilled hole by the inspector, the go gauge enters the hole. What should be preliminary decision? क्या डिसीजन लोगे आप? एक्सेप्ट, इसके बेसिस पे क्या हम एक्सेप्ट कर दें इसको? Right. So can't say, unlike we check no goes also. See, based upon directly केवल to check a dimension whether it falls within that particular those limit, low limit and high limit, I need to make use of two gauges. I cannot take decision based upon single gauge. दो gauges की requirement होगी. For example, ये आपका this is your hole and this is the tolerance limit. Whether that hole कब correct होगा? When it will be less than this, इससे नीचे बनेगा और इससे ऊपर बनेगा. So go gauge तो आपको बता देगी कि यहां से वो it goes inside. Go gauge, this is go gauge. Let's say if it goes, it means ये साइज जो इससे बड़ा है तो यही मैं चाहता हूं कि this gauge should show if it goes inside the hole, it means वो hole इससे बड़ा है और इससे बड़ा ही होना चाहिए. बट क्या ये गेज आपको ये बताएगी कितना बड़ा है? क्या ये इतना है, इतना है, इतना है, इतना है, इससे बड़ा है? नो. It means this gauge by itself cannot tell you whether the hole is correct or not. For the hole to be correct, इससे छोटा भी तो होना चाहिए. It has to be less than that. So this will be checked by what? No-go gauge. So that means you have to make use of no-go gauge. Means if that gauge does not go through this, it means that is lesser than this. It means go gauge and no-go gauge combined together will decide. दोनों का काम जो है, go का है जाना. If it goes, part is okay. And no-go gauge, if it does not goes, then part is okay. So it means both combined together will decide whether the part is okay or lying within these two limits or not. It means based upon this one gauge, I cannot decide. This question could be framed for no-go gauge also, right? So it means this is going to be, I cannot decide at this juncture based upon single gauge only. Okay. Okay. So let's go to the next question now. Okay. Again, as I told you, immediately draw the information. If you draw it, your job will become easy. Okay. So just draw this information. 0.7, you're saying 0.7, 0.7, 0.7, 0.7. Okay. Sorry. Given are the dimensions for the hole size this and the size of the shaft is this, what will be the allowance for this assembly? Allowance हमने देख लिया maximum limits के ऊपर size. So this is obviously 25 और वो size छोटा है. So can I say this is 24.25 point maximum limits की बात करेंगे तो hole के लिए 24.8. Am I correct? 24.8 hole का size minimum जो है 24.8 mm, maximum कितना हो जाएगा? 25.2. I may not be requiring and shaft जो है वो 24.1. 24.1 is maximum, right? 24.1 is maximum. Something this way. So 24.1 ये इसी से काम चल जाएगा मेरा. बट एनीवे मिनिमम लिमिट भी अगर शो करना चाहोगे तो -0.1. तो 23.24 minus 0.1 23.9 ये मिनिमम साइज आ गया. व्हाट इज द अलाउंस? अलाउंस इज द डिफरेंस बिटवीन द मैक्सिमम लिमिट. मैक्सिमम लिमिट फॉर शाफ्ट इज ये सबसे बड़ा मटेरियल लगा हुआ है, ये कब लगा हुआ है मैक्सिमम मटेरियल, जब ये सबसे छोटा है, तो ये साइज, ये मेरी अलाउंस है। डिफरेंस बिटवीन द मैक्सिमम मटेरियल लिमिट्स कितना हो गया 24.8, 24.8 minus 24.1, this becomes equal to 0.7 mm. No, preliminary result means what? Final result calculate करने के लिए they have not given me any other information. ठीक है ना? So preliminary मतलब how will you decide? Initially how will you decide? To find the final result, I need to have the information. वो information he has not given me. To find the final also, let's say if he say final, so am I in position to find it out? I'm not in position because information दी नहीं है कि he has not mentioned anything about the this no-go gauge. So whether it is preliminary or final, it carries no meaning for me because no-go gauge, he's not talking about no-go gauge. Okay. 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 So now we are getting into the this industrial engineering portion. So let's go to the this section now. For the given annual demand carrying cost, okay, just try to answer this one. For a given annual demand carrying cost will, this is the question. अगर एनुअल डिमांड दी है आपको तो कैरिंग कॉस्ट जो है वो क्या करेगी, इंक्रीज करेगी विद इंक्रीजिंग नंबर ऑफ ऑर्डर्स, नंबर ऑफ ऑर्डर्स, दिस इज नंबर ऑफ ऑर्डर्स प्लेस पर एनम, डिक्रीज विद इंक्रीजिंग नंबर ऑफ ऑर्डर्स. ट्राई टू आंसर दिस, गिव मी द आंसर. एनुअल डिमांड दी गई है तो कैरिंग कॉस्ट क्या होगी, इंक्रीज होगी अगर नंबर ऑफ ऑर्डर्स इंक्रीज करेंगे हम, या डिक्रीज होगी नंबर ऑफ ऑर्डर्स इंक्रीज करेंगे, या अदर वे अराउंड. बी. Okay, good. So okay, you know carrying cost क्या है, the cost to carry the that inventory. So let us say अगर मैंने 1000 आपका let's say 1000 आइटम जो है वो परचेज करनी है पूरे साल में, राइट. सो आई हैव टू ऑप्शन, या तो ब्रेक कर दूं मैं 100 करके खरीदूं, समथिंग दैट वे, और आई मे गो फॉर 500. Which one will be good in terms of carrying cost? So if I purchase them, if number of orders I will increase, then if I will increase the number of orders, then obviously to carry them, because when I will get 100, they will also be consumed. They will also, it means the time for the inventory will decrease. Time for those items to stay in inventory will decrease. तो इसलिए हम क्या करेंगे, नंबर ऑफ ऑर्डर्स इंक्रीज करेंगे तो कैरिंग कॉस्ट कम हो जाएगी. व्हाई? बिकॉज दे विल आल्सो बी कंज्यूम्ड कंटिन्यूअसली. बट अगर मैं क्या करूं, number of orders, if I decrease the number of orders, then consumption rate here as well as here is same. So number of items that I'm holding in the inventory or carrying in the inventory will be more. If more are the number of items in my inventory, I have to spend more to maintain them. So it means it will decrease. Carrying costs will decrease with increasing the number of orders. अगर number of orders increase करूंगा, so I'm getting only that much quantity which is required at the same time consumed. But अगर if I purchasing in large quantity, small number of orders, then inventory carrying cost will increase. तो इस केस में increase होगी less number of orders में, large number of orders में it is going to decrease. Okay, done. Okay, let's go ahead now. So go ahead with this. Okay, so this is the problem that you are having. Basically क्या है ये, economic order quantity for gradual replenishment model है ये. This is not a basic model that we have studied. Basic model आपको, you already know, this is the basic model where consumption rate is there, but we don't have the production rate. इसमें production rate नहीं है, production rate is infinite. Immediately when you order the quantity, the whole quantity reaches and it starts consuming, something that way, right? So you're having economic order quantity for gradual replenish model. ये model आपने जो है discuss किया होगा. Now in this case, economic order quantity, how do you calculate? So economic order quantity EOQ in case of gradual replenish model is equal to 2DC0 divided by CC into 1 minus C dash divided by P. I hope you know this. So in case of basic economic order model, you are having this formula in the form of simply CC. ये formula है. So this is for the economic order quantity for the basic economic order quantity model. But in case of gradual replenishment, you are having additional term in terms of production rate P, right? So ये same formula रहेगा, but ये additional term आ जाता है इस केस में. Now we need to set the units. Keep it in mind, if I'm keeping it demand, I'm inputting this value as demand, annual demand. Then this is the order cost per order. Then carrying cost also I have to input in per year. That is the okay, let me just input that information over here, and then I think it will be better. Okay, just use this information. A manufacturer is able to produce 8,000 bearings per day. So ये consumption rate है आपका, no, production rate है. So that means manufacturer is able to produce. That is, produce mean production rate P. P he has given you 8,000 bearings per day. The manufacturer receives an order of this bearing per day. जो आपका ऑर्डर है कितना है, 6,000 का है. प्रोड्यूस 8,000 bearing एंड मैन्युफैक्चरर रिसीव्स एन ऑर्डर ऑफ दिस. इसका मतलब ऑर्डर क्वांटिटी जो है आपकी कितनी है, दैट इज 6,000 bearings पर डे. सो कैन आई से दैट जो ऑर्डर क्वांटिटी है डिमांड, एनुअल डिमांड, वो कितनी होगी, बिकॉज 6,000 every day he require and working days are how many, 300 working days. So total जो annual demand आ जाएगी आपकी, क्या आ जाएगी वो, I can say हर दिन कितना कंज्यूम करता है, every day he is consuming, not consuming, but that means he need 6,000 and for regularly he need, and that for how many days, 300 days. So I can say 6,000 per days is the order and every day he has to supply this much. And since for the year, if we assume the year of 300 working days, then total quantity that you have to supply is this much. So ये मेरी annual demand आ गई. Okay, and the cost of keeping the bearing in stock is 20 per year. Cost of keeping the bearing in stock is 20. That means this is the carrying cost. So कैसे है ये carrying cost? You know how are the units of carrying cost? Rupees per unit per year. That means एक यूनिट को पूरा साल कैरी करने की कॉस्ट कितनी है. कैरिंग कॉस्ट इज अ ₹20. दैट मींस आई कैन से रुपीस, इतने रुपीस है टू कैरी वन इन यूनिट थ्रू आउट द ईयर. तो अगर मैं एक यूनिट को, इफ आई कीप वन यूनिट विद मी थ्रू आउट द ईयर, तो मुझे एडिशनली ₹20 खर्च करना पड़ेगा. दैट इज द मीनिंग ऑफ दिस कैरिंग कॉस्ट, एंड दिस इज हाउ वी रिप्रेजेंट दिस, रुपीस पर यूनिट टाइम. व्हाट अबाउट द ऑर्डर कॉस्ट? ऑर्डर कॉस्ट इज पर ऑर्डर. इस केस में पर प्रोडक्शन रन कॉस्ट क्या है ये, आइदर वी से सेटअप कॉस्ट और पर प्रोडक्शन कॉस्ट, और समटाइम्स वी आल्सो कॉल्ड एज ए ऑर्डर कॉस्ट. तो ऑर्डर कॉस्ट पर ऑर्डर कितनी होगी, आई कैन से दिस इज अ ₹50 या तो 50 लिख लो, रुपीस पर ऑर्डर. बात एक ही है, या पर प्रोडक्शन रन, मीनिंग इज सेम. दैट्स ऑल. अब बोलता है कि फाइंड आउट द इकोनॉमिक ऑर्डर क्वांटिटी. नाउ वी हैव दिस इक्वेशन. क्या टर्म मुझे ये पता है, ये पता है, ये पता है. आई डोंट नो द कंजम्पशन रेट. सी कंजम्पशन रेट क्या है? इफ आई आस्क यू व्हाट इज द कंजम्पशन रेट हियर, कैन यू टेल मी व्हाट इज द कंजम्पशन रेट? कंजम्पशन रेट क्या है आपका? जो डिमांड है. कंजम्पशन रेट कहां से निकालोगे? पूरे साल की डिमांड इतनी है, अगर मैं डिवाइड कर दूं नंबर ऑफ डेज से, दैट विल गिव मी द कंजम्पशन रेट, कि हर दिन इतना कंज्यूम होगा. दैट इज द कंजम्पशन रेट. सो इफ आई वांट टू से डिमांड, ये क्या, ये कंजम्पशन रेट है, बोल सकते हो आप, ये भी कंजम्पशन रेट ही है, फर्क ये है कंजम्पशन रेट क्या पूरे साल का है। बट इफ आई वांट टू फाइंड आउट कंजम्पशन रेट पर डे कितना आ जाएगा, आप बोलोगे 6000 जो यूनिट्स हैं, दैट इज इन इटसेल्फ इज अ कंजम्पशन रेट। मैन्युफैक्चर रिसीव्ड एन ऑर्डर ऑफ 6000 बीयरिंग्स पर डे, मतलब मैन्युफैक्चर को 6000 यूनिट का सप्लाई करना है हर दिन, इसका मतलब है इनडायरेक्टली ये क्या है कंजम्पशन रेट। सो इफ आई वांट टू फाइंड आउट द कंजम्पशन रेट, आई आल्सो नो कंजम्पशन रेट इज दिस इज द 6000 यूनिट्स पर डे, ये आपका कंजम्पशन रेट ही है, और बीयरिंग्स ये बोलना है आपने। सो कंजम्पशन रेट पर डे इतना है, तो पूरे साल में कितनी कंजम्पशन होगी, मल्टीप्लाई नंबर ऑफ डेज, ये वही है। अब आते हैं यहां पर इसमें हाउ यू आर गोइंग टू इनपुट दिस वैल्यू डिमांड। अब नाउ एक चीज ध्यान रखनी है इस फॉर्मूले में, सी कंजम्पशन रेट एंड प्रोडक्शन रेट इसके यूनिट सेम होने चाहिए। फॉर एग्जांपल इफ आई एम टेकिंग द कंजम्पशन रेट और प्रोडक्शन रेट पर डे, तो कंजम्पशन रेट भी मेरा जो सी डैश डिनोट करना हो, दिस हैज टू बी इन पर डे ओनली। सो इसके यूनिट एंड इसके यूनिट दे हैव टू बी सेम, दैट इज व्हाई आई जस्ट wrote it in terms of per day, otherwise I could have done this way also. This is also consumption rate, फर्क ये है कि पूरे साल का consumption rate है ये, right? Per year इतना consumption rate है, but okay, since production rate is per day, so I can write it in per day also. So per day, that means they have to be same. And when I am having this demand, let us say if I am inputting, ये तो order cost per order है, तो it's hardly going to make a difference, but ये और ये में I need to check. When I am inputting this value in per year, demand per year, then I should input this value as rupees per unit per year. If I am inputting demand, I can call this consumption rate demand also. I can also call it as demand. पर ये demand क्या होगी, आप बोलोगे demand of every day. Demand of every day, I am calling it consumption rate also. So if I am inputting this demand per day, then this value carrying cost has to be taken in per day. So इसका और इसका यूनिट जो है मुझे मैच करना पड़ेगा, ठीक है, और ये कम यूनिट मैच करना पड़ेगा, और दिस इज ऑलरेडी इन पर ऑर्डर, सो आई एम नॉट बॉदर्ड। क्लियर? सो दैट इज व्हाई नाउ इनपुट दिस वैल्यू। सो यू आर गोइंग टू हैव EOQ is equal to 2DC0. So 2DC, D mean demand, annual demand. If I am to go annual, then I will keep it in annual. So annual is 6000 into 300 multiplied by ordering cost per order कितनी है, एक ऑर्डर को प्लेस करने की कॉस्ट कितनी है, 50 है, दिस 50 डिवाइडेड बाय कैरिंग कॉस्ट, सो रुपीस पर यूनिट पर ईयर, इट हैज टू बी पर ईयर बिकॉज आई एम टेकिंग इट इन ईयर। सो 20 into 1 minus C dash consumption per day और डिमांड पर डे हाउ मच इज 6000 डिवाइडेड बाय प्रोडक्शन पर डे, हर दिन कितना प्रोड्यूस करती है वो कंपनी, दैट इज 8000 पर डे, 8000 per day. Yeah, that's all. Now this is going to give you the quantity which you can get it. I think it is going to come out as what, 6000 units. So ये economic order quantity है, then this is the quantity that you need to order each time. हर बार आपको जो है कितनी करनी पड़ेगी, इतनी क्वांटिटी ऑर्डर करोगे अगर, let us say if you will order this much quantity each time, then the total cost is going to be minimized. That is the meaning of economic order quantity. Clear? So एक चीज ध्यान रखनी है इसमें, कंजम्पशन रेट और डिमांड इज सेम ओनली डिफरेंस इज हाउ यू आर पुटिंग इट। अगर पर डे के हिसाब से कर रहे हो तो कंजम्पशन रेट आइदर पर डे और डिमांड पर डे बोल सकते हो आप। एनुअल बेसिस पे मल्टीप्लाई विद नंबर ऑफ डेज दैट यू आर गोइंग टू हैव इन वर्किंग डेज, बता रहा है 300, ही इज गोइंग टू गिव यू द वर्किंग डेज मेंशन करेगा वो आपको। क्लियर? सो एज सिंपल एज दैट। सो सिंपली जो फॉर्मूला है EOQ का बेसिक इकोनॉमिक ऑर्डर में डिफरेंस यही है, ये टर्म नहीं है बेसिक इकोनॉमिक ऑर्डर मॉडल में, rest is same. Okay, so now let's go to the next one. Okay, go through this. In a manufacturing firm, the annual demand of the product is this. Annual demand कितनी है? So you have been given annual demand. Now, how will you differentiate? How will you come to know whether this is a basic economic order model or the जो gradual replenishment model है? So in gradual replenishment model, he must have given you the production rate. वो production rate देगा definitely आपको। इस केस में देखना, इस क्वेश्चन में there is no production rate, he is not mentioning about the production rate. इसका मतलब है this is going to be the basic economic order model. ये वाला मॉडल जो है, जो फर्स्ट मॉडल that you discuss, right? Annual demand is 100,000, 1 लाख, यूनिट्स पर ईयर। यूनिट प्राइस ऑफ द प्रोडक्ट, ये प्रोडक्ट की कॉस्ट सी से डिनोट करते हैं हम रुपीज पर यूनिट। आई डोंट नो वेदर इट विल बी रिक्वायर्ड और नॉट, बट एनी लेट्स से इन्वेंट्री कैरिंग कॉस्ट पर ईयर। देखो इसने देखे रखी है इन्वेंट्री कैरिंग कौन सी है, सीसी, दैट इज रुपीज पर यूनिट पर ईयर। सो इसने 1.5 देके रखी है रुपीज पर यूनिट पर ईयर। एंड द ऑर्डरिंग कॉस्ट पर ऑर्डर, ऑब्वियसली दिस इज 30 रुपीज पर ऑर्डर। हर बार ऑर्डर करोगे तो इतना कॉस्ट लगेगी। नंबर ऑफ ऑर्डर्स टू बी प्लेस फॉर ईओक्यू इन ए ईयर विल बी, दैट मींस अगर कोई क्वांटिटी ईओक्यू ऑर्डर करते हो, इफ यू विल ऑर्डर एनी क्वांटिटी विच इज वी आर कॉलिंग एज इकोनॉमिक ऑर्डर क्वांटिटी, तो ऐसे कितनी बार जो है मुझे क्या करना पड़ेगा, ऑर्डर प्लेस करना पड़ेगा। दैट इज द मीनिंग ऑफ दिस। ऑर्डर कितना प्लेस करना पड़ेगा, सिंपल आपको पता है, नंबर ऑफ ऑर्डर्स दैट यू नीड टू प्लेस कैसे निकालते हो। दैट इज डिमांड जो है आपकी क्या है, पूरे साल की डिमांड 12,000 है, ठीक है, 12,000 इज द डिमांड ऑफ एनुअल डिमांड। और हर बार मैं कितना ऑर्डर करता हूं, 12, क्वांटिटी दैट इज ऑर्डर्ड 12, तो कितने बार ऑर्डर प्लेस किया मैंने, नहीं क्वांटिटी ऑर्डर मैं 1000 कर देता हूं। हर बार मैं कितना ऑर्डर करता हूं, 1000। एवरी टाइम आई एम ऑर्डरिंग 1000 एंड पूरे एनुअल डिमांड कितनी है, 12,000। पूरे साल में मैंने ऑर्डर करना कितना, 12,000। तो हर बार कितना ऑर्डर कर रहा हूं मैं, 12। नंबर ऑफ ऑर्डर, सॉरी हाँ, ये है कि कितने ऑर्डर प्लेस करने पड़ेंगे मुझे। ओके, लेट मी जस्ट रिपीट व्हाट आई सेड। कितने ऑर्डर प्लेस करने पड़ेंगे, 12 बार ऑर्डर प्लेस करना पड़ेगा ना। तो हर बार मैं 1000 क्वांटिटी ऑर्डर कर रहा हूं, क्यों, एंड टोटल एनुअल डिमांड जो 12,000 यूनिट्स है, तो कितनी बार मुझे 1000 के ऑर्डर प्लेस करने पड़ेंगे, 12 टाइम्स। तो हर बार मैं 1000 प्लेस कर रहा हूं, तो व्हेन आई विल प्लेस 1000 12 टाइम्स, इट विल बिकम 12,000, दैट्स ऑल। So it means if I want to find out the number of orders that need to be placed, so demand, annual demand कितनी है and कितनी quantity में order कर रहा हूं each time, उससे divide करूंगा, so that will give you the number of orders that I will place in a year, like I said over here. So can I say इस केस में कितना quantity order कर रहा हूं each time, that I don't know, so that I need to find out. उसको मैंने बोला कि ऐसी quantity order करूं which is going to minimize the total cost, EOQ. So instead of Q, I will represent with that Q star, I can represent. So can I say the total number of orders to be placed in a year will be demand divided by हर बार कितना ऑर्डर कर रहा हूं, जो कि EOQ है, Q star, right? Same formula, exactly same understanding. So now let's find out time कितना. So EOQ as per this model is going to be EOQ, that is EOQ, economic order quantity, जिसको I can denote Q star also. Every time how much I need to order so that total cost is minimum. आप बोलोगे इतना 2dc/cc, there is no production rate is not given to you. Okay, 50 you are telling, yes, okay. So economic order quantity 2 demand, annual demand कितनी है, 1,100,000 एनुअल डिमांड है, तो सीसी भी मुझे किसमें इनपुट करना पड़ेगा, पर ईयर। सो ऑर्डर कॉस्ट 30, व्हाट इज गोइंग टू कैरिंग कॉस्ट 1.5 रुपीस पर यूनिट एरिया। सो मैचिंग यूनिट्स आर मैचिंग, दैट्स ऑल। सो ये मेरी आ गई इकोनॉमिक ऑर्डर क्वांटिटी, कितनी आ रही है आपकी, 2000। सो हर बार आई नीड टू ऑर्डर हाउ मेनी यूनिट्स, 2000 units, because when I will order 2000 units, then total cost will get minimized. So I'm ordering this much. So when I will order this much, तो कितनी बार, how many times I have to place an order of 2000 units? तो आप बोलोगे पूरे साल में मैंने खरीदना है 1 लाख, so I have to purchase 1000 unit in a year, और हर बार I am purchasing a unit of 2000, तो कितनी बार मैं 2000 यूनिट्स के ऑर्डर प्लेस करूं, सो आपका आ गया ये 50 ऑर्डर्स। क्लियर, एज सिंपल एज दैट। ओके गुड, ओके गुड। सो 2000 ईओ की आपका ये आ गया, बस डिवाइड इट दिस टोटल क्वांटिटी साल में परचेज करनी है, हर बार कितनी परचेज कर रहे हो उससे इतनी बार आपको ऑर्डर प्लेस करना पड़ेगा, दैट्स ऑल। डन, ओके। सो नाउ वी कैन प्रोसीड अहेड। ये स्टेटमेंट देखो, ये बेसिकली स्टेटमेंट चेक करेगी आपकी अंडरस्टैंडिंग ऑफ द ग्रेजुअल रिप्लेनिशमेंट मॉडल। Go ahead. Gradual replenishment model, inventory model, the true statement is what? B. Max inventory level is more than reordered quantity. ये सेम ही डायग्राम था जो मैंने शुरू में ड्रॉ किया था, बट आई थिंक ये सी ये जो मॉडल है ग्रेजुअल रिप्लेनिशमेंट मॉडल, व्हाट इट सेज कि ये सिंपली ये बोलता है कि प्रोडक्शन भी साथ साथ चल रही है, कंजम्पशन भी साथ साथ चल रही है। शुरू वाला ऑर्डर जो है number of orders are not coming as integer quantity, so okay, you just keep it as a जो भी वैल्यू आपकी नंबर ऑफ ऑर्डर्स की आ रही है ना, so see he is going to give you the उसमें रेंज देगा वो डेफिनेटली, बट आपको केवल उसका ध्यान रखना है, बाकी इक्वेशन में यूज ना करें। रीजन ये है कि नंबर ऑफ ऑर्डर्स को उसमें पूरा कन्वर्ट मत कर देना, मतलब उसको राउंड ऑफ मत करना, नहीं तो वो कहीं ना कहीं आपको गड़बड़ करेगा नेक्स्ट उसमें। फॉर एग्जांपल लेट अस से नंबर ऑफ ऑर्डर्स मेरे यहां आ गए 50.5, अगर लेट अस से इफ वी इज आस्किंग द नंबर ऑफ ऑर्डर्स, लेट से वो आगे तो कोई इशू नहीं है उसमें, आपने उसमें हो सकता है उसने बोल दिया 51 ऑर्डर्स बोल दिया, अगर ऑप्शन दी है या 50 दे दिया तो ओके इट विल डू, ऑप्शन में है। बट अगर इस n को अगर फर्दर आपने कहीं यूज करना है नेक्स्ट इक्वेशन में, सो वहां पर आप इसको राउंड ऑफ मत करना, नहीं तो इसका इंपैक्ट जो गलत हो जाएगा। आई डोंट नो हाउ टू एक्सप्लेन यू राइट नाउ, या मुझे उस तरह क्वेश्चन लेना पड़ेगा कि बिकॉज जब आप राउंडिंग ऑफ करोगे ना, तो राउंडिंग ऑफ अगर मैं 51 में कर देता हूं तो एक ऑर्डर में नंबर ऑफ यूनिट का टर्म है वो दैट वैल्यू गोज इंक्रीजेस। माय पॉइंट कि अगर मैं राउंड ऑफ कर दिया तो 51 ऑर्डर, एक ऑर्डर में क्वांटिटी जो सिग्निफिकेंट होती है, सो व्हेन आई एम राउंडिंग इट ऑफ देन इन टर्म्स ऑफ नंबर ऑफ यूनिट्स दैट क्वांटिटी गेट्स इंक्रीज्ड। तो अगर मैं राउंड ऑफ करके इसको किसी दूसरे फॉर्मूले में यूज कर रहा हूं तो मेरी जो है वो द होल थिंग्स विल गेट स्पॉइल्ड, वो उसमें गलत इंटरप्रिटेशन हो जाएगी। सो ऑलवेज कीप इन माइंड व्हेन यू आर वर्किंग इन टर्म्स ऑफ नंबर ऑफ यूनिट्स, अगर वो फ्रैक्शन में आ गई है वैल्यू उतना ही पूछा है देन योर जॉब इज डन, बट इफ यू हैव टू यूज इट समवेयर एल्स देन यूज दैट वैल्यू एग्जैक्ट as it is, not by rounding it off. That is the only caution that you have to take, right? Rest अगर उसने इतना ही पूछा है then he will definitely give you either 50 51 और रेंज दे देगा, हार्डली उसमें is not the concern, उसमें कोई ज्यादा कंसर्न नहीं है, ठीक है। ओके नाउ लेट्स गो टू दिस वन। तो सी ये आपको पता है कि ये ग्रेजुअल रिप्लेनिशमेंट मॉडल है। आई विल नॉट एक्सप्लेन इन डिटेल बिकॉज इट गोइंग टू टेक अ लॉट ऑफ टाइम, बट प्रोडक्शन रेट ये है, here you are going to have consumption rate, this is production, this is inventory build up rate। so basically आपकी प्रोडक्शन और कंजम्पशन साथ साथ चल रही है, फर्क ये है कि प्रोडक्शन रेट इज ग्रेटर देन कंजम्पशन रेट, मतलब प्रोड्यूस आप लेटर से 2000 कर रहे हो और कंजम्पशन हो सकता है आपकी 1500 चल रही है, तो आप प्रोड्यूस भी कर रहे हो कंज्यूम भी कर रहे हो, सो साथ में सेविंग भी हो रही है क्योंकि प्रोड्यूस आप ज्यादा कर रहे हो, यू आर प्रोड्यूसिंग मोर कंज्यूमिंग लेस, सो सेविंग कितनी चल रही है 500, तो 500 की इन्वेंटरी बिल्डअप चल रही है जो कि ये लाइन दिखाती है। सो in this model simultaneously production consumption is going on at the same time, consumption होगी 2000 में से ये consumption होगी, ये आपके पास बच गया, so 500 500 build up होते गए and finally you are going to have the maximum inventory। so order quantity आपकी ज्यादा होगी whereas this is the order quantity, ये order quantity है इस मॉडल में, अगर आप देखोगे this is the order quantity, so this is the order quantity whereas the maximum level of inventory that you can reach at your end will not be equal to the order quantity। क्यों? क्योंकि आप कंज्यूम भी तो कर रहे थे, राइट? सो कंज्यूम कर रहे हो तो नेट इन्वेंटरी जो आपके एंड में बिल्डअप होगी ओनली लेस, तो ये मैक्सिमम इन्वेंटरी बिल्डअप होती है, बस इतना ही ध्यान रखो। रेस्ट आई थिंक इट विल टेक अ लॉट ऑफ टाइम अगर मैं एक्सप्लेन करने लगा तो। सो दिस मीन इट मींस मैक्सिमम इन्वेंटरी लेवल इज मोर देन, नो मैक्सिमम इन्वेंटरी नो ये नहीं होगा, maximum inventory level is equal, no, maximum inventory level is less, yes, maximum inventory level is less than the reordered quantity. Reordered quantity मतलब क्या है, ये जो quantity मैं हर बार ऑर्डर करूंगा इतनी, I'm going to order this much quantity each time, but actual मेरे एंड पे maximum inventory जो build up होगी वो इतनी ही होगी. Okay, so over here you're going to have the C is going to be the correct option. ये क्वेश्चन कौन सा था? 72. ओके, सो इसका मॉडल देख लो, आप क्या कहते हैं, जो आपने wherever you may have studied, डेफिनेटली आपने क्लियरली यहां मेंशन किया हो, इसका फॉर्मूला भी आता है आपका 1 - c डैश टू समथिंग, वो देख लेना आप, राइट. ओके, लेट्स गो टू द नेक्स्ट नाउ. ओके, सो हियर वी गो टू द दिस वन. Exponential smoothing forecasting method is a variant of okay. Give me the answer, jaldi. Yes. So only difference being exponential smoothing forecasting method और weighted moving average में क्या फर्क होता है कि weighted moving average हम जो most recent data को ही weightage देते हैं. We give some weights to the most recent data, whereas in case of exponential smoothing, the weights are given to all the past data, but that weight decreases exponentially. That is the only difference. For example, अगर मैं बात करूं तो let's say January, February, March, April, May, June. Let's say. So let's say 100, 110, 150, 120, 110, right? So ये डिमांड है, पास डेटा है. So in weighted moving average, depending upon 3 period, 4 period, कौन सा पीरियड ले रहा हूं, तो आप उन रिसेंट ऑब्जर्वेशन को क्या ही वेट देते हो, डिफरेंट वेट, इसको 60%, इसको 50%, 60%, 20%, 10%, दैट वे यू गिव द वेट. ओके, तो आपने जो रिसेंट हो सकता है 3 पीरियड, 4 पीरियड, जितने भी है, बट इन एक्सपोनेंशियल स्मूथिंग ऑल द पास्ट डेटा जो भी आपके पास है, सारे डेटा को आप क्या करोगे, वेट दोगे. द ओनली डिफरेंस इज कि जो वेट्स हैं वो एक्सपोनेंशियली डिक्रीज करते जाएंगे. इसको भी वेट मिला, इसको मिला, इसको मिला, इसको मिला, इसको मिला, राइट. दैट इज द डिफरेंस. सो हम बोल सकते हैं दिस इज द मॉडिफाइड फॉर्म ऑफ द वेटेड मूविंग एवरेज ओनली, राइट. सो ओके, वी सी दिस, दैट इज द B is going to the correct option. So we will see some of the numericals on that. There also we will get the clarification. Okay, I think ये आ गया मेरा क्वेश्चन. So इसमें weighted moving average का, rather he has given you the periods only. Forecast the demand for the 5th period. इस पीरियड के लिए बोलता फोकस करो. Weighted moving average method for the below given details. Consider the weights as this. अब इस केस में उसने weights दे दिए हैं और आपको कहा है कि फोकस करो इसके लिए. So forecast for the period, इस पीरियड के लिए, how much is the forecast? ये. So इन जो डिमांड है इसके लिए उसने वेट्स दे दिए हैं. सो इसमें 0.4, 0.3, 0.2, 0.1 है. सो हाउ मच यू हैव टू गिव? सो 0.4, 0.3, 0.2, 0.1. आपके दिमाग में डाउट आ सकता है कि व्हाई यू आर टेकिंग दिस वे, व्हाई यू आर नॉट टेकिंग दिस वे. ओके, आप बोल सकते हो ये 0.4, 0.3, 0.2, 0.1 ऐसे क्यों नहीं दे रहे हो? सी, क्योंकि यहां कहीं मेंशन नहीं किया कि ऐसे करना है कि ऐसे करना है. दैट यू हैव टू डिसाइड बेस्ड अपॉन द लार्जेस्ट वेटेज यू हैव टू गिव टू द मोस्ट रिसेंट डेटा. क्योंकि आप जो रिसेंट ट्रेंड जो है, यू वांट टू कैप्चर द रिसेंट ट्रेंड. तो रिसेंट ट्रेंड को ओनली यू कैन कैप्चर द रिसेंट ट्रेंड ओनली व्हेन you will give more weightage to the latest data. So that is why even if it is not mentioned here whether this way or that way, you have to give the larger weightage to the recent data. That is why I have written larger, smaller, right? And total weights, if you will see, they will come out to be as 1. Add them up, 0.4, 0.3, 0.2, 0.1. So 3, 3, 6, 4, 1. This value will turn out to be 1. Now to find out the forecast for this period, so what you need to do, multiply with these weights, this demand data, and you will get the this total value. So how you are going to get this value? This value you are going to get, multiply these weights, 45 multiplied by 0.4 plus 40 multiplied by 0.3 plus 44 multiplied by 0.2 plus 39 multiplied by 0.1. ये divided by total weight. Total weights में the sum of all these. So sum of इनको ऐड करोगे तो ये 1 ही वैल्यू आएगी आपकी. 0.4 plus 0.2 plus 0.3 plus 0.4, ये 1 आएगी आपकी वैल्यू. So simply, so this becomes the forecast as per the weighted moving average. अब weights जो हैं इस केस में तो क्या किया है, what he has done is जो भी डेटा दिया है सबको ही वेट दे दिए. It may happen that he may not give. For example, if he may have started earlier, और भी कुछ दिया होता, initial demands 30 something that way. So he will then in that case also you have to take based upon number of जो observation है for which he has given you the weight. I think we will see some example maybe at later stage also. But simply in weighted moving average, simply multiply with the weights, individual demands, and divide by the sum of this, which is going to be always 1. So it means ये value कितनी आएगी आपकी? I don't know. 42.7. I think some of you have calculated. Yes, 42.7. So this becomes 42.7. So this becomes the forecast for this period. That is the 5th period, which is asking us to calculate. Okay. Let's now move on to the next one. Simple, not anything like difficult. The forecast method which considers error forecasting for the recent data is. Give an answer. Okay, D, you are giving D, exponential smoothing method. I think you can get the idea. आपको already you know that formula of this forecast for the next period. When you calculate +1 is equal to what? Forecast for the previous period into alpha into demand minus forecast for the earlier period. Right. So ये जो portion है इस केस में ये क्या है? Error ही तो है. Error mean demand and actual forecast के बीच the difference. ठीक है? This is error. So कौन सा मेथड है इसमें जो कि आपको consider the error in forecasting. So basically this portion is error only. So this method बाकी किसी में भी ऐसे आपका है ही नहीं फॉर्मूला. Simply आप simple average और simple moving average इसमें तो simply आप average लेते हो. So it means this is the exponential smoothing method. So based on the basic formula for the exponential smoothing method for forecasting, you can make use of easily interpret. So this is going to be the D. Okay, go ahead with this. Go ahead with this question. Actual demand for fans in the month of February, March. What is the expected number of sales in April? Okay. Feb, March. दो भी this what he has given you? He has given you the demand भी दिया है और forecast भी दिया है. Forecast. So what is that? For February, he has given you the actual demand. Actual demand, this one 110 and 90. March के लिए उसने 90 दी है. Whereas forecast demands were this. Forecast demands. See, forecast demands mean forecast only. Actual demand, so you can differentiate this way. You can call this as a forecast demand. You can call it as the actual demand. Or sometimes we say simply forecast or this demand. So that means demands what? 120 and 100. ये आपका. Exponential smoothing constant दिया. What is the expected number of sales in April? April के लिए बोल रहा है. What is the expected sales? मतलब sales mean forecast. ये. What is the expected? Expected sales का मतलब क्या हुआ? What is the meaning of expected sales? The meaning of expected sales is the forecast only. Expected forecast. Oh, sorry. Expected sales mean forecast only. Okay. So now, what you are supposed to find out? Forecast. तो forecast आप निकाल सकते हो. Forecast कैसे आएगा? Forecast कैसे निकालते हो next period के लिए? Forecast for the April. Let's say if you want to find out, will be equal to, I need the data of previous month only. This. So how you write it? In terms of अगर मैं लिखता हूं forecast for March plus alpha into demand of March minus forecast of March. ठीक है मैंने? This is how you write. Forecast for next period as per exponential smoothing is equal to forecast for the previous period plus alpha into demand of previous period. Previous that is this minus forecast of previous period. ऐसे लिखते हो आप. क्लियर? तो ये तो लिखा. Previous इस केस में क्या हो गया? ये अगर next period April है तो ये क्या होंगे? They are going to be March only. So if that be the case, then you can just input these values. So how much is that? Forecast for March. Oh sorry, forecast for March कितना है 100 plus alpha कितना है 0.2 and what is demand for March? Demand March की थी 90 minus forecast for March 100. देखो कितना आया? So it is going to be you're going to have 100 minus 9 10 तो आपका आ गया ये 10 minus 10 multiplied by 2 तो 2 आ गया ये. So this is a minus 2. So ये वैल्यू कितनी आ गई? अगर कैलकुलेट करोगे तो 100 minus 2 आ गई ये. ठीक है. This is 98. Am I clear? 98 is coming. Yes. So I think somewhere there is a मुझे इसमें गड़बड़ लग रही है in terms of ये जो options हैं. He has not given the options correctly, right? क्योंकि आपका जो भी है because actual demand उसने देके रखी है. Actual demand is this 110, 90 and whereas forecast demand is 120, 100 respectively. Exponential smoothing 0.2 है आपका. What is expected number of sales in April? April के लिए मुझे डेटा चाहिए मार्च का. So मार्च का डेटा मैं यूज कर रहा हूं तो मेरे पास 98 आ रहा है. तो what I think is we are correct over here and वो क्या कहते हैं option is not correct. That is what I think. You can just cross check it, but that is how it is. मुझे option में गड़बड़ लग रही है इस क्वेश्चन में. I'm finding it some error in the options that he has provided. Okay, so that is how you have to approach. Let's move on to the next now. Okay, go ahead. I think you must be able to do it. Go ahead. A component can be produced by any of these four processes. The fixed cost and the variable cost for each of these processes are tabulated below. Fixed cost और variable cost आपको दी हुई है. Most economical process for producing the batch of 100 pieces. Total cost. So basically what you are supposed to find the most economical process. इसका मतलब मुझे total cost निकालनी पड़ेगी. I need to find out the total cost for each process. So total cost for each process is fixed cost plus total variable cost. Because ये जो variable cost है, this variable cost is per piece. So how many pieces are you producing? 100 pieces. So total cost is going to be this 20. I'm writing it over here. Okay, just take it this way so that I have space. So 20 total cost is 20 plus fixed cost plus variable cost. Total variable cost. Total variable cost means variable cost per unit multiplied total number of units. That is 3 into 100. Same way for this also. Fixed cost 50 plus variable cost per unit मतलब number of units 100. Over here 40 plus 2 multiplied by 100. Down there 10 fixed cost or 4 is the variable cost per unit multiplied by 100. So just get it 300 plus 20 320. What is that? 150. So what is the total cost is 240 and over here 400 410. That's all. So total cost is for which, so that means the most economical process is one in which for which the total cost of production is the least one, and that is the process 2. So B is going to be the correct answer. Okay, got? Only simply you need to calculate the total cost. Total cost, fixed cost plus total variable cost, because he has given this cost at per unit. So how many units you are producing? 100. So multiplied by them, 100 multiply this, add kar do fixed cost mein, the same process you adopt for all of them. Okay, let's go ahead now. ये क्वेश्चन जरा रहेगा आपके लिए नया. So इसको जो है just you learn the method how to find out the tracking signal. Okay, so I think first I will write down the information. Tracking signal, first of all, you just remember that this is a method basically to related to the forecast error. When we want to evaluate the forecasting error, उसके लिए like we are having MAD, we are having bias and other methods. One of the way is to evaluate is the tracking signal also. So how we find out the tracking signal? First, let me just write those information over here. So I think then it will become focus error. So let me just write focused error. Focused error. Forecast error. Absolute deviation. You can just write them deviation. This is a focus error. एक column मैंने focus error का बना दिया. Absolute deviation of those errors. I am just writing it over here. Then I am running sum of focus error. Running sum of focus error. Running sum of forecast error. इसको लिख लो आप. Focus error. Then MAD. You know, mean absolute deviation. Then tracking signal. So even though question has not been framed from this, but there could be some possibility that question could be framed, right? So just learn the method. It is simple because you have already done these MAD and all that you have already done. So इसलिए you can just easily grasp it. Nothing much. पहले क्या करो? Focused error. Focused error कितना है? Simply what is the error? Focused error is demand minus forecast. ये focused error है. As simple as that. So what is is it coming 4? I don't know what you're talking related to. Anyway, so what is the focus error? This minus this. What is that? 10. What is this? Minus 15. This minus this. Minus 10. This minus this 20. Simple focus error. Demand minus forecast. इसको हमने focus error बोल दिया. Okay, good. Now absolute deviation. Absolute deviation किसकी है? Error. Absolute deviation मतलब कितना फोकस्ड एरर है, बट एब्सोल्यूट वैल्यू, दैट इज ओनली दिस. एब्सोल्यूट वैल्यू कितनी है इसकी? एब्सोल्यूट कितनी है? एब्सोल्यूट वैल्यू. एब्सोल्यूट डिविएशन. डिविएशन मतलब एरर ही है. वी कॉल एरर एज डिविएशन. सो एब्सोल्यूट वैल्यू दैट मींस एग्जैक्ट वैल्यूज एज इट इज. एब्सोल्यूट वैल्यूज, पॉजिटिव वैल्यूज. अब रनिंग सम ऑफ फोकस्ड एरर. रनिंग सम ऑफ फोकस्ड एरर क्या करना है आपने? उसका सम करते जाना है. रनिंग फोकस्ड एरर ये है, इसका रनिंग सम करना है. तो शुरू में तो आपका यही आएगा. अब रनिंग सम क्या आएगा? दिस प्लस दिस माइनस 5. जैसे आप नीचे जाओ उसको ऐड करते जाओ. दिस प्लस दिस माइनस 5. नाउ दिस प्लस दिस कितना हो जाएगा? दिस माइनस 25. दिस बिकम्स 25. दिस माइनस 15 एंड देन ऐड फर्दर दिस बिकम्स 5. आई एम क्लियर? तो रनिंग सम ऑफ फोकस्ड एरर, कुछ गड़बड़ तो नहीं की मैंने? I committed some mistake. I think running sum of forecast error 20. Okay. Oh yes. That is why I committed some mistake over here in terms of this. Just remember, ये value जो लिखी थी मैंने, that was wrong. This is 110 minus 90. This was 20. This was 20. Let me just cross check ये value मैंने सही लिखी है कि नहीं. 20 minus 15, 10, 20, right? 20, 15, 10, 20. Okay, now it's okay. तो रनिंग सम अब करो. दैट मींस इस केस में फर्स्ट वैल्यू आएगी 20, फिर आपका आएगा दिस इज दिस प्लस दिस, दैट इज 5. देन ऐड करते जाओ फर्दर 5 और माइनस आपके आ जाएगी 20 माइनस 25 अगेन माइनस 5. 20 प्लस माइनस 15 माइनस 25 माइनस 5 आ गई है. एंड देन 15. I hope it is correct now, right? 25 minus 5, right? Simply add करते हैं ना. Running sum मतलब as you're going down 20, इसके लिए वही आएगा. Add this next one, this value, this plus this. Now add these 3, this, add this 4, this. अब MAD जो है आपका क्या है? MAD क्या है? Mean absolute deviation. Mean absolute deviation क्या है? Mean absolute deviation कैसे लिखते हो? ये this is a forecast error that you find out. Mean absolute deviation is equal to this mean of this divided by n. This is how you write, right? तो इस केस में भी हर एक वैल्यू के लिए आपने जो है मीन एब्सोल्यूट डिविएशन लिखना है. फॉर एग्जांपल इस केस में मीन एब्सोल्यूट डिविएशन जैसे है, एब्सोल्यूट डिविएशन 20 है, ऑब्जर्वेशन 1 है, तो 20 डिवाइडेड बाय 1, ये 20 आ गई. क्लियर? सो एज मूव टू द सेकंड ऑब्जर्वेशन ओवर हियर, दिस प्लस दिस divided by 2. Keep it mean absolute deviation. इसका मतलब हम we will belong to this row. So mean absolute क्या हुआ? 1 observation 20 divided by 1, 2 observation this plus this divided by 2. So 20 plus 15 divided by 2. 20 plus 15 divided by 2. ये 35 by 2. That means it becomes 17.5. लिख ही देता हूं ऐसे 20 plus 15 by 2. Okay. 20 plus 15, 35 by 2. 35 by 2. So that you can at least have 20 plus 30, 35 by 2. So it becomes 17.5. Okay. Then as you move next, this plus this plus this. MAD क्या देखो, this is how I hope you know mean absolute deviation कैसे निकालते हैं. So this is the way to find out the error, right? How do you write? 1 to n is equal to di into fi divided by n. ये लिखते हो ना, तो n number of observation that you are talking about. So ये absolute value that we are talking about this. So as we move on, so अब कितनी observation? This plus this plus this divided by 3. So how much is that? 30. You are having 20 plus 10. 30, 40, 45. 45 by 3. ये कितनी आ गई? 15. Same way, add them all, and you are having 4 observation. Mean values, absolute deviation 4 divided by 4. So it becomes 20, 20. 50, 65. 65 by 4. 65 divided by 4. So ये value आपकी कितनी आई? 16.25. ठीक है? That's all. अब देखो जो ट्रैकिंग सिग्नल आएगा, ट्रैकिंग सिग्नल बेसिकली इज, इसको लिख लो कहीं भी, रनिंग सम ऑफ फोरकास्ट एरर, रनिंग सम ऑफ फोरकास्ट एरर डिवाइडेड बाय मैड. क्लियर? इसका मतलब है रनिंग सम ऑफ फोरकास्ट एरर क्या है? ये divided by MAD, mean absolute deviation, जो मेरी वैल्यू आएगी. तो this divided by this divided by this, corresponding to this divided by this divided by this. Now get the values. So you are going to have 1. This is 5 divided by this से कितनी जितनी वैल्यू आई 0.285, and then you are having minus 0.33 and minus 0.923. Okay. Now what is saying? The quarter which shows the maximum positive value of tracking signal. देख लो, ये ट्रैकिंग सिग्नल है हर एक फॉर एवरी क्वार्टर. सो विच क्वार्टर शोज द मैक्सिमम पॉजिटिव वैल्यू ऑफ ट्रैकिंग सिग्नल? दैट इज क्वार्टर 1. सो क्वार्टर 1 इज गोइंग टू बी द आंसर. दैट इज द डी इज गोइंग टू द ऑप्शन. ओके, दिस मे सीम लाइक ए लेंथी क्वेश्चन इनिशियली, अभी क्योंकि आपने फर्स्ट टाइम किया. आई एम होपफुल दैट यू मे नॉट हैव डन अर्लियर, बट ओके, एक बार आप थोड़ा सा प्रैक्टिस कर लो तो आई थिंक इट इज इजी टू डू, राइट? मेथड अप्रोच देख लो कि जो ट्रैकिंग सिग्नल है जो हमने फाइंड आउट करना है, द रनिंग सम ऑफ फोरकास्ट एरर डिवाइडेड बाय मैड, ये पता होना चाहिए आपको. सो कैसे निकालना है फोरकास्ट एरर? तो आपको पता है सिंपली कैसे निकालते हो. डिफरेंस सिंपल एज इट इज विद साइंस. इसकी एब्सोल्यूट वैल्यू ले लो, दिस बिकम्स द पॉजिटिव, ऑल पॉजिटिव वैल्यू. रनिंग सम सिंपली क्या करो, किसका? ये ध्यान रखना बस, फोकसिंग एरर का, बिकॉज यहां पॉजिटिव और नेगेटिव है. तो इस प्लस फर्स्ट ये ऐड करते जाओ एज यू मूव ऑन, ऐड करते हो, ये मेरी वैल्यू आ गई. अब मैड क्या है? मैड तो आपको ऑलरेडी पता है. मैड जो एब्सोल्यूट डेविएशन की, इफ यू कंसीडर नंबर ऑफ ऑब्जर्वेशन, तो ये 20 था. नंबर ऑफ ऑब्जर्वेशन 1 है, 20 डिवाइडेड बाय 120. दिस प्लस दिस ऐड कर दो तो नंबर ऑफ ऑब्जर्वेशन 2 है. तो मीन का मतलब ये है एब्सोल्यूट डेविएशन का मीन. सो एब्सोल्यूट डेविएशन दिस प्लस दिस, तो 2 ऑब्जर्वेशन डिवाइडेड बाय 2, ये आ गई. दिस प्लस दिस प्लस दिस 3, तो आप क्या करो, डिवाइडेड बाय 3 आ गया. सो ऐड देम अप एंड दिस वे, सो मैड आ गया. सो डिफरेंस ऑफ दिस, सॉरी, ratio of this divided by MAD. So मेरी ये tracking error आ गया. He may ask you this way also, what is the tracking error? For example, we have taken 4 observation. He may give you 2 observation also only. So he may ask you what is the tracking signal for the second observation. Simple as that. आप बोलो 0.285. Okay, just see it. अगर आपको if you find it a little difficult, so take it at the last. But मुझे लगता है कि maybe some possibility exists, क्योंकि somewhere if he has to make it difficult, he may think of it. So if you find it a little difficult and lengthy and time consuming, leave it as of now. Just give priority to other areas, and when you are having time, then at that time just simply क्या करो, उसको try कर लेना. Otherwise don't, just put it on the last priority. As simple as that. Method आपको समझ आ गया, make use of that, that's all. Okay, so now we can move forward. Okay, give me the answer. This is 79. We are there in 79 now, right? Okay, scope of material management. Okay, you can answer it very easily. So scope of material management. Material management का मतलब क्या है? Material को manage करना. As simple as that. You are handling the material. So how to efficiently handle that material, whether they are raw material, whether they are component, like raw material है, semi finished goods हैं, finished goods हैं, whatever it is. तो उनको efficiently कैसे handle करना है, उसको हमने नाम दिया we are that falls under the category of material management, right? So transportation है, चाहे transportation है, transportation के दौरान how to handle that efficiently, so that also falls under that category. Procurement, खरीदना है, purchase करना है, inventory क्या है आपकी, purchasing is involved, right? Ordering cost and all those, तो क्या है वो? That is a part of procurement only, purchasing only. So that is also over there. Material management is involved. Inventory control, they are more or less related. Procurement जब भी करोगे आप तो क्या है? You think of managing those inventories. So whether inventory control की बात करते हो specifically, procurement करते हो, this and these are highly correlated. And transportation, see these all things are more or less related. The supply chain का part है ये. Whether procurement है, चाहे transportation है, inventory है, सब में क्या हो रहा है? Material के तो manage कर रहे हो. Okay, so D is going to be the correct option. 80. Reorder point in inventory indicates. I hope you know about the reorder point. In the basic economic order model की ही अगर हम बात करें, even though in that model we never discussed about that this one, okay. So in this model we were saying that we are placing the order when the quantity becomes 0, and then suddenly all the items will come immediately. The manufacturer will make immediately, and he will deliver also. So that was hypothetical situation, you know, it is not possible. But क्या करते हो आप? When you need that material before it becomes 0, you order that at some time earlier, कुछ time earlier, जिसको more than lead time, you order it over here. So reorder point, ये जो point है इसको बोलते हैं reorder point, ROP और reorder level, ROL. So it means it is the point when you are having certain inventory, when you place the new order. That is the meaning of this. So see, stock level of inventory, भाई अगर मैंने कुछ टाइम पहले ऑर्डर किया तो आपके स्टॉक में कुछ ना कुछ तो होगा. 0 तो यहां हो रहा है, 0 is getting over here. It means if you are placing the order sometimes earlier, definitely you are going to have some inventory in your stock. So that inventory level, that is how much is that inventory? This much. We call it as a reorder point or reorder level also. स्टॉक लेवल ऑफ द इन्वेंट्री, कितना आपके स्टॉक में पड़ा हुआ है जब आपने नया ऑर्डर प्लेस किया. मैंने यहां पर नया ऑर्डर प्लेस किया फर्दर क्वांटिटी के लिए जो कि इतनी है, यहां से लेके यहां तक है, जो कि आपकी डिलीवर होगी. सो व्हेन द न्यू ऑर्डर इज प्लेस्ड, राइट? Okay, so that is the C. Let's go to the next now. This one, go through this. This is 81. Okay, try it out. I think on the similar concept you are having this one. So economic order quantity he is asking me to calculate. Why I am taking this model directly? Because he has nowhere mention about the production rate. Question 80, I already answered, I think. Question 80, stock level of inventory when the, this is a C option. I think same will be discussing over here in this numerical also. This is a C option. So I will discussing over here also. So I think So because there is no production rate given to me, so only I have been given in an electric appliance showroom sells ceiling fans in 1 year. तो डिमांड क्या है, एनुअल डिमांड कितनी है? 2500 यूनिट्स पूरे साल में. एक साल में ही इज टेकिंग 52 वीक्स. द होल्डिंग कॉस्ट इज 10% ऑफ द कॉस्ट ऑफ द सीलिंग फैन. कॉस्ट ऑफ द सीलिंग फैन कितनी है? कॉस्ट ऑफ वन सीलिंग फैन इज 600. So holding cost means carrying cost. The holding cost is 10% of the cost of the ceiling fan. Cost of the ceiling fan is this. This is 10% of 600 rupees 60. ठीक है, तो ये मेरी जो आ गई, ये क्या आई? कैरिंग कॉस्ट आई. अब इसमें थोड़ा सा देयर इज अ काइंड ऑफ मिस इंफॉर्मेशन यू कैन से. It must be clearly specified that it should have been framed this way. The holding cost is 10% of the cost of the annual holding cost. I think that would have been appropriate, more appropriate. Okay, कि that annual holding cost, भाई मैंने जो 10% इसका ले तो लिया, क्या ये मंथली है, ईयरली है, what is that? So he has not very clearly mentioned. He should have very clearly mentioned that holding cost, annual holding cost is 10% of the ceiling cost of the fan. Ceiling cost of the fan is 600. So 600 of 10% becomes इतने रुपीस पर यूनिट पर ईयर. एक यूनिट को पूरा साल कैरी करने की कॉस्ट कितनी है? कितनी? This should have been the appropriate way. Otherwise ये open ended हो गया. पर मंथ लूं, पर ईयर लूं, what should I take? Okay, if that is the case, then cost incurred for placing the order is this. So ordering cost I know, 201, 201 rupees per order. There is a lead time of 5 weeks. अब अभी तो इसको लीड टाइम की बात नहीं करते हैं, जो मैं बात कर रहा था यहां पर, आई विल टॉक एट लेटर स्टेज, बट पहले हम फोकस कर रहे हैं लीड टाइम. कितनी दिन पहले आपने ऑर्डर किया बिफोर इट गेट डिलीवर्ड, दैट इज द लीड टाइम, राइट? द इकोनॉमिक ऑर्डर क्वांटिटी एंड द रीऑर्डर लेवल रिस्पेक्टिवली आर. सो पहले कैलकुलेट करते हैं इकोनॉमिक ऑर्डर क्वांटिटी. तो दिस इज द बेसिक मॉडल दैट ही इज टॉकिंग अबाउट. नो वेयर प्रोडक्शन रेट इज मेंशन, सो आई एम सिंपली द बेसिक इकोनॉमिक ऑर्डर मॉडल. सो इकोनॉमिक ऑर्डर क्वांटिटी तो आप निकाल सकते हो इजीली. इकोनॉमिक ऑर्डर क्वांटिटी क्या है? 2DC0 डिवाइडेड बाय CC. यूनिट सेम है, आप 2 into 2500 इजी. C0 जो है 201 है, डिवाइडेड बाय कैरिंग कॉस्ट पर यूनिट पर ईयर 60. इजी. वैल्यू कितनी आ गई? इकोनॉमिक ऑर्डर क्वांटिटी. हर बार कितना ऑर्डर करोगे आप? 130 यूनिट ऑर्डर करोगे, सो दैट टोटल कॉस्ट इज मिनिमम. ये तो आपका ये आ गया सिंपली, जो हमने अगले क्वेश्चन ऑलरेडी डन. नाउ ही सेइंग दैट व्हाट इज द रीऑर्डर लेवल रिस्पेक्ट. रीऑर्डर लेवल निकालना है मैंने, तो मैंने कहा था लीड टाइम दिया उसने. ही सेइंग दैट कुछ दिन पहले, लीड टाइम इज व्हाट? देयर इज अ लीड टाइम ऑफ 5 वीक्स. कि 5 वीक पहले आप क्या करते हो? लीड टाइम इज 5 वीक्स. आप ऑर्डर प्लेस करते हो, तो 5 वीक पहले ऑर्डर प्लेस करोगे. सो व्हेन यू विल प्लेस द ऑर्डर ओवर हियर, 5 वीक बाद आएगा वो, यहां पर पूरा पूरा डिलीवर हो जाएगा. सो व्हाट इज सेइंग, व्हेन यू प्लेस ऑर्डर 5 वीक्स अर्लियर, आपके स्टॉक में कितना था? आपके स्टॉक में कितना था? ये था, जिसको हमने रीऑर्डर लेवल बोला और रीऑर्डर पॉइंट भी बोला हमने. ठीक है. सो कैन यू टेल मी कि मैं कैसे कैलकुलेट करूं अगर मुझे कंजम्पशन रेट पता है इसका? तो इसको सिंपल, आई थिंक दोज ऑफ यू हु आर नॉट फेमिलियर, अगर सिंपली जो मैं आपको ये बोल दूं, बहुत सिंपल तरीके से बोलता हूं, मुझे बताओ कि ये ऐसे लिखते हैं. रीऑर्डर लेवल मान लिया, ये क्या बोलूं मैं, कंजम्पशन रेट, हर दिन आपका कंजम्पशन रेट जो है वो, सो ये क्वांटिटी आपने ऑर्डर की 100. ठीक है, ऑर्डर क्वांटिटी जो ऑर्डर की आपने 100 है. हर दिन कंजम्पशन रेट जो है वो क्या है? C डैश से डिनोट कर रहा हूं. कंजम्पशन रेट जो है आपका 10 पर डे है, और लीड टाइम आपका 2 दिन का है. ठीक है, एग्जांपल ले लिया मैंने. तो मुझे बताओ कि कंजम्पशन रेट जो है 10 दिन है. हर दिन जो ऑर्डर क्वांटिटी कर रहे हो, दिस इज द टोटल ऑर्डर क्वांटिटी, लेट्स से 100 है. हर दिन कंज्यूम कर रहे हो 10, तो कितने दिनों में कंज्यूम हो जाएगी पूरी क्वांटिटी? आप बोलोगे 10 दिनों में. ये टोटल साइकिल टाइम 10 दिन में हो जाएगा ना. हर दिन 10 कंज्यूम कर रहे हो तो 10 डेज में कंज्यूम हो जाए, साइकिल टाइम 10 है, फिर दोबारा ऑर्डर करोगे। बट उसने क्या किया, 2 दिन पहले ही ऑर्डर कर दिया। मुझे बताओ कि 2 दिन पहले जब ऑर्डर किया तो उसके स्टॉक में कितना होगा, हाउ मच गोइंग टू बी इन ही स्टॉक। अगर वो 2 दिन पहले ऑर्डर कर, अब बोलो हर दिन तो 2 कंज्यूम होना है, अगर 2 दिन पहले ऑर्डर किया, इफ ही हैज ऑर्डर 2 डेज अर्लियर, डेफिनेटली उसके स्टॉक में कितना होगा, 20 होगा। भाई 20 होगा यहां पर, जब 2 दिन पहले ऑर्डर किया है, ओनली देन यू कैन से कि 2 दिनों में कंज्यूम हो जाएगा। बाकी व्हेन इट विल बिकम 0 तो टोटल क्वांटिटी आ जाएगी 100 की, 100 जो आपने ऑर्डर की। सो कैन आई से देन दैट इफ आई मल्टीप्लाई द कंजम्पशन रेट विद द लीड टाइम, इफ आई मल्टीप्लाई द कंजम्पशन रेट C dash with the lead time, then that will give me the reorder level कि कितना था आपके स्टॉक में 2 दिन पहले जब आपने ऑर्डर किया। तो आप बोलोगे कि मेरे 10 हर दिन कंज्यूम कर रहा हूं, 2 दिन पहले मैंने ऑर्डर किया, तो व्हेन आई ऑर्डर द प्लेस दैट ऑर्डर, रीऑर्डर लेवल कितना था, रीऑर्डर पॉइंट कितना था, कितनी क्वांटिटी थी आपके स्टॉक में, आपने कहा 20 यूनिट से। क्लियर है? तो ये मेरा जो है वो रीऑर्डर लेवल आ जाएगा। तो यहां भी तो वही करना है। डू आई नो द कंजम्पशन रेट, यहां तो मैं कंजम्पशन रेट अपनी तरफ से ले लिया मैंने कुछ भी। डू आई नो द कंजम्पशन रेट, कंजम्पशन रेट पता है तो आप निकाल सकते हो। कैसे कि इफ फॉर एग्जांपल बिकॉज आई नो ही हैज गिवन मी कि पर ईयर इतना दिया है, तो कंजम्पशन रेट इन टर्म्स ऑफ पर, बिकॉज इन वीक्स में दिया तो आई कैन कैलकुलेट इन वीक्स आल्सो। तो कैन आई कैलकुलेट द कंजम्पशन रेट पर पर दिस वीक, कैन आई कैलकुलेट दैट? ऐसे भी देख सकते हैं हम। आपने 100 क्वांटिटी कंज्यूम की 10 दिनों में, 100 क्वांटिटी कंज्यूम की 10 दिनों में, तो कंजम्पशन रेट क्या था, 100 डिवाइडेड बाय 10, दैट मींस गोइंग टू 10 पर डे। बात एक ही है। सो कैन आई से टोटल क्वांटिटी डिवाइडेड बाय द टोटल टाइम। सो इट मींस इस केस में, आई होप यू हैव अंडरस्टूड दिस। सो इन दिस केस नाउ आई एम राइटिंग दिस वे, कंजम्पशन रेट इज हाउ मच, पूरे साल का 2500 है। सो इफ आई डिवाइडेड बाय इट विद द टोटल नंबर ऑफ वीक्स 52, सो ये हो गया मेरे यूनिट्स पर वीक, यूनिट्स पर वीक, ये मेरा कंजम्पशन रेट हो गया। सो इफ आई मल्टीप्लाई द कंजम्पशन रेट विद द लीड टाइम, दैट विल गिव मी द रीऑर्डर लेवल। कितनी क्वांटिटी थी मेरे एंड पे, तो रीऑर्डर लेवल इज इक्वल टू कितनी क्वांटिटी थी मेरे एंड पे 5 वीक पहले। तो यू से द कंजम्पशन रेट यू नो, एंड इफ यू नो द लीड टाइम विच इज 5 वीक्स, विच ही हैज गिवन मी समवेयर देयर, 5 वीक्स, लीड टाइम 5 दिन का है। सो आई विल कम टू नो कि हर वीक जो है दिस वाज द कंजम्पशन रेट, हर दिन इतना कंज्यूम हो रहा था, एंड मैंने 5 वीक पहले जो ऑर्डर प्लेस किया, तो टोटल क्वांटिटी मेरे पास कितनी थी, आई वाज हैविंग दिस मच क्वांटिटी। सो सी कितना है, 241 यूनिट्स, एज सिंपल एज दैट। ओके, सो इस तरीके से आप कैलकुलेट कर सकते हो। एक सिंपल एग्जांपल ले लो ये, उसे इफ यू हैव नॉट अंडरस्टूड तो यहां से आप आइडिया लगा सकते हो। ये वीक्स के टर्म, व्हाई आई टुक इट इन, आई कैन टेक इट इन टर्म्स ऑफ डेज आल्सो, पर डेज में जो है मुझे उसने पूरे साल में नंबर ऑफ डेज ही हैज नॉट गिवन क्लियरली, एंड आल्सो ओवर हियर व्हेन ही इज टॉकिंग अबाउट इन टर्म्स ऑफ डेज, उसने वीक्स के टर्म में मेंशन किया है, दैट इज व्हाई आई हैव टेकन इन टर्म्स ऑफ वीक्स। हैड ही मेंशन इन टर्म्स ऑफ डेज, आई वुड हैव डन इन टर्म्स ऑफ डेज। तो मैंने क्या कहा था, कंजम्पशन रेट टोटल एनुअल क्वांटिटी डिवाइडेड बाय नंबर ऑफ डेज ही इज टॉकिंग, तो मेरा यूनिट्स पर डे आया था, और लीड टाइम इन डेज दिया होता तो सिंपली मैं डेज में लेता, तो मेरा जो है इतने यूनिट्स आया था। दैट वे आल्सो आई कुड हैव डन। ओके, सो दिस इज हाउ यू हैव टू प्रोसीड। ओके, सो आई थिंक वी कैन प्रोसीड नाउ फर्दर। ओके, लेट्स गो टू द नेक्स्ट वन, दिस parameter used as a measure of forecast. This is not or, this is as a measure of forecast error is what? The parameter used as a measure of forecast error is, you know, cyclic value, moving average, trend value. Trend value means trend जो आप शो करते हो, मान लो पर्टिकुलर इंक्रीजिंग और डिक्रीजिंग समथिंग। मीन एब्सोल्यूट डिविएशन, फोरकास्ट एरर आपके पास 2-3 तरीके हैं। मीन जो स्क्वायर एरर, you are having mean absolute deviation, bias, these are some of the ways through which you calculate the forecast error. So this is the already we discussed, मैड मैंने डिस्कस भी किया था। So this is जस्ट सी दिस वन, फोकस कंसिडर नाइव। नाइव का मतलब होता है बहुत ही रूडिमेंट्री, बहुत ही बेसिक, वेरी एलिमेंट्री, वेरी बेसिक, एडवांस नहीं। इफ go ahead with this. Forecasts are considered naive if naive का मतलब बहुत ही बेसिक, if they are based only on past value of variables. As you know, हम क्या करते हैं, past data का यूज करते हैं to forecast, right? Quantitative ways of forecasting that we talk about. पर अगर हम क्या करते हैं, उसी के ऊपर रिलाई करते हैं, let us say, तो sometimes we can get the wrong results also. It is not always that कि डेटा के बेसिस पे जो आपका वेरिएबल है, पास वेरिएबल है, उसी के ऊपर फोकस करो, बाकी और डोंट कंसीडर अदर थिंग्स. So there are so many other things that you also, qualitative information also you need to take into account. ऐसा नहीं कि qualitative information is not good. Quantitative data definitely you have to make use of, but in addition to that, definitely you have to take the support of the qualitative data also. तो इसीलिए अगर आपका जो फोकस है दैट इज गोइंग टू बी नाइव, वेरी बेसिक, वेरी रूडिमेंट्री, अगर केवल आप जो अपना फोकस जो वो उस पास वेरिएबल्स के ऊपर ही फोकस करते हो और बाकी चीजें यू डोंट कंसीडर अदर्स, दैट इज द मीनिंग ऑफ दिस. सो ये आपका जो करेक्ट आंसर क्या रहेगा, ये रहेगा. ठीक है, दैट मींस definitely quantitative data plays a very big role for the accurate forecast, but in addition to that you need to take the other parameters into account. Even you can take the data of supporting as a this qualitative data in supporting your those this forecast, right? ये मतलब हुआ इसका. What would be your first step in the time series analysis? Just go through this. What would be your first step in time series analysis? देखो टाइम सीरीज एनालिसिस का मतलब क्या हुआ कि जो डेटा है दैट इज टाइम डिपेंडेंट डेटा है which you are having past data with you. So to analyze that data, first you need to plot that data. But we don't know because we are having two methods. One we are saying that is the constant data, other is the trend data. So how will you come to know whether it is the constant data or trend data? When you plot that data, from their data we will come to know whether there is a trend in the data or not. So if there is no trend, then we are having different methods that we use, make use of, for example, exponential smoothing and all those that we are doing. If there is a trend in the data, then we make use of the focus such as this regression analysis, etc. So first of all, I need to plot that data, and from that data, we'll come to know that what kind of data is it, and then accordingly we can choose the correct or proper tool or the method to analyze that data to forecast, right? That is the meaning of this. So पहला काम मुझे क्या करना पड़ेगा, प्लॉट करना पड़ेगा उसको ग्राफ में, so that क्या करें हम पता कर सकें whether it is a trend data or non trend data, and accordingly then we can make use of the different methods. Go ahead. आपको पास्ट 5 years का डेटा दिया हुआ है. A wholesaler observed monthly demand of mobile phones for the past 5 months as follows. ठीक है, using 3 period moving average, estimate the forecast for the month of June. Pretty simple. 3 period moving average है, simple average ही, but moving average है. Okay, so see, so first what we need to do is, जून के लिए हमने करना है, तो डिपेंडिंग अपॉन कितने पीरियड्स की बात कर रहा है, यहां पर 3 पीरियड्स की बात कर रहा है, तो व्हाट वी आर गोइंग टू डू व्हेन वी हैव टू फोकस फॉर द नेक्स्ट पीरियड, फोरकास्ट फॉर द नेक्स्ट पीरियड, लेट अस से फॉर जून इन दिस केस. सो जून के लिए जो फोकस करना है, सो व्हाट वी नीड टू डू, लास्ट 3 पीरियड्स, बिकॉज़ ये सेड 3 पीरियड, सो लास्ट 3 पीरियड्स का सिंपल एवरेज लेनी है. सो इफ आई से इट इज गोइंग टू 124 प्लस 110 plus 130 divided by number of observation is simply 3. So this become my simple moving average based upon 3 period moving average. So ये कितनी आ जाएगी, this is going to become which one is this, 85, right? So 85 it is going to be 121.33. ये मेरा आ गया forecast. So this becomes the forecast for the next period, that is for the June, based upon the 3 period moving average. He can give you based upon the 4 period moving average. तो उस केस में हम क्या करेंगे, अगर 4 period moving average बोलेगा तो मैं मीन ले लूंगा सिंपली 4 periods का. If says 2 period moving average, तो लास्ट 2 periods की जो है सिंपली एवरेज ले लूंगा. That will give you the forecast for the next period. So when we calculate the forecast based upon the moving average, in that case period must be specified, right? So here he has specified 3 periods, so I have taken the mean, simple average of 3 periods. This becomes the forecast for the next period based upon this. Pretty simple, nothing special in it. Data for 5 these have been given, right? And he has given, so I think we have already done a question, but in that question he had given the weightage to all the past data, right? But in this case I think it will be clear, depending upon for how many periods he gives the weightage. For example, he has given you the weightage only for the 3 periods, whereas he is having the data for the last 5 periods. So what is the weightage? 0.4, 0.35 and 0.25. It means we will start with the latest. जो weightage है आपकी, weightage किसमें, latest किसकी है? Highest weightage has to be given to the latest one, that is a 0.4. Then less weightage 0.35 and then 0.25. Now if you will add them up, it is going to be 1. So what is the forecast for the period of this June? June के लिए मैंने forecast निकालना है. So forecast for the period of June is going to be based upon this value which you have already know. यहाँ पर what is that value? So I can calculate that value, simply multiply them. 130 multiplied by 0.4 plus 110 multiplied by 0.35 plus 124 multiplied by 0.25. So divided by 1. 1 means if you will add them, a value 1 ही आएगी. So how much is that? This value will turn out to be 121.5. ये forecast आ जाएगा जून के लिए based upon the weighted moving average which has been given for the 3 period. वो he can give you only for 2 also, 4 also, depending upon. But whatever the weight जो भी देगा वो total weights को जब combine करोगे, its value will be 1 only. वो value 1 ही आएगी आपकी. Okay, clear? So let's move on to the next one. Following data is available. What is the average forecasting error? Even though forecasting error में जो आप discuss करते हो, ये टर्म नॉर्मली आपने सुना नहीं होगा इन द सेंस, क्योंकि हम मीन स्क्वायर एरर डिस्कस करते हैं या बोल देते हैं बायस क्या है या सिंपली मैड बोल देते हैं, राइट? ये 3 हम नॉर्मली डिस्कस करते हैं. तो कई व्हेन वी यूज सम अदर टर्म समटाइम्स वी मे गेट कंफ्यूज, बट इफ यू गो बाय दिस टर्मिनोलॉजी एवरेज फोरकास्टिंग एरर, तो सिंपली क्या है, फोरकास्टिंग एरर लो और उसका सिंपली एवरेज निकाल दो. सो दैट बिकम्स द एवरेज फोरकास्टिंग एरर. सो व्हाट इज द एरर? फोरकास्ट एरर कितना है सारी उसका? So error कितना है? forecast error कितना है? So here you're going to have values ले लो आप. This turns out to be okay. I think demand minus forecast कितना आ जाएगा ये? -15. इसका कितना आ जाएगा? -2. This is going to be 5. This is going to be 10. This is going to be 11, right? 11 और ये आ जाएगा आपका वो 20. ठीक है, सिंपल फोरकास्ट एरर. सो व्हाट इज आस्किंग मी? एवरेज फोरकास्टिंग एरर. तो ये फोरकास्टिंग एरर फॉर ऑल द ऑब्जर्वेशन, एवरेज ले लो उनकी, राइट? सो व्हेन यू विल टेक द एवरेज, सो व्हाट इज दैट? सो सिंपली एवरेज ऑफ हाउ मेनी ऑब्जर्वेशन? 1 2 3 4 5 6. सो -15, टेक एवरेज. -15 प्लस सॉरी -15 -2 प्लस 5 प्लस 10 प्लस 11 प्लस 20 divided by how many observation? 1 2 3 4 5 6. sorry, I hope it there 6. वैल्यू कितनी आई? ये वैल्यू आई आपकी 4.83. ठीक है, done. Now if I ask you one question over here, isn't it the same thing like we have in bias? bias में भी क्या करते हैं हम? यही तो है. This is just way of saying other way. Otherwise bias की बात करें, bias कैसे लिखते हैं हम? We say simply demand minus forecast without taking any mode, I is equal to 1 to n divided by total number of observation. तो यही तो है वो. This difference, this for first observation, second observation, third, fourth, fifth, sixth, तो यही तो निकाला हमने ये वाला. अब इन सबको ऐड कर दूं मैं तो ये क्या समेशन आ जाएगा इन सारी वैल्यूज का, और डिवाइड कर दो नंबर ऑफ ऑब्जर्वेशन विच इज 6, तो 22 ही तो है, isn't it? So sometimes the terminology used may be different but meaning is same. So that means average forecasting error is simply forecasting error लो, उसकी average लो, that will give you the value, and it is in actually it is bias only. So either he may say bias, अगर वो bias बोलता तब भी वही होता, और अगर simply if he is saying that average forecasting error, that is also the same thing. Okay, so ये ध्यान रखना है आपने क्या मतलब हुआ इसका. Go to next. ये आपका डेटा है मैड तो आप इजिली निकाल सकते हो. मैड वी हैव ऑलरेडी डिस्कस्ड हाउ वी कैन कैलकुलेट द मैड इज द एब्सोल्यूट डेविएशन. एब्सोल्यूट डेविएशन क्या है? व्हाट इज, हाउ डू वी राइट द मैड इज व्हाट द लाइक वी रोट फॉर बायस में हम क्या करते हैं, साइन भी लिखते हैं, बट इन केस ऑफ मैड वी टेक द एब्सोल्यूट वैल्यू फ्रॉम 1 to n डिवाइडेड बाय नंबर ऑफ ऑब्जर्वेशन, दैट इज ओनली थिंग. सो अगर मैं आपसे कहूं कि एब्सोल्यूट डेविएशन कितनी है, एब्सोल्यूट डेविएशन मींस पॉजिटिव वैल्यू ऑफ द डेविएशन. डेविएशन कितनी है 85 minus 100, तो एब्सोल्यूट कितनी आ जाएगी, एब्सोल्यूट डेविएशन विल बी पॉजिटिव वैल्यू ओनली. सो 85 minus this, नॉट minus 15 but 15 only. So minus 2, ये कितना आया 5, आई थिंक दे आर सॉरी एब्सोल्यूट ले रहे हैं तो ये वैल्यू 2 ही आएगी. 5 10 11 20, तो ये एब्सोल्यूट डेविएशंस आ गई. वहां पर हम फोरकास्टिंग एरर लिख रहे थे तो वहां साइन भी यूज कर रहे थे, यहाँ पर एब्सोल्यूट वैल्यूज हैं, दैट इज मोड का यूज करके यूज कर रहा हूं. तो अब क्या करो, मीन ले लो इनका, एब्सोल्यूट डेविएशन का मीन ले लो. एब्सोल्यूट डेविएशन मीन, तो इट मींस मीन ऑफ एब्सोल्यूट डेविएशंस. सो 15 plus 2 plus 5 plus 10 plus 11 plus 20 divided by how many observations, 6, 88, 10.5. This becomes a forecast for, sorry not focus, this is the forecast error in terms of absolute mean absolute deviation. अगर पैरामीटर आपका mean absolute deviation है, अगर उसने ध्यान रहे कई बार जो है वो लाइक एब्सोल्यूट डेविएशन, ओके लेट अस से उसने आपसे पूछा है सिंपली एब्सोल्यूट डेविएशन कितनी है, एब्सोल्यूट डेविएशन कितनी है, तो एब्सोल्यूट डेविएशन कितनी हो जाएगी. मान लिया उसने डेटा दिया टोटल और बोलता है एब्सोल्यूट डेविएशन कितनी है, तो एब्सोल्यूट डेविएशन फॉर ऑल these what we call them observations is simply the summation. but total absolute deviation कितनी हो जाएगी, सिंपली ऐड कर दो. मीन कब होगी, जब when you will divide with the number of observations. so keep it in always in mind. if you see absolute deviation simply the difference and mode of that, right. अगर टोटल बोलता है तो सिंपली ऐड कर दो, बट अगर वो मीन बोलता है then you have to divide by the total number of observations. give me the value. Okay, so go ahead and give me that value. What is that? 89. Which of the following can be possible weights of a moving average method? देखो how you will find out कि जो weights हैं that should the total should become equal to 1. अब देख लो इसमें टोटल किसमें 1 बन रहा है. Which of the following can be possible weights of a moving average, right? This is 89th. So just see where you're going to have that particular possible weights of for a moving average method. Following possible weight, obviously it is a weighted moving average, right? Fourth is 7.9. I think he has mentioned, I don't know whether we have committed mistake in writing, but keep it in mind. So this is 0.3. So when we talk about the weighted moving average में जो weights हम देते हैं तो total value should be 1. अब यहाँ पर 0.4 it is going to be 0.56, ये भी 1 आ रहा है, total is 1. And over here also 6.3, 9 plus 1. So I don't know whether we have committed a typing mistake or not. Over here if you see 0.4, 0.3, 7, 0.2, 0.9, ये value 0.9 आ रही है. So obviously this is cannot be correct. So इस case में for example I have written the answer as B, but that was I think over here there must have been some differences. I think या तो ये 0.2 होगा, that is why I have not taken it. But keep it in mind, अगर यही है let us say question, only this is a question, then both of them are going to be right. Okay, कि what are the possible weights? So इसकी दोनों का if you will see the total, this is going to be 1, total is going to be 1. So in that case this is also correct, this is also correct, क्योंकि the total weights when they are added together they are going to be 1. 0.4 plus okay, that is going to 0.6391. Okay, so that is how it has to be. Okay, I think straightforward है, बहुत वो नहीं है, but in case of exponential smoothing we have already seen ft plus 1 is equal to alpha. Okay, so how we had written that, focus plus alpha into demand minus focus, right? I can also write it this way. If you write it alpha into demand plus 1 minus alpha into ft. Okay, I can write it this way also. So if you see any of them matching with this is going to be your answer. So see, yeah, this is not minus, okay? They are the equal to. So if you see over there, so focus, if you see 1 minus alpha current demand, there is no meaning. But if you see this one, first one is the most appropriate, previous base. Basically, previous base means focus. Previous focus, what was that? So this value he is referring to, previous base, and current demand he is referring to this one. So alpha or A, whatever. So out of all of these, this one is the most appropriately which is matching with this particular equation. This is 1 minus alpha current demand. 1 minus alpha cannot be. So ये तो हो ही नहीं सकता. So current demand plus 1 minus alpha previous base. Current demand, that means dt only plus 1 minus alpha into ft. That is also not correct. So it means the only possible correct option over here is going to be this one. That means matching with this one is this one. That is equal to, forecast is equal to this one. Okay, so basically this is the formula based and only the correct interpretation. Okay, so let's say go ahead with this. Go ahead with this now. The result you're having this one is 91, right? Okay, so what is the, let's consider alpha is 0.1, base for the month of January. See, base for the month of January means what? Base mean forecast for January. Forecast for January is this one. Forecast for January. He has given you. Base mean forecast for the January is 50 units. So 50 units उसने January के लिए दिए हैं. Demand for the month of January. Demand भी दिया उसने January के लिए 60 units. What will be the forecast for the month of March? March के लिए forecast क्या है? Can I calculate it? Cannot be determined, right? क्यों? क्योंकि मुझे जो है exactly उससे previous month का चाहिए. For example, if I want to forecast for the month of March, then I need to have the forecast for the month of Feb plus 1 minus alpha. This is how it is. If I recall it correctly, कैसे है? 1 minus alpha into no. Alpha into ऐसे. Alpha into demand for Feb minus forecast for Feb. ठीक है? अब मैंने ठीक लिखा. Right. So it means I must have the forecast and demand for the previous month compared to this month for which we are forecasting. So I want to focus for the month of March, then I need to have the data of Feb at least. So data है ही नहीं मेरे पास. Or let us say for the Feb if I want to calculate, तो मेरे पास वो कोई information है ही नहीं. Feb के लिए मैं calculate भी करना चाहूँ. Can I calculate the yes, I can calculate the forecast for the Feb. फैब के लिए फोकस में कैलकुलेट कर सकता हूं, बट डिमांड फॉर द फैब इज नॉट देयर. आई कैन कैलकुलेट द फोकस फॉर द फैब, ये निकाल सकता हूं मैं फैब के लिए, बिकॉज जनवरी के लिए इंफॉर्मेशन है, बट वेयर इज द डिमांड फॉर द फैब? डिमांड फैब के लिए कहां से निकालूं मैं, विच इज नॉट गिवन, राइट? So it means I cannot calculate based upon this information. Bias by MAD is referred to as अभी हमने डिस्कस किया रनिंग सम ऑफ एरर्स. देखो हमने ऐसे लिखा था, मैंने रनिंग सम ऑफ एरर्स इज इक्वल टू DI माइनस FI, I is equal to 1 to N divided by MAD, that is tracking signal. So what was this? In one of the earlier example, that question that I discussed, this is basically simply sum of the errors. When I am taking this simply the sum of the errors, then it is basically what? Bias, right? So bias by MAD basically ये N था, right? is basically your tracking signal. यही हमने किया. रनिंग सम ऑफ एरर्स क्या किया हमने? रनिंग सम ऑफ एरर्स जब हम कर रहे थे तो क्या कर रहे थे, जैसे ऑब्जर्वेशन बढ़ा रहे थे, नंबर ऑफ ऑब्जर्वेशन वी वर आल्सो टेकिंग, सो दिस वाज द बायस ओनली. रनिंग सम ऑफ द एरर्स, व्हेन वी टॉकिंग रनिंग सम ऑफ द एरर्स, देन ऑब्वियसली इट मींस इट वाज बायस. ओके, सो व्हिच ऑफ द फोरकास्टिंग टेक्निक्स इन्वॉल्व एक्सपर्ट्स आंसरिंग? आई थिंक यू मस्ट बी एबल टू आंसर. सिंपली जो एक्सपर्ट जो टेक्निक है, वेयर वी सर्कुलेट द क्वेश्चनियर्स and where we circulate the questionnaires and ask those experts sitting at different locations, we call that as a Delphi method or Delphi technique, right? This is a qualitative, not quantitative, qualitative method of forecasting, right? So this is a forecast Delphi. So I hope what is this now? Okay, last, I think this may be the last question on this, but anyway, I think that way we have covered almost like all those which are related to this forecasting error. Almost all the areas have been covered. इसको करो जरा, just see what is this. Again ये term आपने again you have not heard, आपने एक टर्म सुना नहीं होगा, बट अगर आप इसको थोड़ा सा ध्यान दो, इफ यू जस्ट पे अटेंशन, लिटिल अटेंशन, यू विल कम टू नो परसेंट एरर, राइट, एंड मीन एब्सोल्यूट. समझ गए? तो फर्स्ट ऑफ ऑल इसको नाम दिया गया, दिस इज द मीन एब्सोल्यूट परसेंट एरर फॉर दिस फोरकास्ट इज. तो पहले क्या करो, परसेंट एरर निकालो फॉर एवरी ऑब्जर्वेशन एंड देन टेक द मीन ऑफ दैट एब्सोल्यूट एंड मीन. परसेंट एरर निकालो, उसका एब्सोल्यूट लो, फिर उसका मीन ले लो. एज सिंपल एज दैट. सो इफ आई से आई एम हैविंग दिस इज द एरर, ये ऑलरेडी उसने देके रखा है ऑब्जर्वेशंस के लिए, राइट? नाउ व्हाट इज द एब्सोल्यूट परसेंट एरर? अगर मैं बोलूं एब्सोल्यूट परसेंट एरर क्या हो जाएगा? एब्सोल्यूट परसेंट एरर. तो ये एब्सोल्यूट वैल्यू इसकी हो जाएगी, दैट इज अ ओके. बट एक चीज ध्यान रहे, दिस इज नॉट द परसेंट. ओके, परसेंट आई नीड टू कैलकुलेट. कैसे कैलकुलेट करना पड़ेगा मुझे? द एरर डिवाइडेड बाय द एक्चुअल वैल्यू. सो परसेंट एरर कहां से आएगा? सो लेट अस से परसेंट एरर आएगा, एरर इतना है डिवाइडेड बाय द एक्चुअल वैल्यू. दिस इज हाउ डिफरेंस डिवाइडेड बाय, दिस इज हाउ वी डू difference divided by the actual value. So what is that? 6 divided by 11. So do that way, 6 divided by 11, that becomes percent error. So in terms of fraction, you are going to have these, what is this value? 0.545. And what about this divided by this? Percent आ गया ना total. Difference divided by original. So difference क्या आएगा? 13 minus this becomes 6.2. 6.2 divided by 13. 6.2 divided by 13. ये कितनी आ गई वैल्यू? 6.2 divided by 13.44769. और इसकी वैल्यू कितनी आ गई? दिस minus 2.66 divided by 6 कितनी आई है? minus 0.4433. then you are having 2.86 divided by 5 कितना है? 0.572. क्या कैलकुलेट किया मैंने? मैंने सिंपली कह रहा है एरर कितना है परसेंट में, वो निकाला। एरर कितना है, डिफरेंस डिवाइडेड बाय द ओरिजिनल वैल्यू ऑफ एक्चुअल, सो डिफरेंस वाज 6 डिवाइडेड बाय ओरिजिनल वैल्यू। सी बिफोर दिस आल्सो फॉर एवरीवन, सो ही हैड ऑलरेडी कैलकुलेटेड दैट एरर, बट परसेंट एरर उसने कैलकुलेट नहीं किया है। सो परसेंट एरर, परसेंटेज एरर, एज सिंपल एज दैट। तो परसेंटेज एरर आई जस्ट कैलकुलेटेड। नाउ वंस यू आर कैलकुलेटेड, देन व्हाट इज सेइंग, परसेंटेज एरर का एब्सोल्यूट, तो इनका एब्सोल्यूट ले लो and then take the mean. So take mean. So what I'm going to do is, so I'm taking mean absolute percent error. So absolute value of all these divided by what mean? Mean how many? 4. So that is 0.545 plus 0.4769 plus 0.4433 plus 0.572 divided by 4. कितनी आई वैल्यू देखो, ये आ गया आपकी 50.93। मतलब ये फ्रैक्शन में आएगी 0.5, बट क्योंकि ये परसेंट में निकालना है मैंने, तो 50.093, दैट इज अ 50.93%। सो दिस इज बेसिकली इन परसेंट। ओके, ठीक है, तो ऐसे आप प्रोसीड करोगे। सो जस्ट इंटरप्रेट इट क्लियरली, यहीं से इंटरप्रिटेशन हो जाती है मोस्टली। आई थिंक जितनी भी फोकसिंग एरर है, इफ यू see their name, you will get the idea from that name itself. So that is why mean percent error, उसका absolute लो, percentage error निकालो। Instead of fraction, you may have calculated directly in percentage also, 54.5, 47.69, something that way. Absolute value लो और उसका mean ले लो, right? But this is new. You may not, if you have not heard, just take note of it, and he may frame the question on this line also. Okay. Okay, so just go through this question. Customer behavior in which customer leaves a queue after joining is known as. Okay, go ahead. What do you call it? So देखो, दो तीन balking जो customer behavior है, that is he behaves like a king. अगर याद रखना है आपने, king की तरह behave करना मतलब लाइन में खड़ा ही नहीं होता। Okay, reneging, this fellow, joking means he keep on shifting, so that he with the expectation that okay, he will get the service fast. Reneging, he will stand in the line. After some time he will leave the he will lose patience, and then he will leave the queue. So customer leaves the queue after join करेगा, this customer will join the queue, आएगा, patience lose कर जाएगा, थोड़ी देर बाद दम तोड़ देगा, उसके बाद निकल लेगा, right? So that is the meaning of reneging. Balking, इसको याद रखो ऐसे, king की तरह behave करेगा, लाइन में ही खड़ा नहीं हुआ, ये कम से कम लाइन में तो खड़ा होता है, right? That is how you can remember it. Okay, so let's now go to this 96. Customer arrives at a sales counter manned by a single person according to Poisson process with a mean rate आपको दिया गया है, and the only thing that you have to remember is पूरे एक तो यह कि single server model है ये, that you may have studied like MM1 and this is alpha and infinity and first in first server model है, इसी के बेसिस पे जितने क्वेश्चन फ्रेम किए जाते हैं आपके लिए. So this is also on the similar line. And एक चीज आपने ध्यान रखनी है कि जो जितना भी the whole story over here is that rates, arrival rate, average arrival rate और service rates, they are Poisson distributed. Poisson distribution किसमें है? Rates के लिए. Rates कौन से? चाहे वो arrival rate है और whether is the service rate. And जो time है, they are exponential distributed. Exponential distributed. कौन से? Time. कौन सा time? इंटर अराइवल टाइम, लाइक अराइवल रेट, तो दो अराइवल्स के बीच का जो टाइम है इंटर अराइवल टाइम है, तो दैट इज एक्सपोनेंशियल डिस्ट्रीब्यूटेड. या सर्विस टाइम है, दैट इज एक्सपोनेंशियल डिस्ट्रीब्यूटेड. तो रेट्स विल बी पॉइजन डिस्ट्रीब्यूटेड वेयर एज द टाइम्स विल बी एक्सपोनेंशियल डिस्ट्रीब्यूटेड. एंड एक चीज ध्यान रखनी है कि इफ रेट्स आर पॉइजन डिस्ट्रीब्यूटेड, वी कैन मैथमेटिकली प्रूव दैट दीज टाइम्स विल बी एक्सपोनेंशियल डिस्ट्रीब्यूटेड. ठीक है, ये बेसिक कंसेप्ट है जो आपने ध्यान रखना है. नाउ आ जाते हैं, बात करते हैं यही. तो इसका मतलब इफ यू सी सिंगल पर्सन अकॉर्डिंग टू पॉइजन प्रोसेस विद ए मीन रेट, इसका मतलब रेट क्या है? पॉइजन डिस्ट्रीब्यूटेड. ऑब्वियसली टाइम क्या होगा? एक्सपोनेंशियली डिस्ट्रीब्यूटेड होगा. सो वी डोंट नीड टू बॉदर अबाउट. सो for example, arrival rate, mean arrival rate is 20 customers per hour. ये mean arrival rate है. The time required to serve a customer has an exponential distribution. तो time तो हमेशा ही आपके जो exponential distribution रहता है. This model that we discuss, they are discussed based upon that. The time required to serve a customer has an exponential distribution with a mean of this. Now, ये जो service time है, ये क्या दिया उसने? Service time दिया है. तो service time is what? 100 seconds. So मैं इसको अगर मान लिया मिनट में बदल दूं तो ये हो गया मेरा इतने मिनट. And always, you know, जो सर्विस रेट है, जैसे मान लिया सर्विस टाइम निकालना है, मैंने सर्विस इंटर अराइवल टाइम निकालना है, तो टाइम इंटर अराइवल टाइम इज इक्वल टू 1 बाई अराइवल एवरेज अराइवल रेट एंड सर्विस टाइम इज इक्वल टू इनवर्स ऑफ सर्विस एवरेज मीन सर्विस रेट, राइट? So this is time, that is the arrival. So average mean arrival time is that is the inverse of arrival rate and mean service time is equal to the inverse of service rate. So इसका मतलब है if I want to find out the service rate, mean service rate, so it is going to be one of this. So that means it is going to be this is per minute. So hours में convert कर सकता हूं मैं इसको. So let's say hours में convert कर दो because this value is in this. So that means 100 divided by 60 into 60, right? So this becomes itne hours. So service time is this much. So service rate is going to be 1 over service time. So 1 over service time क्या जाएगा? 1 by mu. So mu is equal to 1 by service time. That is the 1 by this. So it becomes 3600 divided by 100. So ये हो जाएगा customers per hour. क्योंकि hour में था ये. So it means it becomes equal to mu is equal to 36 customers per hour. ठीक है? Now we have this information, that is the average arrival rate is 20 customer की on an average 20 customers मेरे पास आ रहे हैं सर्विस लेने के लिए और on an average मैं कितने कस्टमर सर्व कर पा रहा हूं? 36 कस्टमर. ठीक है? ये सिचुएशन है और इट इज ऑलवेज, ध्यान रखना कि इन मॉडल्स में ऑलवेज फॉर देम टू बी स्टेबल हमेशा सर्विस टाइम जो आपको आगे क्या होगा, सर्विस रेट इज गोइंग टू बी मोर देन अराइवल रेट. ओनली देन ये मॉडल जो है एप्लीकेबल है. तो इतना तो ठीक है. दिस बेसिक अंडरस्टैंडिंग आई होप यू मे बी हैविंग. नहीं है तो आई ऑलरेडी एक्सप्लेन यू ब्रीफली. सो मेरा पर्पस था अराइवल रेट पता करना एंड पर्पस वाज टू फाइंड आउट द सर्विस रेट आल्सो. सो ये मेरा सर्विस रेट आ गया, एवरेज सर्विस रेट. ठीक है? ओके, सो व्हाट आई एम सपोज टू फाइंड आउट, ही सेइंग दैट एवरेज वेटिंग टाइम कितना है कस्टमर का. तो ये मॉडल यही है जो हमने कहा. सो नाउ लेट अस फाइंड आउट द व्हाट ही सेज, व्हाट इज द एवरेज वेटिंग टाइम ऑफ द कस्टमर इन द सिस्टम. एवरेज वेटिंग टाइम ऑफ द कस्टमर इन द सिस्टम. नाउ वेटिंग टाइम जो है कस्टमर का निकालना है तो दो चीजें ध्यान रखो कि first of all remember these two formulas, that is the length of queue and length number of that way length of queue भी बोलते हैं हम इसको, या number of customers waiting in the queue and the number of customers waiting in the system. ये दो फॉर्मूले आपको याद रखने हैं और that is I'm just writing them, then I will explain. ये आपका आएगा lambda square divided by mu into mu minus lambda. Mu lambda we already know and this is lambda divided by mu minus lambda. Okay, these formulas you need to remember. क्या मतलब हुआ इसका? इसका मतलब ये हुआ कि आपका सिस्टम में हो, यहां पर सर्विस फैसिलिटी है, यहां पर आपको सर्विस फैसिलिटी है and you are waiting in the queue and someone is receiving the service. So if I will ask you waiting length कि how many on an average how many customers are waiting in the queue. क्यू का मतलब है ये जो जिसकी सर्विस चल रही है, जिसको सर्विस दे रहे हो आप, उसको छोड़ के, तो क्यू ये है. तो नंबर ऑफ कस्टमर्स वेटिंग इन द क्यू, ये इसको छोड़ के जिसकी सर्विस चल रही है. सो व्हेन यू हैव बीन आस्क्ड द नंबर ऑफ यूनिट्स इन द क्यू और नंबर ऑफ कस्टमर्स वेटिंग इन द क्यू, इसका मतलब जो वेट कर रहे हैं, जिसको अभी जिसको सर्विस नहीं मिल रही है. बट व्हेन यू विल इंक्लूड इवन दिस वन, द पर्सन हु इज आल्सो गेटिंग served, then we will say the number of customers waiting in the system. तो सिस्टम की बात होगी तो जिसको सर्विस मिल रही है वो भी उसका पार्ट हो जाएगा. देन नंबर ऑफ कस्टमर्स वेटिंग इन द सिस्टम विल बी गिवन बाय दिस. सो आई होप ये डिफरेंस आपको क्लियर पता होना चाहिए, बिकॉज यू गेट कंफ्यूज्ड ऑलवेज बिटवीन द क्यू एंड इन द सिस्टम, कि कितने कस्टमर जो क्यू में है कितने सिस्टम में है. तो क्यू का मतलब है कि एक्सक्लूडिंग द पर्सन हु इज गेटिंग सर्व, जिसको सर्विस नहीं मिल रही है, जिसको सॉरी तो उसको छोड़ के बाकी वो क्यू में है. बट अगर हम उसको भी कंसिडर कर रहे हैं जिसको सर्विस दे रहा है, वो काउंटर पे सर्विस चल रही है उसकी, उसको भी कंसिडर कर रहे हैं, तो वो हो जाएगा सिस्टम कि नंबर ऑफ कस्टमर्स वेटिंग इन द सिस्टम. तो उसको भी इंक्लूड करके नंबर ऑफ कस्टमर्स वेटिंग इन द सिस्टम एंड दे आर गिवन बाय दिस. और ये डिफरेंस इफ यू नो देन आई डोंट थिंक कि इस पर्टिकुलर इसमें जो है कोई दिक्कत होगी आपको अंडरस्टैंड करने में. अब बात रही, ये तो हो गया कितने कस्टमर वेट कर रहे हैं इन टर्म्स ऑफ वेटिंग टाइम. सो यू आर हैविंग एक लिटल्स लॉ है, लिटल्स लॉ, जहां से आप क्या कर सकते हो, टाइम निकाल सकते हो, वेटिंग टाइम. सो फॉर एग्जांपल लेंथ ऑफ क्यू इज इक्वल टू लैम्डा इज इक्वल टू वेटिंग टाइम इन द क्यू. क्यू में कितना टाइम स्पेंड किया, सेम वे. सो लिटल्स लॉ कोरिलेट द वेटिंग टाइम विद द वेटिंग टाइम इन द क्यू विद द लेंथ ऑफ द क्यू, वेटिंग टाइम इन द सिस्टम विद द नंबर ऑफ यूनिट्स इन द सिस्टम. ठीक है, तो उसमें सिंपली क्या है, लेंथ एल क्यू इज इक्वल टू लैम्डा इज इक्वल टू डब्ल्यू क्यू, एल एस इज इक्वल टू लैम्डा टाइम्स डब्ल्यू एस. तो सिंपली इफ यू नो दिस देन सिंपली आप क्या करो, मान लिया मैंने वेटिंग टाइम इन क्यू पता करना है तो एल क्यू बाई लैम्डा कर दो. वेटिंग टाइम इन सिस्टम पता करना है, एल एस डिवाइडेड बाई लैम्डा कर दो, यू आर गोइंग टू गेट इट. सो आई डोंट नीड टू रिमेंबर ऑल दिस फॉर्मूला. सिंपली अगर इनको रिमेंबर करोगे तो टाइम हम निकाल सकते हैं, बिकॉज आई नो द दिस थिंग. सो व्हाट ही हैज आस्क्ड मी, what is the average waiting time of a customer in the system. System का मतलब waiting time in the system, WS he is asking me to calculate. So if he is asking me to calculate WS, so how I can write LS by lambda. So LS if I know, if I divide by lambda, it will become equal to 1 by mu minus lambda. As simple as that. So if you remember the Little's law, then directly make use of this. That's all. So what is the waiting time? Average waiting time of the customer in the system. That means including the person who is also getting served. ये मतलब हुआ सिस्टम में. Rest just input this value and how much is that? 1 by कितना है, क्योंकि hours में है तो और में आ जाएगा ये. So it is 1 by 36 minus 20. तो ये आया आपका hours में. तो R को कन्वर्ट करना चाहो तो आप इसको मल्टीप्लाई कर दो. He has given you option in seconds. तो सेकंड का मतलब है मैं क्या कर सकता हूँ, इसको 3600 से मल्टीप्लाई कर दूं तो सेकंड्स में आ जाएगा ये. तो कितनी आई है, 6 सॉरी यस, सो इट विल बिकम इक्वल टू, ये सेकंड्स में कन्वर्ट कर दिया मैंने. होप दिस इज आर. सो इसको कन्वर्ट कर देते हैं हम 16 इंटू 3600, ये आ जाएगा आर. तो कितना हो गया, 3600 बाई 16 आ जाएगा 225. सॉरी ये सेकंड्स में आ गया ना, सेकंड में कन्वर्ट कर दिया मैंने इसको आर को. सो दिस बिकम्स 225 सेकंड. ठीक है. Okay, so this is how you have to attempt it. So I think in most of the situations you need to find out the mean arrival rate, mean service rate, find it out, and then depending upon what he is asking you, you can proceed ahead. Okay, let's go to the next one. So ये ध्यान रखना, ये दो फॉर्मूले याद कर लो, रेस्ट आप लिटिल्स लॉ लगा के जो उसको निकाल सकते हो. Okay, I think 97. Okay, we can proceed with this. An AC service find that the time spent okay, so you need to find out what he's saying, that if in an AC serviceman finds that the time spent on his job has an exponential distribution with a mean of 18 minutes. टाइम स्पेंड इसका मतलब है कि टाइम स्पेंड इसका मतलब सर्विस टाइम है ये. सो ही हैज गिवन मी द सर्विस टाइम. सो सर्विस टाइम कि उसके पास जो है एसी रिपेयर होने के लिए आता है एंड ही सर्व इट, तो सर्विस टाइम ही हैज गिवन यू. सो सर्विस टाइम कितना दिया उसने, सर्विस टाइम. सो अगर मैं इसको पर आवर कन्वर्ट कर देता हूं, क्योंकि यहां इंफॉर्मेशन पर आवर दी है, तो मैं 18 by 60, तो ये हो जाएगा सर्विस टाइम इतने आवर. And you know, if I have to find out the service rate will be equal to 1 by service time. So it becomes 60 by 18. Customer per hour. ये मतलब हो गया इसका कि इतने कस्टमर पर आवर जो है वो सर्विस करेगा आपका. Now what about the if the repair sets in the order in which they come in, that means first in first out model है आपका, and if the arrival of the set is approximately Poisson with an average of this, that means arrival rate obviously Poisson distributed, the rest time जो आपके जो है क्या होंगे, they are going to be exponential distributed. So average arrival rate is 3 per hour. तो 3 कस्टमर पर आवर आ रहे हैं. That's all. ये इंफॉर्मेशन मेरे पास आ गई. So average arrival rate मेरे पास आ गया and average service rate भी आ गया. Now what he is saying, the serviceman works for 8 hours a day. 8 घंटे काम कर रहा है. What is the serviceman's expected idle time each day? हर दिन idle time कितना होगा? So पहले तो ये देख लेते हैं यूटिलाइजेशन कितनी है. जो रो है that is average utilization, how much basically जो आपकी capacity है that is getting utilized. So you can say that how do we know? Lambda by mu. This is how it is. That is, this is the this much time, that probability that this much time that serviceman is busy. तो ये क्या आ जाएगी? Mu by lambda, मतलब आपका आ इतना रहा है, देखो सी lambda is this much customer is coming, whereas आपका सर्विस रेट इतना है, तो एवरेज फैसिलिटी यूटिलाइजेशन कितना हो गया? 3 डिवाइडेड बाय व्हाट? 3 डिवाइडेड बाय mu कितना हो गया? 16 18 और 60 by 18 divided by 60 कितना हो गया ये? So it comes out to be 0.9. That means this is the percentage utilization. What he's saying that what is the serviceman's expected idle time? ये तो busy time आ गया. Probability that this serviceman is busy is the 90%. 90% time क्या है वो? Busy है. इसका मतलब idle time कितना होगा? Idle time of serviceman कितना होगा? Idle time जो होगा, idle time निकालना है, तो idle time will be what? 1 minus rho. This is the idle probability that is going to be idle 10% time, that is 1 minus rho into हर दिन जो है 8 hours का डे है, तो if I multiply by 8 hours, so this is going to be the total time. 8 hours is the total time. Out of that 10% time क्या है आपका? वो idle है. So this is going to be 0.1 minus 0.9 into 8. That is obviously 0.1 into 8. So आपका क्या आ जाएगा ये? 8 जो hours है. So this is going to be 0.8 hours. So in terms of what he has given, minutes में दिया है उसने, कोई भी minutes में है rest. So you can multiply 0.8 multiplied by कितने? Hour mean this minute 60. 4.8 48 10 48 minutes. ठीक है. So basically what you did, let me just rewind. First ये तो almost more or less आपको करना पड़ेगा हर बार. You have to find out the average service rate, arrival rate. इस केस में he saying that serviceman जो है basically 8 hours working day है उसका, and he is asking to find out the expected idle time क्या है. So if you are able to find कि how much time he is busy or how much time basically he is utilizing himself, तो ये जो average utilization जो आप निकाल सकते हो इससे. If you are able to find out that this 90% he is busy, then obviously 10% he is going to be idle. So if you know that out of the total 8 hours, if 10 hours 10% is idle, then obviously this 1 minus this becomes 10% times, that is 0.1 multiplied by 8, this becomes the idle time for this, right? Okay, so let's move on to the next one. Just see, for obtaining optimum, just go through this. For obtaining optimum service capacity in a queuing system, we need to, okay, I think this is a very basic question. Queuing system में आपका ultimate objective क्या है? What is the ultimate objective in the waiting lines? In waiting lines, ultimate objective is to minimize the service cost as well as the waiting line cost. So waiting line दोनों को minimize करना है आपने, combine together, because you cannot have unlimited service capacity or you cannot have unlimited length of the line. तो उसमें customer भाग जाएंगे. So what you have to do is capacity को भी आपने क्या करना है? Manage करना है as well as line को भी आपने short करना है. So basically minimize waiting as well as the service cost, right? So ये queuing model में, waiting line model में आप line भी छोटी रखना चाहते हो, साथ में आप बहुत ज्यादा capacity, बहुत ज्यादा counter, let us say if you are in a this what we call is a mega store, so you cannot have a n number of these over there counters, तो आप उनको भी कम से कम रखना चाहते हो. At the same time you also want to minimize the waiting line also, ताकि line बहुत लंबी ना लगे. So our objective is to minimize both of them. Okay, so I will come to this question after taking this question. Just go through this question first. In a tool crib, worker comes to take tools 4 hours on an average. So ये क्या दिया हुआ है? टूल क्रिब का मतलब है एरिया जहां से आप टूल कलेक्ट करते हो. यहां से द वर्कमैन विल गो एंड फ्रॉम दिस एरिया ही विल टेक द टूल्स, राइट. तो इसका मतलब है इस टूल क्रिब पे, इस एरिया पे जहां से टूल कलेक्ट करने हैं, 4 hours on an average, takes tool at 4 per hour, comes to take tools at workers come. इसका मतलब है एवरेज अराइवल रेट कितना है आपका? 4 वर्कर्स पर आवर. ये मतलब हुआ कस्टमर्स पर आवर बोल लो, जो बोलना है आपने इस केस में, क्योंकि सर्विस फैसिलिटी टूल क्रिब है और जिसमें कस्टमर जो है आपका कौन सा है? वर्कर है, पर आवर. ये आपका अराइवल रेट है. वेटिंग फॉर देम कॉस्ट ₹10 पर आवर. ठीक है, तो वेटिंग बोलता है कितना आपका कॉस्ट कर रहा है? ₹10. अगर आपका कोई भी वर्कर है वहां पर वेट कर रहा है तो 1 घंटा वेट करने के लिए आपको जो ₹10 जो है कॉस्ट आएगी. वेटिंग फॉर देम कॉस्ट ₹10 पर आवर. सर्विस टाइम पर वर्कर इज इन द टूल क्रिब इज 12 मिनट्स. मतलब वो जाएगा तो सर्विस टाइम कितना है? सर्विस टाइम इज 12 मिनट्स. तो आज मैं लिख दूं 12/60 इतने आवर्स. आई हैव टू कीप द यूनिट सेम. So if service time is this, then आपका service rate, average service rate is 12/60/12, 1 by service time. That means this becomes 5 customers per hour. तो सर्विस रेट जो फैसिलिटी का है, किस रेट पे सर्विस कर सकता है या टूल दे सकता है? दैट इज 5 customers per hour. अराइवल इतना है. What will the waiting cost of the worker per day? वेटिंग कॉस्ट कितनी होगी पर डे के बेसिस पे इफ इट इज 8 hours a day? तो पहले क्या करते हैं हम? वेटिंग कॉस्ट पर आवर अगर निकाल दें तो आवर जॉब बिकम्स 0. तो वेटिंग कॉस्ट पर आवर निकालने के लिए पहले हमें देखना पड़ेगा कि ऑन एन एवरेज हाउ मेनी वर्कर्स आर वेटिंग इन द सिस्टम. भाई जो यहां पर टूल क्रिब में जो दिस योर वर्कर हु इज वेटिंग हियर, वो तो वेट ही कर रहा है जब तक उसको सर्विस कंप्लीट नहीं होगी. ही इज आल्सो वेटिंग. सो इट मींस फॉर मी व्हाट इज इंटरेस्टेड, कोई मान लिया वर्कर है, जब वो आया टिल द पॉइंट टाइम ही गेट सर्विस, तब तक वो लाइन में ही था. टिल दैट मींस फॉर मी इंपॉर्टेंट इज द वेटिंग टाइम इन द सिस्टम, कि वो जो वर्कर आया उसने सिस्टम में कितना टाइम वेट किया, तभी तो मुझे पता चलेगा कि हाउ मच दिस कॉस्ट इज इन्वॉल्व, कि वो कितना टाइम वेट किया. और हर घंटे की कॉस्ट में ₹10 है. सो इट मींस आई डोंट नॉट ओनली नीड टू फाइंड आउट द वेटिंग टाइम इन द, so basically I don't need to find out the मतलब कितने जो on an average कितने जो these workers थे वो क्यों मैंने इंपॉर्टेंट नहीं है मेरे लिए. ऑन एन एवरेज कितने वर्कर्स सिस्टम में वेट कर रहे थे. ऑन एन एवरेज हाउ मेनी वर्कर्स वर वेटिंग इन द सिस्टम, क्योंकि जब तक वो सिस्टम में तब तक वेट कर रहा है, और जब तक वेट कर रहा है यू आर गोइंग टू हैव दैट वेटिंग टाइम कॉस्ट. सो इसका मतलब है आई नीड टू फाइंड आउट फर्स्ट हाउ मेनी बेसिकली workers were waiting in the system, not in the queue. Queue पे find out करूंगा तो I am excluding the time which is spending while getting serviced. So इसका मतलब है length, number of customers waiting in the system और number of workers waiting in the system, that is in the tool crib, not in the queue. So वो हमने already last question में किया था, that is lambda by what was that? Lambda by mu minus lambda. ये था. ठीक है, ठीक लिखा मैंने. दिस वाज दैट, राइट. ठीक है, ओके. सो नाउ फ्रॉम हियर आई विल कम टू नो ऑन एन एवरेज हाउ मेनी वर्कर्स आर वेटिंग इन द सिस्टम. ये पता मैंने कर लिया. तो हाउ मेनी इज दैट? लैम्डा यू नो 4 डिवाइडेड बाय व्हाट इज दैट? 5 minus 4 वर्कर्स और कस्टमर, जो भी बोलना है आपने, वर्कर्स. सो ऑन एन एवरेज मुझे 4 वर्कर्स जो है वो वेट करते हुए मिलेंगे व्हेन आई विल गो टू द टूल क्रिब. सो ऑन एन एवरेज 4 वर्कर्स विल बी वेटिंग इन द सिस्टम. तो अब देखो वेटिंग टाइम कॉस्ट इज ₹10 पर आवर. तो अगर मान लिया हर घंटे की कॉस्ट ₹10 है, तो ऑन एन एवरेज 4 वर्कर्स आर वेटिंग इन द सिस्टम, then waiting time cost कितनी होगी? waiting time cost will be equal to how much? On average 4 are waiting, and for her in each hour, so that is per hour, so it means rupees 40 per hour. But if I had to calculate the same on the basis of per day, so since there are 8 hours per day, so waiting time cost on the basis of per day. So in one day, how many hours are there? This 8 hours, so multiply by 8. So that means 8 multiplied by 40. So that means rupees 320 per day. So this is the waiting time cost, you can say, for the workers. ठीक है? So what I did is simply, वो बोल रहा है कि कितनी कॉस्ट है, तो सिंपली पहले ये पता करो कि ऑन एन एवरेज हाउ मेनी वर्कर्स आर वेटिंग इन द सिस्टम. क्यू पे नहीं, अगर क्यू पे लेंगे तो आपका सिस्टम पे व्हेन ही वाज गेटिंग सर्विस्ड उसको एक्सक्लूड कर रहे हो, उस टाइम को एक्सक्लूड कर रहे हो आप. सो यू कैन नॉट एक्सक्लूड दैट. सो दैट इज व्हाई आई नीड टू कैलकुलेट द नंबर ऑफ वर्कर्स वेटिंग इन द सिस्टम. आई एम नॉट कैलकुलेटिंग द नंबर ऑफ वर्कर्स वेटिंग इन द क्यू. अगर क्यू पे कैलकुलेट करूंगा तो फिर मेरा गलत हो जाएगा, राइट? बिकॉज देन आई एम एक्सक्लूडिंग दैट टाइम व्हिच इज while I was getting service. जब मुझे सर्विस मिल रही है वो ही तो कुछ टाइम होगा. How much is that? So I am not calculating that. Okay, I hope you got it. Let's now go to the last one. So if this is done, I think that will make it easier for you to go for it. Okay. No. On an average, देखो जो भी ऑब्वियसली वो तो वेट करना ही पड़ेगा. यू हैव टू वेट, ऑल द वर्कर्स हैव टू वेट. रीजन बीइंग सर्विस टाइम जो है, आप सी बेस्ड अपॉन, वी आर कैलकुलेटिंग बेस्ड अपॉन द प्रोबेबिलिटी, राइट? कुछ टाइम ऐसा हो सकता है कि खाली पड़ा मिले, बट ये एवरेज वैल्यू कैलकुलेट कर रहे हैं हम. इट इज नॉट द पॉइंट टू पॉइंट वैल्यू, वी आर कैलकुलेटिंग द एवरेज वैल्यू, प्रोबेबिलिटी बेसिस पे निकाल रहे हैं. कुछ टाइम हो सकता है खाली पड़े हों, बट व्हेन वी से ऑन एन एवरेज हाउ मेनी कस्टमर्स वर वेटिंग in the queue when I went over there, you find 4. So that is the probability that these many customers or those workers may be waiting over there. Are you getting? So it is not that waiting line में हमेशा ये रहता है आपका, हो सकता है कई बार पूरी बहुत बड़ी लेंथ हो, कई बार स्मॉल हो, कई बार हो सकता है खाली भी हो. But this is on an average value based upon the probability that we are calculating. Right? Okay, go to this particular question now. Machine fails at 4 per hour and the cost of non-productive machine is this per hour. Repairman charges 100 rupees per hour and repairs at 5 per hour. तो इसका मतलब repairs at 5 per hour, इसका मतलब है जो सर्विस रेट ये है आपका, and fails at this, इसका मतलब अराइवल रेट कितना है? 4 per hour. मशीन जो है 4 मशीन फेल हो रही है पर घंटे के बेसिस पे, and on an average, ये आपकी वैल्यू एवरेज वैल्यू है, ध्यान रहे, राइट? सो म्यू इज द एवरेज सर्विस रेट 5 पर आवर, तो इतनी जो है सर्विस रेट है आपका. नाउ रिपेयरमैन चार्जेस 100 पर आवर, तो पहले क्या करूं मैं? चार्जेस 100 पर आवर, सॉरी, द कॉस्ट ऑफ नॉन प्रोडक्टिव मशीन्स इज रुपीस पर आवर, नहीं है. तो फर्स्ट व्हाट आई नीड टू फाइंड आउट कि जो आपकी मशीन्स है, नॉन प्रोडक्टिव मशीन्स है, तो मशीन्स को कितना वेट करना पड़ेगा, राइट? कितनी मशीन जो है रिपेयर में वेट कर रही है ऑन एन एवरेज. सो नंबर ऑफ, या तो मतलब एवरेज नंबर ऑफ कस्टमर्स, एवरेज नंबर ऑफ मशीन्स वेटिंग इन द सिस्टम, एवरेज नंबर ऑफ machines waiting in the system or expected number of units in the system. Again ये सेम ही लाइन पे जैसे पीछे है, बिकॉज जो भी मशीन वेट भी कर रही है while it is getting serviced, जब उसकी सर्विस भी चल रही है उसको काउंट करना पड़ेगा. जब तक वो मशीन सर्विस पे है तब तक क्या है, वो आइडल टाइम है उसका, बिकॉज आपका जो हर घंटे जो है वो 200 रुपए जो है क्या हो रहा है, नॉन प्रोडक्टिव कॉस्ट है. सो नॉट ओनली दैट इट वाज वेटिंग इन क्यू, वो मशीन जो है नॉट ओनली इट वाज वेटिंग ओवर हियर इन क्यू, बट also the time it spent over here when it was getting serviced. So I need to find out on an average how many machines were there in the system, right? So average number of machines waiting in the system, आपने कहा on an average कितनी machines जो wait कर रही हैं, that is the length of the system. So it is lambda, it is same on mu minus lambda. So कितनी आ गई है? lambda is 4 divided by 5 minus 1, that is on an average 4 machines, you can say on an average 4 machines are waiting in the system. ओके, सो 4 मशीन वेट कर रही हैं, तो अब मुझे बताओ कि नॉन प्रोडक्टिव कॉस्ट ऑफ मशीन्स कितनी है? 200 पर आवर है, तो इट मींस अगर 200 पर आवर है, ऑन एवरेज 4 है, तो आपने जो हाउ मेनी कॉस्ट क्या होगी? नॉन प्रोडक्टिव कॉस्ट की बात करें हम, नॉन प्रोडक्टिव कॉस्ट, तो हाउ मच इट इज गोइंग टू बी? ऑन एवरेज 4, 200 per hour, so it is going to be 200 into 4, that is you are going to have 800, so that means 200 multiplied 4, so non productive cost is going to be rupees 800 per hour. so ये तो केवल है नॉन प्रोडक्टिव, किसकी? मशीन की. मशीन चल नहीं रही है, मशीन इज नॉट वर्किंग, तो ये आपकी कॉस्ट है. बट एट द सेम टाइम रिपेयरमैन चार्जेस 100 पर आवर, तो साथ में जो रिपेयरमैन जो वहां पे चला उसको भी तो आप 100 रुपए दे रहे हो, तो टोटल कॉस्ट कितनी हो जाएगी? सो टोटल कॉस्ट पर आवर इज गोइंग टू बी टोटल क्यूइंग कॉस्ट. टोटल कॉस्ट, क्यूइंग कॉस्ट मतलब लाइन पे लगे रहने की कॉस्ट जो है, टोटल कॉस्ट विल बी इक्वल टू नॉन प्रोडक्टिव कॉस्ट बिकॉज ऑफ मशीन्स व्हिच इज 800, एंड साथ में आप क्या कर रहे हो, 100 रुपीज जो है उसकी चार्जेस भी है, सो रुपीज 900 पर आवर. ठीक है, so that is how we have to approach this problem. So don't go by the exact values. ध्यान रहे, ये जो है एक्सपेक्टेड नंबर, देखो ऐसे बोलते हैं हम इसको कि दिस इज बेस्ड ऑन प्रोबेबिलिटी, नहीं तो आप फिर ऐसे बोलोगे कि आप ये जो बोल रहे हो नंबर ऑफ टोटल नंबर ऑफ यूनिट्स इन द सिस्टम इज इक्वल टू टोटल नंबर ऑफ सिस्टम इन द क्यू प्लस 1, ऐसे हो जाना चाहिए, क्योंकि हमेशा एक ही तो होगा, सिंगल सर्वर मॉडल है, तो यू विल से दिस शुड बी दिस वे, बट ऐसा होता नहीं है. सी द फॉर्मूला दैट यू आर हैविंग फॉर LS and LQ. It's not that way. This formula is wrong. Reason being, there is not one तो आप बोल रहे हो जो दिख रहा है, आपको लग रहा है कि एक ही हो रहा होगा, but when because we have calculated these values on average basis, probability basis, so I cannot simply say okay add 1 because 1 is being served, right? So that is the thing I think you have to keep it in mind. Okay, so I hope anyhow finally I just completed all those questions which I had to do within today. So I hope they are going to be helpful for you. They may have added something to your kitty. So that is all for today. I think then next session I'm going to have maybe next month. So there maybe covering. Let's see if there are some left out questions over here, and definitely the other areas also. I think from the theory of machines, maybe machine design also, and maybe some other areas which may be left out. Okay. So, okay, that's all from my side today. Thank you very much for the session. See you in the next session. Okay, good night.